Big data can be described in terms of data management challenges that, due to increasing volume, velocity, and variety of data, cannot be solved with traditional databases. In this session, you will get a complete understanding of how AWS can be used to implement various big data analytics, visualizations, and analytical techniques. Let's move on to the agenda of the session, but before that, please subscribe to our channel and hit the bell icon for more updates. Let's take a look at the agenda for this session. So we're going to start with the overview of the AWS Big Data exam, and then we'll move over to introduction to AWS Big Data, data collection, data storage, data processing, data analytics, and data visualization. After that, we'll take a complete overview of AWS Kinesis, DynamoDB concepts, a complete overview of Amazon EMR, HBase with EMR, introduction to AWS Lambda, quick hands-on on AWS Lambda, a complete overview of Glue with hands-on on Glue as well. And after that, we'll have a complete introduction to Amazon Redshift with a quick introduction to Designing Tables. So fasten your seatbelts, we'll take you on a ride for AWS Big Data.
So yeah, this is what we are going to be covering. So I'll just go through this. This is an exam guide which is provided by AWS on their official site itself, which is for the certification. So what it does is it tests your ability to see if you are able to implement core AWS Big Data services according to certain architectural best practices that they have laid down. So I'll be telling you what are those best practices regarding their architecture. And apart from that, how do you design and maintain big data? To will see the life cycle of a data. Where does it start from? What do you do in between the transformation bit? And finally, where do you store it for later usage? And certain tools that you can leverage in order to automate this data analysis process. So this is what they are going to validate your knowledge on. And there are certain recommendations, but again, as I mentioned earlier, even if you're new or if you're not cleared any sort of certification, that's not a very big thing to worry about. But as such, just to highlight this, they require you to have a minimum 2 years of experience using AWS technologies. And you should have certain idea about AWS security best practices. And you should be able to independently define AWS architecture and services and how they integrate with each other. This is what we are going to be learning in this particular sessions. And finally, define and architect AWS Big Data services and explain how they fit in the data life cycle of collection, ingestion, storage, processing, and visualization. So you'll see in the bottom of this particular page, this are the portion that we are going to be seeing: collection, ingestion, storage, processing, and visualization. These are the categorization which they have subcategories for. You can stay on this for now. Okay. I'm going to, yeah. And finally, certain recommended general IT knowledge. So they need some sort of experience in IT, which they have mentioned here as 5 years of experience, but whoever is new, don't get worried about it. It's not that much, what do you say? For your certification, you don't need this even if you don't have. Then you should have certain understanding on how do you control access to secure data. Security when it comes to AWS or any cloud, GCP, Azure, security is always a big portion. So we are going to be talking about few best practices and general things that people do to secure their data, like basic things. Again, nothing fancy or nothing very advanced, but certain basic thing which is good enough just to get started with your projects, like encryption of your data. How do you transfer data, like keep it encrypted at rest, as well as transit and things like that. Then understand the frameworks that underpin large-scale distributed systems like Hadoop, Spark, and certain data warehouses. So we'll be talking about what exactly is Hadoop, Spark, where exactly they fit into the space of big data, because this is what, like, most of the companies, at least whatever I have worked with while my tenure at AWS, almost everybody works on either Hadoop for their big data need, and for any sort of transformation, they go for all this PySpark or any kind of Scala scripts. So again, I'm not going to be teaching you how to write PySpark scripts, but where exactly you can those scripts in AWS is what I'm going to be doing. So I'm just mentioning it now itself so that there's no later confusion on what was covered and what should be covered. All my teachings, they are going to be as per the data guide or exam guide given by AWS itself. Fourth point, understand the tools and design platform that allow processing of data from multiple heterogeneous sources with different frequencies, batch versus real time. So again, big data is not just data which is like terabytes or petabytes of data. It's data which is coming with huge amount of velocity or increased velocity. And finally, you should be capable of designing a scalable and cost-effective architecture to process data. So all four things, it is not going to work well with your projects or with your company if you are just giving them the best practices, because even best practices, sometimes you have to worry about the trade-off as well. not always the shiny thing is the good thing for your project as well. You have to be cost effective or frugal at times as well. So we are going to see, or they test actually your ability, their questions. I'll show you the sample questions as well, which AWS has given themselves. So questions are scenario based in all the AWS certifications, not just this one. So they ask you question like, for an example, I have this real-time data coming in and I need to store it and save it in such a way that I'll be able to process that information in certain fashion. This will be the scenario that they'll give you, and they'll ask you what is the best tools required for this particular architecture. What things I should combine to make this work, and you'll be uh, from this training you'll understand that okay, this is for real time, this is for storing data for longer duration and things like that. So you'll write all those answers basis that. And sometimes they ask you what is the most cost effective solution. So in that case they are not asking you what is the best solution, they're asking a trade-off over here, that give me a good enough solution which is good enough for this particular scenario, but still at the same time it is cost effective. And if you're not aware about how AWS examinations are, so all the AWS examinations are multiple choice. They give you a scenario. The scenario is like what I mentioned just now. It has one or more correct options. Those are, they call those as distractors. So all those options pretty much look same. You'll feel like, okay, all the options look correct just by reading them. But there will be one correct answer, which would be the most appropriate answer. You don't want just the correct thing, correct tool to just choose as an option. They want you to choose the most appropriate as per the scenario. And they have multiple response as well, which means a question can have two or more than two correct responses as well, and you need to select all of them. There is no partial marking over here. If let's say they are asking you to choose, select 3 options out of 6 options given. If you've chosen 2 and 1 is incorrect, you'll get 0 for that particular question. And please do have the habit of guessing. There is no penalty or there is no negative marking. So even if you are not sure about anything, please do make sure that you answer all of the questions in their certification examination. Yeah, that's pretty much it. So I'll just stop for a second here and see if you have any questions. If not, I'll cover what we are exactly going to be covering. You can go for any examination. It's just your money. You're going. They have just given you that, okay, this is our foundational level certification, then this is our second certificate and things like that, associate level and then professional level. So that is the general hierarchy that they have given. But if your company is sponsoring or if you have money and you just want to appear for the certification that you're interested in, you're more than welcome to do that. It's just that you will need little more efforts from your end. If you're, let's say for an example, somebody mentioned that they have cleared cloud practitioner, that is a good thing for them. Cloud practitioner covers all the basics which are required to just get you started. So cloud practitioner is basically a fresher joining a company, and they are given a KT of like 5 days. So it's basically introduction to all the tools that AWS has. Some people find that certification very easy because it just tests your memory. It's not about anything that are you able to connect these things together to make it work and things like that. They just ask you question, I want to store data, what is the service? S3, this kind of questions. So some people skip that certification and go for certifications like this one or solutions architect or any other certification. Okay, if there is nothing, as I mentioned earlier, these are the main domains that we are going to be covering. That's what this particular certification requires. For an example, domain 1 is about collection. How do you collect data? How do you store that data is going to be a domain 2. Processing of that data is going to be domain 3. Finally, analysis of some sort on that data, creating visualization, and finally data security. So these are going to be the main domain that we are going to be covering in this certification. And I'm not going to read all this point like 1.1, 1.2. Please do read them in your own time. But this is how my content is made. As per this points, whatever is mentioned over here is going to be part of this training. If there is something missing which is written over here, you can please reach out to me and I'll give you that particular demo or whatever is required. But yeah, anything apart from this, please get the idea by yourself that that is not going to be part of this certification. There's one question over here, what is the best reading material for this? Best is again a pretty vague term. So for an example, when I cleared the certification, I didn't just prepare from one place. There were a lot of Google articles and all those things. I used all those, but I'll give you certain basics, what worked for me. Again, that is from my opinion. So don't just go ahead with it. You can have your own Quora questions. There are a lot of Quora questions, just like how you asked, what is the best reading material? Please go through those as well. But yeah, I'll definitely share what worked for me. And mostly, you don't have to go outside what AWS has already provided. That's what I recommend, at least in my classes, because people, they get very tensed and they start reading 10 different things, and at the end, it doesn't make sense to just like put too much energy into this. So whatever they have provided, for an example, their FAQs, their white papers, their documentation, it is more than enough as per me. So yeah, this is going to be agenda. As you saw in the exam guide as well, it is focused on points like what is data collection, storage, processing, analysis, visualization. They have Intellipaat, they have just taken that content itself, what you saw in the exam guide, and basis that they have curated this content for you, basis those points over here. Yeah. So introduction to big data on AWS. It's pretty fairly simple concept. What exactly is big data? This question is open for anyone. Absolutely. And that's what the Wikipedia definition about big data is as well. Kind of very related to that. So it exactly says that big data refers to the data sets which are pretty large or pretty complex to be dealt with by your traditional data processing application software. So if you're aware, the world was functioning very nicely up until all this social media came. We were pretty used to having all this relational databases, and entire world was working on those, including your banks, all those corporates, whatever. Till then we had no need of big data. All of a sudden we saw this boom in social media and everything. We saw like uh, too much too many people using internet, processing a lot of information. So there came a need of big data. Your information, because of all these things, it was coming in high velocity. Earlier it used to be like, okay, I got data from my customers and things like that. Not the entire world was sharing data. So here we have this big data which is regarding your velocity, variety. It was earlier, it used to be just your traditional databases tables. Now your data refers to images, videos, clickstream data, and whatnot, all sorts of data. So that is your variety bit. And finally, the size of data. Earlier again, it used to be few terabytes is what I've heard. People who are in this industry for 30 years and all, they can share their experience. But yeah, that's what I've heard, that earlier it was pretty much sufficient to have those kind of infrastructure in place, and that was good enough for a particular company. Right now we needed all this cloud. AWS came into picture. They are the first one who started with cloud with their offerings like EC2, S3 in 2004. And after that we saw that okay, it makes sense to have this kind of architecture because this is pretty cost effective. This deals with this problems of having this huge amount of data and things like that. So that's what big data means. If so, for an example, right now, how this is your traditional way of implementing big data, which is go to the previous slide itself. Yeah, earlier we used to have this kind of big data cluster, and this is basically your in-house compute requirement. Somebody, let's say for an example, you hired few databases or the computing requirement hardwares, whatever you needed in order to process that kind of information, and you were keeping all those things in your company itself, and somewhere from your remotely you were accessing all this clusters over here. Now after AWS and after all this cloud computing solutions, now you can go to the next slide. So we just have an abstract layer in between now, either AWS, GCP, Azure, or any other solution. They are sitting in between. They are the ones who are providing all this AWS servers or any servers. They have their own servers. We are just remotely accessing their servers, and they have given like a lot of tools, or they have basically made our life easiest to access those things. Otherwise, we needed to have in-house team of literally hardware engineers, then security engineers, database engineers, just to have a minimum viable product that you can work on. AWS has taken all that responsibility from us, and they are providing very easy kind of plug and play solutions is what I call it. So again, pretty basic stuff. It is, I think, covered in your solutions architect, but again, for the sake of completeness, we'll cover it here as well. So there are multiple advantages of using AWS. So firstly, it is fully managed, and yeah, people who have cleared certification, I would love you that you can explain this. What is fully managed versus whatever is not fully managed? What is your understanding on it? What exactly AWS refer to as fully managed? Yeah, that's the term I was looking for. Serverless. which means obviously there are servers. It's not like you are using anything without servers. Servers are there, but it is not your responsibility to handle those servers. So all that work from your head is gone, like doing the maintenance and things like that. Fully managed refers basically to that. They are the ones who is taking care of it. You just have to use that service itself. So there are certain services which are fully managed. There are certain services where there is some sort of shared responsibility. Few things you are doing, few things AWS is doing on your behalf. So that's what the fully managed means over here. Then we pay only for what we use. And this is literally, as per me, the biggest benefit after the cloud computing came into picture. So for an example, even with my very small career, I've worked with like startups like, so if you're aware, Hotstar uses AWS. They came when I was working there. They came with a very small project, and then they are what you see them now as. And apart from that, very small people who are in India, if you have heard about Chai Point, Chai Point is something that again uses AWS. They again started with few cafes in India, and now they are a big chain here itself. So again, these are example as per my experience. There could be lot n number of things as well. So all of them, they became actually this big because they were able to experiment with AWS pretty quickly. They were paying only when they were fairly small. They were not paying huge amounts of fees just to have that infrastructure in place, because they were not sure will they be able to do it or not. They were able to do it because they were paying only small chunks for doing all sorts of experimentations, whatever they did and whatever helped them succeed this much. So a lot of startups, if you do some sort of study or just Google about it, just see the amount of startups which like exponentially increased after the advent of cloud computing. So as per me, this is the biggest benefit of cloud computing, that you pay only for what we use. Again, for my experience, people like you and me, I think we wouldn't have even tried using the services. Right now, AWS provides me anybody, whoever is even a college fresher, they have the free tier and all those things, that at least come and see and use all these things. Even you can build fairly small companies using the free tier itself. Me, even I tried having a startup, and obviously it failed, but yeah, we tried it, and for around 1.5 years we were able to run it literally for free. So yeah, that's, I have focused too much on this point. So it integrates with other AWS services is another advantage, that here they have built an entire ecosystem. So for an example, a guy like me who had initial experience in DevOps, when I started venturing into machine learning, I didn't have to go ahead and learn everything from start. I can just use their plug and play solution. So for an example, my basic project was, initial project when I was starting with the machine learning, it was to build a project which was, for an example, we are having this conversation right now. My project was to have a recording of this class, and at the end of the day save it in place like S3, automatically create a pipeline which can convert this solution or whatever I am talking or you're talking into another language, let's say Spanish, and save two multiple copies of it, and finally have two different recordings of it available in different places, so that I can, if I'm planning to create a platform of my own like Intellipaat, where I'm providing you option to go ahead and see all this thing. So I just wanted to minimize effort. I'm just talking to you in English, my voice is getting recorded in n number of languages, and all the solutions. I had no idea how to do it using machine learning. They had a tool which did it for me. I just had to use that tool, plug it with my S3 solution. And that's just an example of how quickly and easily AWS services work in conjunction with each other. So that's another advantage of using big data for, or not just big data, cloud computing or AWS for your needs. And another one is obviously instantly scale up or down. And it pretty much goes with pay only for what you use, I think. So whenever you have requirement, for an example, let's say there is Super Bowl going on, or some sort of World Cup match, FIFA World Cup or something going on, and you are a streaming platform. So you don't want to pay for all those charges that you're going to be incurring during those peak times. You need to have that flexibility, that whenever I have this kind of requirement, let's say from 1 million customers to I am going to expect 2 million customers, I am only able to pay when that peak period is there. Whenever I don't have that requirement, I should be able to discard all those resources and pay only for that initial resources which are required for 1 million customers. So AWS gives you this option of having the capability of scaling up and down quickly, and that's how your architecture should be as well. So for an example, you're going to be learning about Lambda, And as I mentioned, I started with my startup, and we are so basically our startup was entirely microservices based. We didn't use anything which is like monolithic structure. Our entire architecture was distributed, and that's why Lambda, it gives you around, if I'm not wrong, 2 million or 1 million requests per month. So that was pretty much I needed for my startup, and that's why I never paid a single penny to AWS for around 1 year. So yeah, and if you have architecture like having serverless architecture is what Lambda is used for, no need to worry if you don't know what Lambda is. We are going to be covering and just giving you example of how you can scale up or down using AWS services. And finally, no hardware requirement. All you need is your laptop, and all these services tools are at the palm of your hands, literally. Yeah, any questions? Good, thank you. You can proceed to the next slide. And yeah, somebody asked me what are the services that we are going to be covering. So you can see it now. Even if you don't know the services, no need to worry. In this slide, I'm just expecting you to read the names. So for an example, your data, it is being generated from somewhere. So that generation bit, or how do you get your data into AWS, that you can think of at, for an example, Kinesis can do it, SQS can do it for you. And just a general trivia, SQS is the first AWS services that they launched. Now AWS is quite big and they are world famous. They are over GCP and Microsoft by like huge margin. But this is the basic service that they started AWS with, Amazon SQS, the first service. Uh, anyway, coming back to the topic, processing, we are going to be covering Amazon EMR, which uses your Hadoop, Spark, and all those things to process the data that you are going to have in your AWS ecosystem. Lambda, as I mentioned, is a serverless offering, and this is what you need when you're building a microservices kind of architecture. Amazon Lambda. Here, you absolutely pay for whatever you're using, nothing more than that, at least for processing bit. And Amazon Redshift. So if you have any kind of data warehousing requirement, Amazon Redshift fulfills that for you. It is a columnar data storage which AWS is optimized. So there is nothing in the world, at least in my experience, no other data warehouse which is as efficient as Amazon Redshift in terms of how it works, scales, as well as how much you pay for it. It works amazing, and still you pay quite cheap as compared to the other solutions that you have in the market. Again, don't take me by my word. You can have your Googling skills to see this. But yeah, oh yeah, those are fairly, obviously, they are into picture because obviously, if you're in the market, you wanna just overpower something. So Amazon Redshift is a fairly old product. Snowflake is a fairly new product in comparison. But yeah, I take your point as well. That's a very good product. I recently started learning that. In terms of storage, coming back to it, so Amazon S3 is the go-to thing when you have storage requirements. We are going to be seeing Amazon S3 a lot. Nobody escapes S3 no matter what certification they are going through. It's kind of a backbone for all the certifications. Then for your non-relational database, they have Amazon DynamoDB. And for your relational database, you have Amazon RDS. We can go to the next slide if you don't have any questions. Oh, good question. Actually, ideally, it should be under storage. It's just that Amazon Redshift gives you this. It's not a Redshift as such. They have an added extension to it, which that does some sort of processing there as well. So ideally, if I have to choose as well, I would have kept it in storage as well. So yeah, in the data collection, there is a service called AWS Kinesis, and this is how you are going to get your data inside Amazon. This is just not one way of doing it, but as far as this course is concerned, we have to focus on Kinesis because Kinesis is actually used widely whenever you're building some sort of data analytics application. So for an example, if you have heard or worked something related to Kafka, it's kind of pretty similar to that. So here, Kinesis is what you use in order to build those data analytics application. So for an example, it can send the real-time data, and that's why. So yeah, I was talking about Kinesis, and just very like short description of what the service is. We are actually going to talk about Kinesis in much more detail in the actual Kinesis section. So this is what Kinesis is, and they have given one example. This is directly from AWS documentation. So this one, for an example, a tractor is sending you sensor related data, which is being captured by your Amazon Kinesis data streams. And once you have the data inside Amazon Kinesis stream, it can basically ingest and store your real-time data for further processing. So for an example, you want to do some sort of SQL queries on top of this data just to see some sort of where clause, order by, and all those things. You can do that in between using Amazon Kinesis itself. And let's say you want to do some sort of action basis this data, you can just club this particular data, what you're getting from Amazon Kinesis data stream with AWS Lambda, and Lambda will take care of doing a code specific job. So for an example, Lambda is nothing but it's basically a function. It can have any code. That is up to you. Whatever code you want to run, Lambda will just run that code whenever a event will be triggered. So for any event driven architecture, you can use Lambda along with your Kinesis data stream. And finally, whatever is your output, you can get that output from your AWS Lambda function itself. So this particular example, it's firstly, this service, again, if you're trying it on your own, it is going to cost you some money. You can check AWS cost page or pricing page for details on that. Yeah, we will have a demo on Kinesis as well, and you'll get to know a little bit more hands-on on Kinesis later then. Any question on this? Just brief introduction about Kinesis. Okay, so this is how you are basically giving you introduction on how you are going to get data, and you can do so using Kinesis. Now, once you have the data and you have done some sort of processing on the data, what you want to do is basically you want to save that data for long-term storage or further processing. And the services that we are going to use for that, specifically for this course, is firstly DynamoDB. So DynamoDB, it's a NoSQL database which is completely managed by AWS, and which is the biggest advantage I would say of using this service. Otherwise, if it is not fully managed, there are lots of moving parts related to maintaining your own NoSQL databases. So for an example, I'm currently maintaining a Cassandra database, and there are a lot of things you have to configure there, and all those things are abstracted from you by Amazon, and it's just a NoSQL database. You just tell them that I want to be using this service, and they will scale this service. So it's like fully scalable service. You don't have to worry about that scalability factor from the day one itself when you're using DynamoDB. It takes care of that scalability factor. It is fully managed, though they still give you some controls if you want. So if you don't want, it is fully managed automatically. But let's say you are a very advanced user who want to tweak little performance of your application. In that case, they have given you certain things that you can change, for an example, to improve the performance or to decrease cost further. All those things are possible as well. But by default, it is a fully managed service. You don't have to worry about anything at all from day one, and it gives you pretty predictable performance. And I have a lot of AWS services which are my favorite, and this is one of them. So whatever pet projects I do, I mostly use DynamoDB because it gives me a predictable performance. It gives me near real-time latency kind of performance, like whatever I'm querying right now, next instance I'm saving right now, next system instant I want to query it immediately for some real-time processing. It gives me those results as well. So it's quite predictable performance, quite cheap, as well as at the same time, it is scalable. And yeah, so these are the major advantages of using this service. We'll talk a little bit more about entry cases of this service, why this is so scalable, why it gives you that near real-time performance and all those things later. With this, you can create your databases table that can virtually store any sort of data, whatever size your data is. And that is your Amazon DynamoDB, which is a NoSQL database. For now, you have to just remember this much. Any questions on it? The next one, so for an example, this is when you need some sort of, for an example, this is when you're trying to build an application like e-commerce website or something where you will have your lot of databases changes. Somebody will place an order, you have to update your database. Somebody is asking for return or something, then you have to fetch data from your database and things like that. So DynamoDB is suitable for those kind of workloads. Now you just want to save your data. In that case, Amazon gives you this cold storage option, which is your Amazon Glacier. And this is just for your long-time storage for your cold data that you're not going to be using again and again. You are very frequently going to retrieve this data, and you probably want it quickly whenever you're trying to retrieve it. Not quickly, sorry. In that case, basically it's just a backup service. You just want to keep your data. So example, anybody want to give example of this, why we might want to use a cold storage solution? Okay, that's great. So Amazon EMR is basically hosted on top of your EC2 virtual machines. So yeah, it is like n number of, let's say, 3 EC2 instances connected together to give you this ecosystem. So when you're dealing with this big data, when you have like too much amount of data and you just want like very quick results, in that case, you might want to use Amazon EMR cluster. We are going to talk about Amazon EMR cluster a little more, like what is master node, core node, and things like that. So yeah, EC2 in a nutshell is basically it's a computer. It's just somebody else's computer. Amazon is giving you that computer for you to use. That's all EC2 is. So yeah, that's what EMR is. So Elastic MapReduce, it just gives you what MapReduce does. So if you're not aware about MapReduce, I'll give you a quick kind of walk through about what is MapReduce. But basically, it's to process huge amounts of data. Otherwise, basically using all this n number of computers, you are trying to break data and send it to different computer machines to work on their bit, and they just collect, finally aggregate all the results and give it back so that it is distributed computing at your disposal. That's what EMR or the MapReduce does. Amazon has just implemented the same version of that MapReduce by the service, which is Elastic MapReduce, and they have made it again a fully managed service.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Now coming to Lambda, so Lambda is again one of my favorites. So whenever you're trying to build something with a serverless solution, here you do not. So I mentioned that in EC2 you were renting somebody else's computer. Here, instead of renting somebody else's computer, which you are paying rent for like all the time whenever you're using that machine, here you are paying somebody else's machine to run for a, let's say, just 5 seconds. That this is my code. I want to run this code somewhere else. That's what Lambda provides you. It's a serverless, event-driven, and fully managed computing solution. Wherein, why event driven? Can somebody explain what is event driven? So that's what event driven is. Here, for an example is given. You have taken a certain picture and you have uploaded that picture to Amazon S3. So this is the event that you have triggered. You have mentioned that this is my trigger. Whenever something comes to S3, I want to resize that image and save it somewhere else, let's say in another S3 bucket. So all these things can be entirely automated, which means you make it event driven. It won't run unless this particular event happens, and that's what Lambda is that's where it is super powerful. You can make all your code, entire applications based on Lambda itself. You don't have to have something like Amazon EC2 or EMR. You can just use Lambda as well. Again, it has its own limitations, and we'll talk about that later. And then Glue. So many people were interested in Glue. So Glue is fully managed ETL solution, your extract, transform, and load. And yeah, that's what basically it is. Amazon, again, it is powerful again because it uses Spark at the back end. And that's what makes your job or the ETL jobs quite like efficient here. So for an example, again, there is much to Glue apart from just being an ETL service. It's a data catalog as well. And we'll see that in action actually. Anything else in processing? Is EMR, Lambda, and Glue clear so far? Again, just an introduction. We are going to talk about all of the services in detail. Absolutely. So it's your data warehousing solution. So far we talked about DynamoDB, or there is another thing called RDS, Relational Database Service, and those are databases. Here, Redshift, it's for your entire data warehouse. And it's again fully managed. It can handle data to some petabyte scale. And apart from that, you mentioned one good point, columnar, and I'll give you a lot more detail about that columnar storage. But for the people who don't know, so either you save data in row-wise fashion, probably everybody is used to that. You have seen all your Excel spreadsheets. Those are the examples of saving data in a row-wise fashion. Redshift, what it does is it makes your data much more efficient, or the queries much more efficient by saving it in columns. So for an example, you are doing some sort of queries, you have like 200 columns, and you are doing a query like, give me data for just this particular country. And here what you have done, your data is saved in a columnar fashion. So here it won't have to go through all your rows just to fetch that one country related data. It will just fetch that data wherever that country is present, and that's all. Again, we are going to talk about Redshift, but basically it's a data warehousing solution. Then SageMaker. my bread and butter actually. So Amazon SageMaker, it's again a fully managed machine learning service, and nowadays they are introducing a lot of things to it. So even I am kind of outdated to 2 or 3 sub services that they have launched inside SageMaker. But again, at a high level, what SageMaker is, it gives you machine learning capabilities. You want to train your TensorFlow model, PyTorch model, all those models. You want to do machine learning related tasks like, for an example, some sort of object detection and all those things. All of those operations related to machine learning can be done inside SageMaker itself. It's a fully managed service, so all the things that you need. So, for an example, starting from collecting your data to processing that data, calling EMR services if required, everything can be done from SageMaker itself. You don't need to worry about SageMaker much for this certification, but again, it's a part of it. So we are just going to give you an overview of what SageMaker is. I'll give you kind of walkthrough of what SageMaker looks like, what are the portions of it, but we are not going to go in much more detail. That is your machine learning specialty certification and not this one. Athena, and Athena is again just like Lambda. It's a serverless service. You are paying only whenever you're using this service. So what basically it is, it's an interactive query service. So if you have used something like DB Weaver, PG Admin, all those tools, they allow you to query your databases. Same thing Amazon Athena does, but it is serverless, which means whenever you want to query your data, you just type that query and it will just go to your database and it will fetch the results. And you're going to pay only for the duration when your query ran. That's all. So your data, whenever it is stored in, let's say S3, you want to query that data, or you have a database which is saved in RDS or somewhere, you can do that via Amazon Athena itself using basic SQL queries. That's all it is. It's just a window which allows you to run SQL queries. And Elasticsearch service, again, not much used service, but I would say it's again a fully managed, cost effective Amazon service which allows you to deploy, secure, and run Elasticsearch and scale it. So Elasticsearch itself is an service which Amazon has again done, just like every other thing. They have taken Elasticsearch tool and they have implemented their own version of it, and they have started calling it Amazon Elasticsearch service. And yeah, if you're not aware about Elasticsearch, I'll show you, but again, not in much detail. This is not required, but I'll show you. And finally, we'll end this course by talking about data visualization. Not very heavy on what kind of questions you get. Data visualization is basic stuff, whatever we are learning from elementary time itself, which is like what is bar chart and all those charts, in what scenario you might use this kind of chart, and all those questions usually come. But there are certain specific questions related to Amazon QuickSight, which is Amazon's offering for visualizing your data. It is pretty fast, and that's what they claim, because they have something called Spice, which is the proprietary engine basically that they have used to query your data or to create all this visualizations. Again, details we are going to talk about. For now, just remember, QuickSight is a service which allows you to visualize your data and show those pretty looking graphs, stories, dashboard, things like that. So yeah, that's pretty much it. This was the overview of what your course is going to be. If there are no questions, I'll get started with the second day of content, which is actually where we are going to dive deep into all the services. Yeah, so this is the agenda for this particular portion, which is your data collection. And as I mentioned, we are going to talk about Kinesis. Kinesis have few sub-components related to it, like Kinesis Firehose and Kinesis Data Analytics. We are going to cover all of them. And here, as you can see, all these things, this is what we are going to cover, like what is Kinesis, why Kinesis, how does it work, or what are the features of it, what are the components associated with it, what are some specific features like enhanced fan out, Kinesis Firehose, because these are the things that they usually ask in certifications. So all the things related to Kinesis that they might ask, or that is required for you to know Kinesis better, are covered in this agenda. So what is Kinesis? I've already given you a brief about it. Quickly, somebody tell me. Key thing to talk about Kinesis is it's a real-time data collection service. So basically what we are looking at now is how we are going to collect data with Amazon Kinesis. And at the end of this module, you will be able to describe in detail how Amazon Kinesis can be used to collect data within a big data solution. And so getting started with it, what is Amazon Kinesis? So Kinesis, it basically makes it easy to collect, process, and analyze your real-time streaming data. So you can get timely insights and react quickly to the new information that you are getting from whatever your use case is. Could be reading tweets, getting sensor data, and things like that. So with Amazon Kinesis, you can ingest real-time data such as your application logs, website click streams, IoT data like data coming in from your Apple Watch into your databases, your data lakes, or your data warehouses. So that's what it does. It collects all your streaming data, whatever examples I have told you about, and it allows you to save the data or further process that data, whatever your requirement might be. And apart from that, it enables you to process and analyze this data as it arrives and respond it in real time. So for an example, somebody is using a website and you want to recommend them basically, for an example, you're using Amazon itself. You would use Amazon and then there's you might be looking for this and all those things. So what they are doing is they are doing a recommendation engine at the back end. How they are doing it, they are using Kinesis to get your click streams, where you are clicking, what kind of products you are clicking on, how many times you went to the checkout page or somewhere. All this data gets captured. And basis that data, they are making real-time decisions. Okay, this person might like sneakers more, so suggest more sneakers, things like that. So whenever you have this kind of requirement where you don't have time to first feed the data into your databases and later process that data, and you just want real quick time insights, Kinesis is your friend there. Now, whenever you're choosing a big data processing solution from within the AWS service offerings, it is always um, important to determine whether you need the latency of response from the process to be in seconds, minutes, or hours. And this will typically drive the decision on which AWS service is best for processing that kind of, for basically that processing pattern or use case. And Kinesis is primarily designed to deliver processing oriented around real-time streaming. So as I mentioned, the keyword here is real-time streaming of your data. So for an example, you wanna this I'll show you that. So, for an example, you want to host a Super Bowl event or some sort of FIFA thing live. You want to stream that data. You want to stream that video. Kinesis can help you with that streaming bit as well. And apart from that, one of the interesting things when we look at all the storage patterns is that Amazon Kinesis, it does not store persistent data itself. So for example, Kinesis is not a data storage solution. It is just a streaming solution. It takes your data and it sends you to, let's say, S3, RDS, DynamoDB, where exactly your data gets stored. Okay, unlike many of the other Amazon big data services, this service, do remember, that does not store data, persistent data in itself. It requires some sort of database solution or data storing solution at the end to actually save the data for a longer usage. I'll stop here. I'll assume that you are all good. Anyway, moving on. So all these definitions and all, I'm not going to read it, but like how do you want me to explain, like how I just did by myself, or you want me to read the definition and then go on from there? So Amazon Kinesis, it needs to be deployed as part of a larger solution where you are going to define a big data solution that will store the results further of whatever string data, log data, whatever kind of data you have, and you are further processing that data. But in that case, Kinesis job is done. It got that streaming data, it processed that data. That is an optional thing. If you don't want to process and you just want to save that streaming data, you can use Kinesis for that as well. So how it will handle, it will just uh, basically it will act as a middleman. It will fetch your sensor related data, log related data, and it will finally just save that data in your further data process storing solution. What else? Apart from that, do note that each Amazon Kinesis, okay, I'll talk about those stuff in the later slides. So some of the Kinesis use cases, is enough. So these are some of the use cases where you might want to use Kinesis. So for an example, in the later section, once we are at the hands-on section of Kinesis, what I'm going to show you is I have built an application. What it does, it generates some fake data, and that fake data is all about Marvel superheroes. And what it does is I have assigned some sort of score to all of these Marvel superheroes as per, again, my biases. And what it does is I have intentionally put one outlier there. So for an example, all the superheroes, I have given them a score from 1 to 1000. One of them, I have given a score of, let's say, 10,000. And for me, that is an outlier. And again, this is just one made up example, but this could be used somewhere. For an example, this can be your sensor data. Your sensor data usually, let's say, reads in few or centimeters, and all of a sudden you are getting a reading which is like 1 kilometer, which is an outlier for you. And it might have happened for a number of reasons. We are not going to go there, but let's say that kind of outlier is present. And as this is a streaming data and you want that outlier to be detected as early as possible, what we are going to do that in our hands-on section is that we are going to detect that outlier using Kinesis itself, and we are just going to do like whatever, probably delete that record, correct that record, and things like that, or just notify somebody. That is up to us, but yeah, that is the hands-on we are going to work on when we are doing the Kinesis hands-on. So that is one example. This is an example of real-time data analytics, what I just mentioned, that made up superhero example. Apart from that, you can have real-time data log, basically all of your log data coming in, or data entry ingestion, all of those coming in and getting saved somewhere. You can use Kinesis for that as well. Now, coming to exactly how it works. So before we understand Kinesis further, we need to understand what exactly are these terms, because I'll be using these terms and you'll be seeing these terms in your AWS console as well. So getting started with a service which is called Amazon Kinesis data stream. Okay, so let me see if they have a drawing board. Yes, they do have. So here in Kinesis, basically Kinesis is one big service. Under this, you have something called Kinesis data streams, Kinesis data firehose, Kinesis data analytics, and Kinesis video streams. So actually, Kinesis is not just one service, it's a collection of 4 different services. One is Kinesis data streams, one is Kinesis video streams. As the name suggests, this is for data, this is for all the other videos, and this is your Kinesis data firehose. We'll talk about it. And then we have Kinesis data analytics. So you can use it in both. So for an example, if you have collection of image, basically what is a video? It's nothing but different n number of images captured, and then you are just playing them in like at one go. That is the video itself. So your video actually itself is the collection of different images, but your image, you can send it in a binary string or bytes kind of format as well. So image can be used both in both the places. Does that answer your question? So we'll get started with Amazon Kinesis data stream. And that's why I just gave you all these different services so that it is not confusing, because shard is used in one service, but it is not used in another service. So it was an introduction of what we are talking about, because that is missing from this slide for whatever reason. So yeah, we are going to talk about Kinesis data stream. So just correct it. This is not how Amazon AWS Kinesis work, but this is Amazon Kinesis data streams. So first, we'll have a look at the architecture that underpins what exactly is Amazon Kinesis data stream big data service. It's basically based on a platform as a style architecture where you determine the throughput of the capacity you require, and the architecture and the components are automatically provisioned for you. You just say that I might be getting this kind of data, which is like 10 MB, 2 MB, whatever. That is up to you. You will define that this is the throughput or capacity that I want. And basis that the architecture and the components are going to be automatically provisioned for you. They are going to be installed for you, configured for you as well. You just have to mention this throughput capacity. So there is only one input required from your end when you are working with Amazon Kinesis data stream, which is the throughput capacity. You have no need or ability to change the way these architectural components are deployed. Unlike some of the other Amazon big data services where you have a container that sits within, for an example, a database instance with an Amazon RDS which Amazon Kinesis does not. Here you don't have the flexibility of changing any architectural component. Whatever it is going to remain like that. It is going to work like that. You just have one input here that is required from your end, which is the throughput capacity. Now the container, it is effectively the combination of the accounts and the region you are provisioning. For an example, whatever Kinesis stream, actually we are going to talk about that later in the hands-on itself. So what Amazon Kinesis stream is, it's just ordered sequence of data record. Again, it is not. So whatever I'm going to type, please make sure that you type it down as well somewhere, because those things might not be present in your PPT slides. So yeah, it's up to you. You want have notes, otherwise, yeah, you might miss few information. So what I was mentioning is all your data in Amazon Kinesis stream is nothing but it is ordered sequence of data records. And what is record? Record is the unit of data in an Amazon Kinesis stream. So here, this is the record that we are talking about, which is mentioned here. We'll come to what shard is. So hope a record is clear. If not, please ask me. Okay, so record here, even I'm not a very big on definition, so I don't learn the definition myself. I just get started with things and understand them in my own fashion. But record, I think it can be called as a just one unit of data, which means here you have ordered sequence of data record. So for an example, taking your example of you mentioned images. So let's say you are going to send 10 images to be resized in Amazon Kinesis stream. Again, it's a very bad example. Let's say 10 logs to be processed for whatever. Could something you're doing with logs and you're sending it to Kinesis data stream. So here in this case, your one log can be called as one record. And overall, you have data records. What are they? They are just ordered sequence, log number 1, log number 2, log number 3, and so on. So that is what Amazon Kinesis stream is, the first definition that I have returned here. And record is just your one log. And again, this is a very bad example. It cannot be one log. Let's say it is just worth 1 MB of data. Hope that makes sense. Now, each record in this stream that is coming into Amazon Kinesis data stream, it is composed of a sequence number. Kinesis data stream architecture. I think this will be good to understand all these key terminologies. Oh, it's the same diagram we have in our PPT as well. I thought they'll share something else. So here, okay, let's take this itself. We have this in our slides as well somewhere. Okay, so let's take this. So for an example, you need one producer, which is going to produce the data. And in this case, let's say your data is coming in from EC2 instances. Your EC2 instances, they are generating logs and you want to consume those logs. And you want to send those logs somewhere finally to be processed. You want to do something like if this log is 500 type, check my something. So that is happening over here in the consumer section. And finally, you want to save this processed information in one of the database storage solution. So Kinesis data, Kinesis stream, it is going to fit in here. And all these logs, whichever are coming to your Kinesis data stream, that is called as one record. And this one record has a partition key, a sequence number, as well as the actual data referred as data blob. So all these things are mentioned here. It says that what is a data record? It is just the unit of data stored in your Kinesis data stream. It composed of sequence number, partition key, and blob, whatever I'm saying right now. All these things are returned. Okay, so I hope this much is clear so far. Now, the data record in your stream, they are distributed into shards. So now we are going to talk about shards. So what is happening? You have this 1, 2, 3, n number of records coming in. You don't want to send them, all of them, to just one place itself. You want to distribute them so that it works like in a distributed fashion. It works very smoothly with much less latency and all those things. And that's why you have this concepts of shards. So this is what we saw in between in this diagram, that you have all this shard. So what is shard? A shard is the base throughput unit of your Amazon Kinesis data stream. One shard, what it does is it provides a capacity of 1 megabyte per second of data input. Let me write it down. It might be there in PPT, but if in case it is not there, I'm just writing it down as well. So one shard, what is it has is, firstly, what it is, it's a stir throughput capacity, and one shard can hold data which is equivalent to 1 megabyte per second. And basis this, you can just specify the number of shards needed when you're creating a stream. As I mentioned you, there is only one input required from your end, which is the throughput capacity. How you are going to define that throughput capacity? By shards. How you are going to calculate that? You have the base unit number for what a shard can hold, which is your 1 megabyte per second. So for an example, now you have a requirement of sending 20 megabytes of data. How many shards you are going to need? Quickly give me a very obvious answer. Absolutely. Now, the data capacity of your stream is basically going to become the function of the number of shards that you specified for that stream. The total capacity of that stream is the sum of the capacity of all these shards. And if your data rate increases, you can increase or decrease this number of shards allocated to your stream. And your producer continuously keeps on pushing your data to Kinesis stream, and the consumer keeps on processing this data in real time. So that's what this diagram is all about. Here we talked about producer, we talked about consumers, we talked about what is the throughput capacity, why throughput capacity is required, just to give you an idea of like, so that you have an idea how many shards I'm going to need, and why I need all those shards to scale up or down your application. You don't want to waste too many shards if you don't have too much data. You don't want to like have very less number of shards when you have too much data coming in. That can create problems, and handling that is as simple as adding or removing these shards. Now, taking an example of this could be, let's say, a web service which is sending log data to a stream in a producer via a producer, sorry. And your consumers, they receive all these records using Amazon Kinesis stream, and they processing that information. Now, this consumers, they are basically known as Kinesis stream applications. So here in this case, you have EC2, which are the producer, which is actually generating all these logs for this web service. And here you have again this EC2 instance, but what are they actually? They are your Kinesis stream application, because this is where exactly your consumers are present. This is where you're actually consuming that information to do whatever n number of things that you can do. That is your custom logic. And later, your consumers, they can store their results using any of the Amazon services such as DynamoDB, Redshift, S3, whatever. Now, Amazon Kinesis application, what it is a data consumer which reads and processes your data from your Kinesis stream, and it typically runs on a fleet of EC2 instances, as you can see in the diagram. And you need to build your applications using either the Amazon Kinesis API or Kinesis client library. These are the two key terms that, let me write it down. So to do all of these things, we have talked about theory, we understood what Kinesis is, we understood what is shard, what is record, what is data blob, and all this producer, consumer. Now, exactly how do you do it? You are on an EC2 instance and you want to start using Kinesis data streams. How exactly you can do it? You can do it via one of the two options, which is your Amazon Kinesis API. They have created an API. You can directly use this API to send the records, to consume the records, or you can use Amazon Kinesis client library, which is nothing but an SDK function. It is also called as KCL. So this is where exactly your data is going to be consumed. And you can do, once you have the data, you can have your custom logic to process that data, so store that data, whatever. Now, before we go into each option in detail, we are going to have a quick look at how Amazon makes life easier for you. And one of the great things about AWS is that they always try and make things easy for you. So when you go to Amazon Kinesis stream, I wanted to show you a few things in my console itself. AWS. Let me try one more password. What it might be? Oh, I might have and it's one of the major. What do you say? No, shard is just basically you're bifurcated how you're handling that data. It's not a storage, and even if it is a storage, some sort of storage. So, for an example, again taking an example of Kafka itself, Kafka it's not a storage solution. They don't store your data, but obviously they handle your data, so they are storing it somewhere. But all that data is stored only in like some sort of cache or something like that. It's not persistent data. So it cannot be called as a database or any sort of data storing solution. It just handles your data in between. So shards is nothing related to data storage. Shard is basically one unit, how they have defined here to, which is handling the piece of your data. And regarding the question on how do we define how many shards we need for this iCloud example, so you have to check. So for an example, in 1 minute, how much data in megabytes your iWatch is sending. Let's say if it is under 1 MB, which means you just need one shard itself. Okay, and if it is more than that, so for an example, it is sending 20 megabytes of data, again, the same thing continues, you just multiply it. Couldn't find the password again. So yeah, I'll show you all the things related to console when we are doing the actual hands-on. I'll continue with all the rest of the PPT things. So we have understood what exactly is shard, what is record. Let me see what do we.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
All these things are returned, whatever I type there. So good thing for you. You don't have to. So same thing. What I mentioned, it has a capacity of one shard has a capacity of 1 megabyte per second, which is your. This is one thing which I didn't mention. So one chart, it provides you a capacity of 1 megabyte per second data input. However, it gives you 2 megabyte per second data output. So basically, you can put 1,000 put records per second, which is equivalent to 1 megabyte. However, you can read. So basically, it's like you can take little, but you can give more. So whatever your consumer applications are, they are going to be able to reach data in a much more faster fashion because it has a capacity of sending 2 megabytes per second. In that case, it is just taking a data which is 1 megabyte per second. So just do remember these numbers. Apart from that, it's like in terms of regular usage of this service, they are not much useful. 1 megabyte per second is definitely useful because this is how you are going to know the throughput of your application. Then we have things like shard ID, which is the everything has a unique identifier, just like you have a name, just to name it something, they have a shard ID. And then you have a shard iterator as well, which iterates to all your record. And we are going to talk about this shard iterator later. All these things, whatever I have already mentioned, so I'm not going to go through them again. There's the same diagram we already covered. So your data is ingested into Kinesis shards pipeline from all these producers at 1 megabyte per second. It should be second, not shard. Then your data is going to be streamed to consumer instances after processing or without processing at a maximum speed of 2 megabyte per second. Absolutely. Each shard, what we are talking about, 1 megabyte per second and 2 megabyte per second, all of those things are related to just one shard itself. Okay, what else? Manage a Kinesis shard. So I'll do the hands-on once I have my AWS account properly in place. So this is what we are going to do. And actually, we are going to do much more than this. What I mentioned about that Kinesis data, the outlier thing about that super error data, it is going to cover all of these things plus little more things as well. So there we are going to create a stream. We are going to describe that stream. We are going to list all the stream. We'll add a record to that. We'll get the shard iterator. We'll use that shard iterator to get the record, and we'll finally delete that stream as well. So we'll see all this. So a good question which a lot of people ask me, and we have already compared it to Kafka, but why exactly Kinesis is better than Kafka? So I need you to answer this first, then I'll talk about it. Yeah, that's the very big thing. If you are using Kafka in your organization, you might know that a Kafka requires a dedicated team who handles that Kafka related cluster. They provision those things for you. They ask you like, why do you need it? What is your project? What all those things they ask you, and basis that they use their own expertise, their knowledge, and basis that they tell you, okay, you can have this number of topics and all those things. Here you don't have to worry about that. You just are worrying about what kind of throughput you want to handle, which is very easy thing to know. Just like we talked about that iCloud example, we just get to know what kind of data I'm going to be consuming. You define that via shards, and rest of the things, the entire architecture is being taken care by Amazon itself. So that's one major thing. Apart from that, in Kinesis, you are only paying to basically you are paying again just like every other AWS service. You are paying as per your usage. You are not renting the entire cluster itself, or buying the entire hardware resources and managing them, keeping a team and all those things, which becomes an expensive operation. Apart from that, it gives you the flexibility that you don't have to dedicate your entire DevOps team to manage and maintain it. So all those things, whatever they provide, all of these things are automated or taken care by Amazon itself. And apart from that, Kinesis manages and maintains a lot of things for you as it's a paid provided service. It's not a very cheap service as well. Like when I'm talking about it's not a cheap service, I'm talking on an individual level. For organizations, definitely it's quite cheap. And then we can finally analyze and manipulate your Kinesis data streams using Lambda functions before finally forwarding it to some sort of persistent storage, which is again, if you're using Kafka, it does not give you that inbuilt integration already in place. You have to have your custom logic in place for that, which is again sometimes quite cumbersome if you are not that, like, anybody who is not that expert in that particular area. So all of these reasons make Kinesis much better than your Kafka. And but yeah, these are the basic advantages that Kinesis offer, that it's a cloud-based service. You have this divide and conquer thing available already, that you just provision things and then all those things are managed. It is fast as well, and it is quite cheap and scalable as well. Scalable actually Kafka is as well, so there is not much of an advantage over here, but yeah. So how do you think your data is segregated by Kinesis streams to multiple shards? It's a question for you. I've already given you the answer. Your data segregation into different shards, how that is happening, because of what particular thing that we discussed. Absolutely. All of your data records, as I mentioned, they have a partition key associated with them, which is determining which shard will be given what data record. So just to keep a track of, okay, this data record belongs to this particular shard. For what anything related to monitoring or governance, you have those partition keys in place, and basis those partition key, your data is being segregated into multiple shards. Now, partition keys, what are they? They are just unicoded strings with a maximum length of 256 bytes. So what exactly it does? It has something called MD5 hash function, which is used to map your partition keys to a 128-bit integer value and to map associated data records to shard. Again, you don't need to know this information. This is additional information. What exactly a partition key is doing? It uses a MD5 hash function, which is used to map your partition keys to a integer, because your partition keys are strings by how they are defined. But using this function, hash function, they are being mapped to a 128-bit integer. And your data records, all of your data records, this is how they are associated or mapped, like which data record belongs to what partition key or what shard. Now, a partition key is specified here by your data producer while you're adding data to an Amazon Kinesis data stream. So for an example, I don't have a Kinesis example in place, but I'll show you example that I have of Kafka, because it is quite similar. So this is how your somewhere like producer will look like. In your producer is what? Nothing but your EC2 instance or your local machine itself. So consider this is my producer. This is your, as I mentioned, you have two things, API as well as library. So this is going to be your producer library. Okay. Using this library, what you're doing, you're sending data to Kinesis stream. Again, this is not the exact signature, but something. You are going to publish your data or send your data to Kinesis stream, and you are going to define one thing, which is your partition key. Using that partition key, it will bifurcate the data. It will generate that hash function. It will decode that, and all those things will happen. But basically, this is how you are going to use your data producer when you're adding data to a Kinesis data stream using either via library or an API itself. Hope that makes sense. Yeah, it's not a Python code, it's a Java code. I just showed you Python code as an example. Details, you can get it in the documentation itself. Probably last time I used, that time they had just Java library for it. And they have already written that we are writing that particular client code in different languages as well. So by now, probably they might have Python or other languages as well, but you can check it in their documentation itself. Last time I remember it was just Java. Okay, now I just need one blank slide to show you something or type things. Okay, so now for an example, you have two shards. Okay, shard 1 and shard 2. Let me use pen itself. Highlighter is bad. And you have configured your data producer to use two partition key. You have data producer and it has two partition keys, key A and key B. So that all your data records with key A are added to your shard number. All your data records associated with key number B, they are associated to shard number 2. Now, a sequence number is going to be assigned, which is just a unique identifier for your each record. So your data record, whatever it is, let's say it's just one log here as well. It will have a sequence number. Sequence number, let's say 1. This is your sequence number 2. They are assigned by Amazon Kinesis itself, so you don't have to worry about it in your custom code or logic. Whenever your data producer calls your put record or put records operation to add data to a Kinesis stream, this sequence number will be added automatically. Sequence numbers for the same partition key generally increase over time. The longer the time period between your put record or your multiple put requests, the larger the sequence number becomes. Now, in that case, what a shard basically becomes is it's just a group of data records in a stream. So for an example, I told you that you can send 1 megabyte data in one shard. Okay, this is my shard number 1. It can hold this much data, and I am sending record, which is 1 log. And this is what, let's say 5 KB. Okay, is my 1 MB throughput already over or not? Yes, no? Can I send more logs? Absolutely, I can send much more logs. So this log had a serial number 1. Another log I am going to send, it might have 2, 3, and till n. Okay, so this is what I was mentioning, that whenever you have the longer time period between your sending one log, then sending next log, this sequence number keeps on increasing. Again, just an additional information. You don't need to remember this information or it's not going to be useful. It just came to my head, so I just told you about it. So this is what all this n number of logs that you are sending until they becomes 1 megabyte or until it is 1 minute already over, they will be sent as one data record to your Kinesis data stream. I hope that much is clear. If yes, give me a yes and I can proceed. Okay. Now, whenever you're creating a stream, you specify the number of shards for the streams, which we have already established. Now, each shard, it can support up to 5 transactions per second. I'm just writing TR. Understand it is transaction. For reads. And it can send up to a total data read of 2 megabyte per second that we have already talked about, and up to 1000 records per second for writes, and up to maximum total basically this 1 megabyte per second, including your partition keys. Now the total capacity of your stream is the sum capacity of all of your shards. And we have determined already that we can increase or decrease this. Yeah, this is the only information that you need to worry about. That just like I sent, initially I sent 100 logs. Okay, and it is still not 1 MB. I sent 100 more, then I sent 100 more, and all of these things I did it in 1 second itself. Multiple calls, multiple put record calls from my multiple producer. Basically, I'm making this all 5 calls in 1 second itself, which is 100, 100, 100, 100, 100. And if you're trying for the 6th time, it will not work. This is what I wanted to explain over here. Hope that is clear. 5 transactions per second is pretty good as per me. So usually I never reach that. I got an error that you are trying for the 6th time. But yeah, just a good to know information. It might come somewhere in your certification. Are we good? Okay, I'll take that as a yes. So do note that you are charged on a per shard basis. So before you create a stream, you need to first actually determine an initial size for that stream. And after you create this stream, you can dynamically scale up or down your shard capacity as per your requirements. That is pretty easy. You can do it using the AWS console UI, or you can just update shard count in the API call itself, from wherever you are making that call. And you can calculate the initial number of shards you need to provision using that simple formula, 1 MB/s. I've already told you. Just determine what kind of data you're sending. Basis that, figure out that initially I want 10 shards. Later on, if you need more, you can definitely increase. But this is how you're going to calculate and start using actually this service. Now, Kinesis streams, it supports changes to your data record retention period for your stream. Kinesis stream, it's just an ordered sequence of data records which are meant to be returned to and read from in real time. So initially it is not made to be like persistent. However, your data records, they are giving you some sort of flexibility here. Whatever data records you're storing in your shards, in your stream temporarily, they gives you an option of sending it, storing it temporarily. So let me explain via diagram what I'm talking about. Where is that diagram? Oh, it was earlier. Can I erase all this information, or do you need something? No, it's gone. You had that. So it will keep on accumulating your data, and once it becomes 1 MB, then only it is going to go to the next chart.
Okay.
If, for an example, you have provision 2 shards, and for 10 days you're using that application, but you never send data which is more than whatever your example 0.5 MB. In that case, your second chart is just sitting there idle. It is never getting any data because you're not sending that much data. So basically, it's a mistake from your end that you ended up provisioning a service with 2 shards. In this case, you just needed 1 shard itself. So that is just your provisioning mistake. That's all. So basis that again. So for an example, let's say your consumer is not able to do whatever your logic is. It is not getting it. Obviously, you are writing code, so you will have some sort of custom check. If I'm getting the data which I'm sending or not, you will do something like that. And you can write something like that as well, that if I'm not getting this data, then notify me. And once you are notified, you can just go and increase 1 shard. And that's where I'm coming to the second piece. It's not like that information is gone. They have this thing called temporary storage that I was going to talk about. So what this temporary storage does, here in between, you have sent this data, but you have not consumed this data yet. It is going to be gone from your shard only when you have actually consumed it. Okay. Till then, it gives you a retention period. Your data will sit in your shard for, let's say, 7 days. By default, it is 24 hours, but it can maximum sit up to 7 days as well. So yeah, that was the next thing that I was going to talk about, which I already did, which is that Kinesis data stream, it gives you an option of keeping your data for 24 hours by default. Your data is going to sit there by default. You don't have to do anything. For 24 hours, it is going to be there. But you can configure this to up to 168 hours. So do note that some sort of additional charges apply for the streams where the retention period is about 24 hours. So don't unnecessarily keep your data if you don't need it beyond 24 hours. Usually for all of my use cases, I have used Kinesis so far. I don't want data to be sitting idly for more than 24 hours. Otherwise, I'm not using this service probably. I would probably use some sort of other thing like something else, not this service for sure. Here, I'm using this service because I want data real time, so not more than 24 hours. Okay, and Kinesis streams, they do support resharding, and that enables you to adjust the number of shards in your stream in order to adapt to the changes in the rate of data flow through your stream. So same example that you talked about, if let's say you started sending more data, it gives you very simple change itself that allows you to reshard. You started with 2, now you need 4. Just do it. Very simple thing to do. And there are two types of a resharding operation, which is a shard split and a shard merge. And as the name suggests, in a shard split, you divide a single shard into 2 shards. In a shard merge, you combine 2 shards into single shard. Again, you don't need to worry about this. This is again little additional information that I'm giving you. So yeah, just forget about it. Shard split, shard merge. You don't need it for this certification. Now, coming to the features of Kinesis. So we have already talked about that it has two sides to it. One is producer, one is consumer. For both the things, you have API as well as the clients as well. Apart from that, it provides you the 4 subsequent services that I already mentioned, which is Kinesis video streams, Kinesis data streams, Kinesis data firehose, and Kinesis data analytics. But yeah, so just we'll go through the architecture and the use cases of all these services. So Kinesis video streaming service. So for an example, let's say I have a camera and I've installed it on my door, and I just want to keep monitoring my gate itself just to see. I'm building some sort of application, and this application actually I've built. So there's one camera like directly pointing towards my car, and it keeps on recording if somebody else is coming near to it. It's a machine learning solution, so it fetches everybody's face, and if it is something like not my face, it just sends me a notification via push notification as well as SMS as well that somebody is approaching your car. So something like that. So this is an example of how you can use Kinesis video streaming to build your big data applications. Then Kinesis data streaming, same thing. However, here we have already talked about this as well earlier as well. So here you capture and sending some sort of data using Kinesis data stream from, let's say, EC2 instances. Now, Kinesis data stream, it will ingest and store this data stream for further processing. And then you work on this data, you build some custom real-time application using this Kinesis data that you're getting. And you send it to Apache Spark for further processing, write your own code in EC2 or Lambda functions. You did something out on that data. And finally, you are showcasing that output, the visualization of that output via some service like QuickSight. That is an example or architecture use case of Kinesis data stream. Then Kinesis firehose. So what it does, again, it captures and send data from your producers, whatever they might be, to your Kinesis data firehose, and directly it saves your data to further storing application like S3, Redshift, Elasticsearch, or Splunk. And yeah, that's all. That's all this service does. Kinesis data firehose. It just gets your data and stores that data somewhere in this kind of solutions. Now, Kinesis data analysis, the same thing that I mentioned earlier, that Kinesis data analysis, it takes your data and send it to something like Kinesis data streams, where you are further doing some sort of aggregation on that data. And in between, you want to do some sort of SQL queries on the data just to filter out things and things like that. So here, that's where you will use Kinesis data analysis. This will basically run just your queries on your real-time data. And again, this is the same thing that I'll show you in the hands-on as well. Data firehose is a service that you're going to be using whenever you just want to take the data and save it somewhere for permanent storage. That's all it does. Kinesis data stream here, and again, there are much more to it. That Kinesis data stream, you need charts. Kinesis data firehose, it's much more simpler. So whenever you need some more control over your data, what should happen? You are going to send it to consumer to further consume that data and do something on top of it. In that case, you will use Kinesis data stream. And if you just want to save your data, in that case, you are going to go for Kinesis data firehose. We'll come to the components, and kind of have already started talking about all of these components here, there, in between parts. So starting with producer. So I want you guys to tell me what exactly a producer does. No, producer does not do that. Producer, all is in the name itself. this is exactly where your data is being produced. So for an example, your Apple iWatch, this is where you have your again, Apple iWatch cannot have producer library installed on it, but for an example, some place where you can have it installed. Let's say you found something and you are installing that library. Easy to instance your own computer, that is going to be a producer. Is that clear? So yeah, that's what producer does. And as I mentioned, they have already created a library for you so that you don't have to write your custom code to be able to send your data from, let's say, your local machine to some place like, which is your Kinesis data stream. You just have to use that library, plug and play kind of library that will allow you to send this data. So I'm going to explain one by one all of these points. So starting point. So what it does is it writes to one or more Kinesis data stream. So you can have n number of Kinesis data streams. So for an example, you have one Kinesis data stream which is sending data just to be saved. Another Kinesis data stream that wanna do something your data, process that information, and all those things. Another application which is doing some other custom thing as well. So this library, it allows you to write to more than one place as well, and with an automatic and configurable retry mechanism, which means, again, a very big thing. If you're trying to implement this on your own, it's again a big task on itself, that you have to have this retry mechanism. Here, if something happens, let's say you tried sending a record, but it was not being sent in the first time itself, it is going to retry that automatically. So you don't have to worry about it. As long as you ran your code with publish send or something, you send your record to this particular library, to your Kinesis data stream, it will make sure that it will keep on trying for a few times until that record is fed to your Kinesis data stream. So that's your point number one. Then second one is it collects and uses this put records to write multiple records to multiple shards per request. Again, quite self-explanatory that it allows you to write put request. All of this put request will be able to write multiple records to your multiple shards per your request. So for an example, same example, in one request itself, you have the capability of writing to multiple shards, which means if your data is more than 1 MB, it will send 1 MB of data to shard number one, rest of the data to shard number two, and so on and so forth. Third one, it aggregates user records to increase the payload size and improve throughput, which means it, as I mentioned, it. So somebody mentioned it is you are just sending zero point 0.5 MB of data. It is going to wait for a certain time. It is going to live in that particular memory. It is trying to fill your shard itself so that you are not wasting on shard throughput. It will keep on collecting, aggregating those user records until you have a major payload size less than 1 MB for sure, just to improve your throughput. Then it integrates seamlessly with your KCL library, which means you have sent the records. Now you want to consume those records. You don't have to worry about this. Here you aggregated those records, which means your shards, they don't have a record, like it can have like poor increased payload size, which is all of your shards are merged. I mean, the data is merged together. But when you are consuming that data, you don't have to worry about it being aggregated there as well. It is going to de-aggregate it for you. However you sent it, you are going to receive it in the same fashion. This library works seamlessly with your KPL library, which is your producer library. KCL library works seamlessly with that library to do this de-aggregation. Now, last point, Amazon CloudWatch. Assuming that you have learned this in your prerequisite, that CloudWatch is a service that monitors the performance of your application. So you want to know how your Kinesis data stream is performing. It will send all these logs, how it is performing, related logs to CloudWatch, so that you have better visibility on how your producer performance is going on. Any confusion here? Say no if you don't have confusion. Now, just again, terminology. So there is a distinction between your KPL user record and Kinesis stream record. So does somebody has confusion with what is KPL user record and what is Kinesis stream record? Again, think about the same example, the log example that I mentioned. Try thinking on that and then tell me, do you have confusion on it? What is Kinesis stream record versus what is KPL user record? So KPL user record from our example, that I sent 5 logs, 10 logs, 100 logs, whatever. Those are my KPL user records, the logs coming in from my KPL client producer library. That is called as user record. And Kinesis stream record, I told you, it will keep on aggregating. It will keep on batching this data to accumulate all these records. So all of these records, once they are in your shard, they are called as Kinesis stream record. And yeah, one more distinction here. So user record is just your user record, which is your logs. But if you remember, when I started talking about this service, I told you that Kinesis stream record is not just going to have your data blob, it is going to have few other things as well. Can you name those three things for me now? There are three things that gets attached to your Kinesis data stream. It is what it consists of. What are those things? Absolutely. So user record is just your data blob. Kinesis stream record, it is data blob plus sequence number per partition key. It's just not data. It is more information to it. Clear? So, batching, as the name suggests, it is just like doing a bulk operation rather than doing operation on single records here in this case. So what it does, it aggregates as well as it collects. So there are two kinds of batching strategies when you are trying to send data to your Kinesis stream. And how that is done is via this logic, which is aggregation or collection. We'll learn more about this. So this is in your next slide. So aggregation, as the name suggests, it is storing multiple records within your single Kinesis data stream record. Basically, taking a huge chunk, compacting it, fitting it in one place, and then using or doing some operation on it.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Collection, it is using the API operation. So it is basically just sending put records to send multiple Kinesis data stream records to one or more shards in your Kinesis data stream. That's all it is. But yeah, we are going to talk about this much more detail. So that time it will be much more clearer. Anyway, this is not that important. Aggregation versus collection, it is abstracted from you. It is handled by default. It's just that you have option if you wanna configure it by yourself. So as I mentioned, the time I used Kinesis, it was only in Java. So this is how it looks like, how you send data. So you have some data from 1 to 100 here in this case. What it is doing, it is converting the data to bytes. And from that, it is just calling a method called add user record. To you are mentioning what stream you want to send this record to. You are sending the partition key as well and the actual data. And this is how it will be sent to your Kinesis data stream library. Sorry, Kinesis data stream. Just like how producer sends the record, once you have record in your Kinesis data stream, you consume that record via this library called KCL. That's all it does. So what it does, it allows you to connect to a stream. It enumerates the shard. Enumerates the shard mean it just keep on reading that this is shard number 1, this is shard number 2, this is shard number 3. So that is your enumeration. Then it coordinates shard association with other workers if required. So for an example, if this shard is associated with some other record as well, because anything that is same key can go into the same, it will definitely go into the same shard again and again. So if there is any mistake that something happened that another shard is also using this data, there is basically a duplicate. Usually there are no duplicates. That's why they have mentioned as well, if any. It takes care of that as well, that you should not have duplicates. Now, apart from that, it instantiates a record processor for every shard it manages. So what it does is there is a record processor function over here, and what it does, it fetches data from your Kinesis data stream for particular shard. For every key associated to it, wherever you want to pull that data, it allows you to do that. All of these things. Again, it might sound too wordy over here, but in operation, it is very simple, and that you will see in the next slide itself how it does. So this is the code for it. So this is all it does. So this is your consumer application code to get a shard iterator for a particular shard in Java. It is just getting, tell me, for this particular shard, what is the data? Then this is the code for shard iterator to going through that shard. And let's say that shard has log number 1, then next time I send 10 more logs, then next time I send 30 more logs, then next time I send 50 more logs. So it has 1, 2, 3, 4. It has 4 different sequence number associated with it. So I'm just iterating through all that and I'm getting a record for it, and it gives you a record in the list format. So yeah, that's pretty much it. We have covered a lot of ground on Kinesis data stream. We have covered its two libraries, KCL, KPL. We have talked about the internal terminology related to it, like what is shard, what is record, what is user record, what is Kinesis stream record, and few other things as well. So you can configure that behavior by default. Once it reads the data, it is gone. But if you want to keep that data for, let's say, 7 more days, I told you it has from 24 hours to 168 hours. You can choose to keep that data. In that case, even after the consumer reads it, it is going to stay in your shard itself. So let's say initially you wanted to read that record, something happened with your DB, you were not able to read it. It is still there. Next time, whenever you want to go there, read it, you just have to run your consumer code one more time. It will try to fetch that record again. In the meantime, what you want to do with your Kinesis stream, keep it running, keep it stopped, that is up to you. I told you, if you have the retention already in place, even if you stop it for 7 days, it is going to stay there. Okay, I think there are no more further questions. So there is another thing which is enhanced fan out, and it's basically an optional feature. Most of the time, if you are a newbie setting up your Kinesis data stream, you don't end up using enhanced fan out. But again, it comes in your examination. That's why it is here as well. So yeah, what it does, it gives your consumers logic. It basically gives you the throughput pipes between your consumers and shard, and this allows your customers or consumers to scale the number of consumers that are required to read the data in parallel while maintaining high performance. So basically, this will be explained from the next slide, which has the diagram. So let's go through this first. So your input, it is capturing and sending data to your Kinesis data stream. Now your Kinesis data stream, it ingests and stores the data streams for processing. It's sent to further tools. It could be EMR cluster, EC2 instance, Lambda function, Kinesis data analysis, data analytics. You did some processing over here. And finally, you want to output it. So earlier, what we were doing is we were doing one of these things. Either you were sending it to EMR, either you were sending it to EC2, either you were sending it to Lambda function. And finally, that particular thing was doing its job, which is storing it at last. Using enhanced fan out, what you're doing is you are giving the capability to the consumers to read in parallel. And that is achieved via this enhanced fan out thing. As you can see, you have this fan out going on. 1, 2, 3, 4. All the operations are going in parallel. So in this case, you can do n number of things. Again, your custom logic is required for that, but using this, you can do that. So it's the same thing. It has this different enhanced fan out pipes, and all of those pipes can be used by your multiple consumers, multiple instances inside those consumers, and things like that. So with this, we have covered Amazon Kinesis data streams, and now we are going to start Kinesis Firehose. So actually, we have already talked about Firehose. There is nothing much over here. One of you, whoever remembers, what is Kinesis Firehose? Yep. So Kinesis Firehose, as I mentioned, what you can do over here is, as you can see, you have one data source. You are sourcing those records, or you are sending those records to Kinesis Firehose delivery stream. If you want to transform those records, it gives you some sort of functionality in between by itself. But that is very basic, bare minimum transformation. It's not like something very custom that you can do via Kinesis data stream, where you could send it to EMR and all those places. And finally, you are just saving it to an S3 bucket or all the places that we saw earlier. That's all Firehose is. And just let me see, with this, we are done with Kinesis actually, and this data collection thing. Let me see if I'm missing something. If yes, I'll cover that. Otherwise, we are done with this one portion. And yeah, of course, if you have questions, go ahead and ask. Few other basic things. So KCL, your consumer library, it has something called vault tolerance, where it has this checkpointing capability. So what it does is, using that functionality, each consumer reads from a particular shard using a shard iterator, as we saw. And a shard iterator represents the position in the stream from which the consumer will read. And when they start reading from a stream, consumer, they get this shard iterator, which can be used to change, whether the where exactly the consumers read from the stream. And when the consumer performs the read operation, it receives a batch of data records based on the position specified by this shard iterator. And there are a number of limits within this Kinesis stream service that you need to be aware of, that I'll talk about after this. But any question with what exactly is this shard iterator doing? What is its job, or where exactly it might be helpful? If any one of you can come up with an example that, okay, shard iterator might be helpful in this scenario, that will be amazing. Okay. So shard iterator, again, taking the same example that I got from one of you, which is what something you're trying to read it and something happened, your database went down, your code application, whatever you were running, it went down. In that case, it's you were reading from in between. So for an example, you had 100 records in that particular shard. You were able to read 70 record. Now, what will happen if in between it breaks? Something happens, whatever. Could be due to any reason, something happens. So your shard iterator will take care. Okay, I know that you have read till 70. That is taken care of. You are at 70 position. Do you want to go back to position 1 and start reading from it, or you want to continue from position 71 itself? So that is just making it much more efficient. So if you have already read it, consumed that information, do you want to read after it, or you want to consume from the start itself? So this is what shard iterator is helpful for. Okay, hopefully that makes sense. And yeah, that's pretty much it that I'm able to remember. Yeah, was that a question? Oh, like this you mentioned. So that's what directly it cannot. But at the end, if you want to send data, what you can do is you can plug your data stream to data firos, and data firos, we know that it can send data.
Okay.
This is one of those scenarios where you want to make the best of both worlds, that you are using Kinesis data stream. You want to do some sort of processing, but you want to save data as well. In that case, does it make sense to just let go of this processing requirement altogether just because you want to save data? In that case, they have a workaround or a hack here that, okay, do something, whatever you want using Lambda function, EMR or whatever. And if you still want to save the data, what you can do is you can send this data to data firos, and data firos will, like, at the end will save this data.
Gotcha.
But
okay.
If you directly want to save, you can use data firos directly without Kinesis data stream. Okay, talking further about Kinesis firos. So in this case, you do not need to write applications like KCL, KPL, or you don't have to manage resources. You just configure your data producers to send data to firos, and you automatically delivers the data to the destination that you are specifying. We have already seen what those destinations are, like S3 and all those things. And you can also configure Kinesis firos to transform your data before data delivery. So unlike a lot of other AWS services which have a container that sits within, for example, DB instance with RDS and all those things, Firos does not have any of that. So where exactly you might want to use it? So let's say a web service sending log data to Kinesis data Firos is your data producer in this case. Now each delivery stream, it records for up to 24 hours in case the delivery destination is unavailable. After 24 hours, your data will be gone. So if you are not able to, let's say, save it to S3, make sure that you do in 24 hours, otherwise your data will be gone. Now, all these destinations are S3, Redshift, Elasticsearch, Splunk, and all those things. And within your delivery stream is a data flow, which is effectively the transfer and the load process over here. And the data flow, it is predetermined based on what target data source that you are configuring your delivery stream to load data into. So for an example, if you're loading data into Redshift, the data flow defines the process of lending the data into an S3 bucket. And then there is something called copy command to load the Redshift table. So as per you mentioned that I want to save this data to Redshift. But in the backend, that's not what happens. Your data first goes to S3. You are not aware about it. You don't see that data in your S3 bucket. From there, it uses this copy command to load that particular data to your Redshift table. Now your Kinesis firehose, it can also invoke an Lambda function, okay, to transform incoming data before delivering it to a selected destination. But this is only Lambda function. There is nothing else that you can use that you were able to use with Kinesis data stream like EC2, EMR, all those things. Those are not here. But if some sort of basic processing is required, you have the option of using a Lambda function to transform your incoming data further before actually sending it to your S3 or any of the selected destinations. Now, using a Lambda function is fairly simple. I'll show you later once we are on the Lambda topic. But they have a lot of blueprints that AWS provides. Blueprints are nothing but templates which do all of these jobs. Like for an example, check for duplicates, rename the column names, and things like that. All of these blueprints are available. You have to just pick those, make changes as per your requirement, and just use those things itself, and just get it going with it. Kinesis data stream, it's a real-time service. And Kinesis Firehose, it's near real-time, which means you send data, you received it here in your consumer, Kinesis data stream, this is how it will happen. But Kinesis Firehose, there is some sort of lag. I'm not able to remember what exactly is the lag, but there is some sort of lag in your Kinesis Firehose. Good that I remember that. Is that clear? Okay. So whenever that's why all of these things define exactly which service is better for you, Kinesis Firehose or Kinesis data stream. And your certification questions are based on this kind of scenarios as well. That in scenario, they have returned that I want a service which will take care of my near real-time data. I don't need a real-time application. In that case, why do you want to complicate everything and go for Kinesis data stream? In that case, the answer they are looking for is going to be Kinesis Firehose because it's fairly simple to set up. There is no shards required, all those unnecessarily things required. But if they are explicitly saying that we want a real-time service, in that case, Firehose goes as an option because Firehose has a lag, which is, I think, 60 seconds. So Amazon Kinesis Firehose, it is a service for workloads that requires zero administration. You don't want to worry about shards or anything like that. You don't just want and you are okay with this near real-time latency, which is 60 seconds or higher. In that case, you want to go for Amazon Firehose. So what you are saying is Kinesis data stream takes that aggregation, collection, all those logic. So by that logic, Kinesis data stream should be a service giving you this latency. But in this case, that is not the case. Here, what is happening is Kinesis data Firehose has this lag. Why do you have this lag? Because it is customizing or managing a lot of things on your behalf. How they are doing it, their architecture makes it in such a way that it has created some sort of lag. But there in Kinesis data stream, you have a lot of flexibility. You don't want, so basically as a customer, if I am doing a lot of work from my end, I want better results from you, right? So that's what is happening. You have this library to maintain all this thing, but as a result, you are getting real-time data. But here you are not doing anything. You're just saying, send my data. So a drawback of that is that in order to do that, you are going to have near real-time performance. Okay. Apart from that, so we use Firehose by creating a delivery stream to a specified destination and send data to it. Here, in this case, you don't have to worry about stream. You don't have to worry about charge. You don't have to create a custom application. All of those complex logic is gone when you're using Firehose. And apart from that, you don't have to specify partition keys. You don't have to, unlike data streams where you were mentioning partition keys as well. Now, thing is that Firehose, it is very limited to only few things, which is your S3, Redshift, Elasticsearch as your destinations. You cannot send it to anywhere else, which you can do with your Kinesis data streams. You are free to use any of the AWS services which might be able to handle data. So for an example, if you want to save data, again, they might be asking you this question in certification that I have a requirement where I'm going to process this web service logs, and those logs needs to be processed before sending it to DynamoDB. What solution suits my requirement? In that case, again, it is your job to eliminate the answer, which is your Kinesis Firehose, because it does not save data to DynamoDB. Make sense? Okay. So in this demo, I'll be creating a DynamoDB table to store a random like basic data for pet inventory data, which I have created by myself. And in this scenario, like the data architect on the team, this is the scenario over here that a data architect on the team has requested a table definition with a partition key called pet species with certain data type called string, a sort key of pet ID with the data type number, and the table should be named as pet inventory. And because the workload in this development is not known, I do not know how much information or how much data I'll be storing in this table. I don't know how many people are going to be accessing this table. So if you remember from a discussion, we can have two kinds of table. One is on demand, where you just ask for a table, AWS gives you, and they scale it for you. But here you have some lesser amount of control, and cost may be little higher. They try to optimize cost for you, but it might be little higher, and it does not give you all that WCU, RCU things, which actually contributes to your cost. And that's why we are not going to be seeing that. We are going to be seeing the on-demand provisioning of your table. And yeah, we'll just get started. So first, I'm going to create a DynamoDB table using AWS Web Console. So this is your Web Console, the UI of AWS Console. Then we are going to do the same via CLI as well. And then if time permits, I'll do the same with Boto 3 library, and you'll get to know what that is as well. So basically, these are the different ways of creating a table, and we are going to cover all of them. So first thing, we'll just search for DynamoDB. In this case, I can clearly see DynamoDB is here in my recently visited tabs. So I'll just click from here. Otherwise, you can just search for it. Over here, I'll click on create table. And as I told you, the name of this table should be pet inventory. You can call it whatever you want. And a partition key I mentioned is going to be of type pet species. And that is of type string. And there is a sort key. It is optional, so you can leave it. But in our case, I'm going to use the sort key as well, which is pet ID. And this is going to be of type number. And in the table settings section, we'll uncheck this option called default settings, and we'll click on. So as you see in default settings, this is what they provide you: 5 RCU, 5 WCU, auto scaling will be on. So they'll do it on for you. It is called as provision mode. It is owned by Amazon DynamoDB, and all the table related parameters or metadata. And another option is you have the option of customizing it as well. And in customizing, as I mentioned, you have the option of providing all these things. Provision, you can write how much WC you want and all those things. Write capacity, read capacity. In this thing, I'm just showing you how you can do all that. And there is a capacity calculator over here as well. It tells you how much you will be paying for that table for whatever RCU, WCU you are using. But in our case, I'm going to stick to the default settings, which is 5 RCU, 5 WCU, and that's pretty much sufficient for this particular table. And I'll just click on create table now. So yeah, it's as easy as this to create a table. Any questions till now? We have created a table. Okay. So yeah, this is done. I'll just delete this table, and we are going to again create a table, but this time using a CLI. Delete. And I'll open a terminal. You can open whatever terminal you have. I prefer this one called iTerm, or you can just go for the terminal itself. I'll increase the font size. To log into SSH, you have to do something like this: SSH, your username, whatever is your username, @ the IP address. So I just logged into my Amazon Linux account, which is your EC2 instance. all I did is SSH your username at the rate whatever is the IP address of that EC2 instance. And then I'm inside it will ask you for the password. Just provide that password and you will be logged into Amazon EC2. Now I'm going to create a table using CLI. So it goes something like this. You have to type AWS DynamoDB create. Actually, I don't want to write this much. I have it pasted. So I'll just copy that. Where is it? So yeah, this is how it goes. You type AWS DynamoDB, you look for create table, you provide the table name, how we did it in the console as well. There are certain attribute definition that you need to provide, what we provided there as well. So in this case, attribute name is pet species and it is of type string. Another one is pet ID, which if you remember was a sort key, and that is of type number. Then we have a key schema. Here you define which one is what kind of key. So key type, this is the option that you have to notice on. So this one is of type hash and this one is of type range. I know you might have forgotten, but while telling you about DynamoDB, in theory I mentioned that your primary key is also called as hash key and your sort key is also called as range key. So here you don't have the option of providing primary key or sort key. Why in doing from CLI, you have to mention the primary key by the name hash and sort key by the name range. I hope that makes sense. And finally, the billing mode, it is paper request, which is nothing but on demand. And this is the output that I got. So I ran this much. And if somebody wants it, although it's available on the internet, I'll give it in the chat as well. For some reason I don't have option to access chat, but anyway, this is fairly easy. You can just Google it, create table query, and you will find the same thing. Otherwise you anyway have access to this thing. Oh yeah, Varun, yeah, I got access to chat now. Thank you, Varun, for messaging. And all we have to do now is go to DynamoDB and check if the table was created. So there are two things that I can do. Either I can check it directly from here, or I can go to AWS and then check it over there as well. So first, let me do it from here. So for that, command is AWS DynamoDB describe table and then provide the table name, which is pet inventory. And as you can see, as the table is created, it is giving me all the description about this table, whatever attributes that we have chosen, what is the provision throughput, size. Right now it does not have anything, so size is 0, whether the table is active or not. So it is showing as active. That means a table got created. There's another command. Let me first give you this command. Apart from this, you can list all the tables that you have in DynamoDB. All you have to do is type AWS DynamoDB list tables. And it is giving me the only table that I have in my account, which is pet inventory. And there is another option of checking if the table was created as per how we requested or not. So for that, we type AWS DynamoDB describe table and the table name pet inventory. Then there is an option of querying that table. The query would be table dot partition key schema. Don't worry about all these things. These are again available on the internet or their documentation. All I have done is just change this fields like whatever I have, the table name, whatever I have provided, and all those things. Key type. I definitely typed something wrong over here. Let me paste it. Yeah, and can someone tell me what this query is doing over here? So here we are actually checking whatever attributes we provided, are those properly created or not. So I'm just querying my table with its metadata that, okay, what is my sort key? What is the type of that sort key? What is the billing mode this table was created with? What is my partition key over here? And what is the sort key type, whether it's a string, number. So this particular command is useful for that. I'll send this one to you. And finally, we'll do one thing, which is to delete this table. And command for that again is very simple. DynamoDB delete table, table name, that is pet inventory. And it is giving me that it is deleting this particular table. To just ensure that table is deleted, all we have to do is run this command again. DynamoDB describe table, table name, pet inventory. And this should give me the error that there is no table called pet inventory. It is not available. And we can check it again by this as well. DynamoDB list tables. And it should also show that there are no tables available. So we have seen how to create a table and how to delete a table from your console as well as your CLI. Now we'll do one last thing, which is we'll try to do it the same thing from a library called Boto3 SDK. So if you have not heard about this library, so this is the name of Python library that AWS has created to interact with your AWS account via SDK. So how do I do that? What is this? Always allow. Okay. So for that, we'll just go to Python. In Python, I'm going to import this library called Boto3. And I'm going to create a client object. What would be the client? Somebody tell me. What would be the name of client? Which client we are trying to interact with? Come on. What are we actually doing? What lab is this? Which service? No, the service, name of the service. DynamoDB. So my client is going to be DynamoDB. If I wanted to see or talk to my S3, I would have typed S3 over here. Same goes for any other service, EC2 or whatever. The client remains same. The library remains same. The name of the client will change. So in this case, this is how you create any object to react to talk to any of the AWS service. You type boto3.client and provide the name of the client. Hope that makes sense. So this is done. Now I'm going to be creating a table, but again, I don't want to type everything. So I have it already typed. Let me just find it. But it's going to be the same information what we have been using so far. You will just see it and you will understand. Here, using this object that we have created, DDB session, DynamoDB, I am using a method called create table. I am defining attribute definition. What is the name of my sort key, oh sorry, what is the name of my primary key, what is the type of that primary key, what is the name of my sort key, what is the type of sort key. Then I'm going to provide a schema over here, and I told you the name of your primary key and the type of your primary key would be called as hash. Name of your sort key in CLI or in SDK, it will be called range. Do remember this. They sometimes confuse you in examination question to see if you know the name of this hash keys. Primary key is also known as hash key, and other one sort key is known as range key. Same goes with billing mode. You type paper request, and finally you provide the mandatory attribute, which is table name. And I'm just going to enter, and yeah, there is no response. It ran. All I have to do is check what is the response I got from DynamoDB. So for that, Python, it's fairly easy. You just type print, and whatever you have stored in this variable called create response. So it gave me all this information. This is what I got from Amazon. To parse this information, it's not so pretty to read. I'll just sorry, I typed it again. So all I have to do is I have to type create response and filter it with things that I want to know. I want to know the table description. So this is my table description. Then from table description, I want to query further or filter further. What is the attribute definition? Sorry, yeah, attribute definitions. And it, oh sorry, it's called create response. I've typed create only. Come on, go. I'll type it again. Create response, enter. What I'm doing wrong? Oh, I'm not printing it. Oh yeah, Python create response. This is what I got. Copy and call it response equals to basically let me try it again. Description. What am I missing? I'm not used to this big. Python 3 response. Import go to 3 DDB equals to go to 3 dot client DynamoDB table already exists. Damn. I'll do one thing. I'll just change the name of this table and I'll create another table. Done. Create response. Run table description. And let's say I want to know what is the key schema. And this is giving me the key schema, what I have defined I can change all these things. I can just know table status, table name, all these things by filtering it. Now we can create this another status variable called, let's say, status response, and I'll just describe this table. Table
Can you
name
paste all this
equals
code on the chat once you're done?
so this is done. I've provided the name of this table. Here I'm checking the describe table and I've put it to a variable called status response. And this is what I'm getting as a response from Amazon DynamoDB. And finally, what else? Yeah, last thing that remains is delete this. Or first, let's see how many tables are there. So ideally, there should be two tables, ddb.list tables. And I'll print list response. And as you can see, there are two tables, pet inventory and pet inventory 2. And finally, I'll delete this table. ddb.delete table. Table name equals to pet inventory. And I'll print the delete response as well. Over here, you can see the table status as deleting. I'll delete the other table as well. Pet inventory 2. And finally, I'll again do the list tables command and it should show me nothing this time. So as you can see, table names equals to a empty list. That means I do not have any table. So with this, we have created table from console, from CLI, as well as from SDK as well. So this was an introduction to CLI and DynamoDB for the people who have not seen it. Let's just do one more thing, which is obviously my favorite thing to do because that is the easiest and that is the easiest to replicate. So let me get started with that. And that is who has heard here about cloud formation? I know people have cleared some other certifications, you have gone through prerequisites, so definitely you at least should know. Absolutely. And again, this is also what I do as well mostly. So I try to automate stuff for the people who are whoever is on my team or the people who are new joinees, so that there are no mistakes down the line. Whatever best practices we have set up, those are being followed across. For that, cloud formation is the best thing. So I'll give you one example of cloud formation. So for an example, this lab, I keep on taking this classes, and for every class to create different scenarios, like okay, I want to create a DynamoDB role. In that DynamoDB role, I need to have access to EC2 instance. I need access to a public subnet so that I can talk to the internet, and then other things. All these things I don't want to set up again and again. So for that, what I have done is I have created a cloud formation templates. So whenever I show you all this stuff, I do not waste all my like half an hour or 1 hour before class to do all these things just to show you all these things in the class. So what I do is I have created all this cloud formation templates for different labs that I show here. And in this case, I'll show you my template for this class. So this is what I have written, and you don't need to know right now. This is little advanced, not that much as well. So here, as you can see, so far I have an access to AWS EC2 account. I was doing all these things from EC2. Then I need that EC2 in a public subnet, which means I was talk just anywhere from the world. Does not matter if I have today this laptop or some other laptop. If I'm having this Wi-Fi or another Wi-Fi, I should be able to talk to this EC2 instance. So I've made that EC2 instance public by defining it over here. I've created an internet gateway for the same thing. Then there is a route table associated. Then there are a lot of things. I have created a VPC route table. Then there are security group, whatever I have assigned over there, and few other things. Who should have what? So for an example, in this lab, if you saw, I didn't have to create DynamoDB role. By default, I had that role to create DynamoDB table. But when you are doing it on your own, you might not have if you are using somebody else's account and not your account, in your own account, you're obviously admin, so you can do everything by default. But let's say you're using somebody else's account. In that case, you might not have access to DynamoDB. So in this lab, as you can see, I have set up this access key. I have given myself a DynamoDB admin profile so that I can do all the operations on DynamoDB. And that's why we didn't have any hiccup while talking to DynamoDB, because I was the admin for that. So all these things I have done from this cloud formation. And the same thing that we are going to do over here is I'm going to show you how do you use cloud formation. Again, it is not related to this certification. It's related to your DevOps certification. So I'm just going to show you how to create a DynamoDB table using a cloud formation template. So I hope that much makes sense. I mean, the answer to this would be all of the above. There is so cloud formation. There are things that you cannot just directly automate, or that automation always works out. So in some cases, wherever you want flexibility, console and CLI are your go-to friends. And whenever, let's say, somebody is new, whoever has not access or not have much experience to CLI, they probably would prefer console method. But mostly the recognized way, let's say 70 or 80% of the time, people do end up using something like cloud formation. This is not the only option. There are other things that can help you with this as well, but yeah, most of the time this is what people use. So here there are few options. Template is ready. I do not have a template ready. I do have to create, so I'm not going to choose this option. Use a sample template. So AWS does provide you all these sample templates that you can play around with. It's pretty cool. So with this one click, you will have a WordPress blog for yourself ready with a RDS database, with EC2 instances, with all the things. With one click itself, you will have a WordPress website for yourself. And this is the probably one of the first things that I tried when I was learning AWS. It's pretty cool. You can try this again, but it might charge you. So yeah, be careful with that. If you might go across your free tier with this. Now I'm going to be choosing this option, which is create template as designer. And I actually don't like this approach. I like to write a YAML or JSON file, but to show you this, I'm going to do it this way. So let's search for DynamoDB. Where is it? Where is it? DynamoDB, and drag this table over into this canvas. This is called as canvas. So as you can see, we have brought a new resource, which is a DynamoDB table. Now in the properties box below, make sure it is showing you the components. Delete the existing components code, whatever you're seeing. So as you can see, this is the components, and you can do everything from here itself, but I don't like that. So I'll just delete everything from this component section, and I'm just going to type my own code, which I already have pasted. And to see the result, all I have to do is click on this refresh. I have pasted it over here, and as you can see, it already has a name. It's called pet table, and every information, whatever we provided, pet species, pet ID, and all those things are mentioned over here as well. So this is your CloudFormation homepage. You click on create stack, and you can choose this. And over here, as you can see, there are three options. Template is ready, use a sample template, or create a template. So I clicked on this create template, and then I clicked on this create template in designer, and this brings me to this screen over here. Awesome. So yeah, my table is gone again. It could be a JSON or it could be a YAML. I prefer YAML. The one I have given you is a JSON. It's a JSON, but here there is a option over here. Choose a template language. Even if you provide JSON and you click on YAML, they will create a YAML for you. Not a problem. That's fairly easy. Even if you don't want them to do it, there are online things, JSON to YAML online, and you can do it over here itself. It's the same JSON, and they have converted it to YAML. Okay. First, I have to close this. I have two designers open, so it is confusing. And here there is something to check this as well. Where is that? I'm not able to find. I mean, I know my YAML is correct, but they do give one option to check if this YAML is correct or not, because there might be mistake, because cloud formations templates can be very long, like 200, 400 lines of code as well. So which one is that? That I'm not able to find right now, but anyway. This one, I think. Validating the template. It is checking if my template is correct. So as you can see, this is valid template. So I've saved this template. I'll close this. Again, create stack. Now this time we have a template ready, and it's not in S3, it's in local. So I'll choose the other option, which is your upload a template YAML, file. And that file is called pet table. So it will be in downloads, I think. Let me search. Click next. Provide name to your stack. You can call it pet inventory stack. Click on next. Leave everything default. Go to the next again. And yeah, submit. And we'll just now monitor the progress. Whatever is happening, you will see in this event section. So let's wait for it to complete. I'll keep on hitting refresh. As you can see, pet inventory stack, it is in progress. It is trying to create a table, pet table. It is also in progress. So as you can see, it has created completion of my pet table. Now all I have to do is just go to DynamoDB to see if this table is created or not. DynamoDB tables, and it has this table with a partition key of pet species and a sort key of pet ID. You want to see this table, this you can get every information about this table from here. But yeah, that's pretty much it. I am just going to delete this table. And yeah, with this we are done with our demo on how do we create DynamoDB table using a CLI, using a SDK, using a CloudFormation template, as well as console. So there are a lot of ways actually to do that. So you can do that using something called as AWS data pipeline, and that would be the easiest approach. And that would give you this one-click thing that you're looking for. So it will export all of your data from DynamoDB to S3 or vice versa, from S3 to DynamoDB. So that is what I would recommend if anybody want to do it. But then apart from that, there are a lot of ways you can write your Lambda code. You can use S3 export and then import it over here. Then you can use EMR, and there might be a few other things which I am not aware of, but these are the things that are coming to my head right now. So yeah, so far we have learned a lot of things about DynamoDB. What are the DynamoDB related concepts, replication, best practices. Let me see where we left off. Eventually consistent, strongly consistent. Yes, this is what I showed you just now. Provisioned is what we use, which is default for your free tier, or you can go for on demand as well. Actually, from here we can start. And yep, so do remember all the scenarios, because they are going to ask you questions or give you scenarios related to that I have a requirement where I don't want to be worrying about how much I would be paying, what all I have to do. I just want to get started with DynamoDB. In that case, on demand mode works for you, but do not choose on demand mode when they are asking you that you want table serving what a known workload of, let's say, some thousand megabytes, kilobytes, gigabytes, whatever. If they are specifying something, in that case, on demand mode is not your option. You should go for a provisioned option, because that is much more cost efficient. So firstly, by default, somebody tell me what is the mode that DynamoDB uses by default: strongly consistent or eventually consistent? Eventually consistent, true. So consistent. So DynamoDB uses consistent reads unless you specify otherwise. Now your read operations provide you a consistent read parameter. And if you set this parameter to be true, DynamoDB will start using strongly consistent reads during your operations. Now, if you use eventually consistent reads, you'll obviously get over here, you are going to get twice the throughput in terms of reads per second. A unit of read capacity, write capacity unit, it enables you to perform obviously one write per second for items up to 1 kilobyte in size. Now you can calculate the number of units of RCU and WCU that you need by estimating the number of reads or writes you need to do per second. It's as simple as that. Let me write it down so that it is you can make a note or something. So you can calculate this by estimating the number of reads or writes you need to do per second, and finally you have to multiply that by the size of your items and round it to the nearest kilobyte. I'll type KB. Now, table with secondary indexes, what do you think is going to happen if you are using secondary indexes? DynamoDB is going to consume additional or less capacity unit. This is a question for you. Think through whatever we discussed about secondary indexes and then give me this answer. Yes, absolutely. So in that case, it is going to consume additional of your WCU units, and that's why I mentioned do not unnecessarily create 10 secondary indexes or create any indexes which you are not going to be using, because even though it gives you performance, it helps you not reading the entire table, but it increases your consume capacity. So your WCU, RCU will be consumed much more than your usual table without any secondary indexes. So this is what I wanted to highlight over here. Now I'll give you example. So let's say, for example, if you wanted to add a single 1 kilobyte item to a table. So for an example, currently I created this table called pet inventory. Here I just want to add a record which is 1 kilobyte. That's it. I just want to add the name of my pet, the species of my pet. So my pet name is, let me type that name. So my pet is called Dante. He is a German Shepherd. And what? His owner, Harsh. I just want to include this much information, and this is not going to be more than 1 kilobyte. This is the data I want to write to my table called pet inventory. Okay. So yeah, this is the example that I want to add 1 kilobyte item to a table, and this is my data of 1 kilobyte. I want to add it to this table called pet inventory. Now, and in this case, this item contains an index attribute. In that case, you need 2 WCUs. Why? One for writing to the table, another one for writing to the index. Let me know if this is clear or not. Why I need 2 WCU in this case when I'm just writing 1 kilobyte of data. So although our DynamoDB performance, it can scale up as your needs grow, your performance is still limited to the amount of, let me write this is important. So your performance is dependent on whatever the number of RCUs and WCUs you have. How? Because your DynamoDB can keep on scaling. It does not hold you from storing n amount of data. It will keep on scaling for that. But your performance, it will be very limited to the amount of read and write throughput that you provision for each table. For an example, you have created this pet inventory table with 5 RCUs and 5 WCUs. Whatever 5 RCUs and WCUs can do, it will do only that much. After that, it will stop not performing, or it will be not that performant. Hope that makes sense. Now, if you expect a spike in your DynamoDB usage, in that case, you will need to provision more throughput in advance, or your database request will start failing. That you are asking for data from your table, but your read capacity unit is over. In that case, you will get a response which is not 200 for sure. It will say, okay, whatever you are trying to accessing, you cannot access that, something like that. Some sort of exception error will occur over here. Let's say this is an example of your e-commerce website. You have provisioned around 2000 RCUs, which works for you all year. Every work, whatever you need, 2000 RCUs are more than enough. Now, all of a sudden, you have this Black Friday sale. In that case, much more traffic came, so many people start accessing your website, and 2000 is not sufficient for you. So till 2000 your table will perform really good. All those initial customers, whatever they try to access, they will be able to do it. But after that, other customers, they'll start seeing some sort of error because your read capacity unit is over. It does not scale this automatically on its provision mode. All you have to do in this case is just increase this. You saw more user came, calculate how many users more can come, how many read you might have. Just increase this from 2000 to 2500, something like that, and it will not fail anymore. So yeah, this is how you scale with DynamoDB, and it goes for writing and reading both. In this case, my reads were failing because so many people were trying to access it. Now they are trying to obviously place order as well. I was able to work well with 1000 WCUs all year throughout. Now in this Black Friday sale, so many people are placing order. So I am having new customers and I'm writing their data to my DynamoDB, and I'm not able to write anymore. They will also see error in processing your order or something like that because you do not have enough WCUs to reach out to your DynamoDB table. All you have to do is again increase WCU from 1000 to 1500. Make sense?
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
That's what I mentioned over here. So this is for your provision mode. Provision modes you use, and this is what is written over here as well. When you know what kind of traffic you will expect. Then apart from this, you already have this on demand mode. On demand mode, AWS is calculating this for you automatically. You don't have to worry about it. It's just that you lose that control. Sometimes they might over provision, right? Yeah. Usually this is what they claim, that they try to manage this as efficiently as possible. But of course, they they do this automatically to make sure that there are no failures. So obviously, what do? If there is any pandemic coming, you know about, like let's say in 3 months, you will over provision, you will keep much more grocery at your home, right? Same thing they do as well over here. But in this case, let's say you have a tight budget, you will go for this provision mode. You will keep, okay, I think pandemic, I'll survive in this much, I'll ration and whatever, so I'll use this provision mode. I know, okay, sometimes my stock get over, what I have to do, I just have to pay more, I just have to increase this WCU RCU, and it will start working again. So that's why they give you both options. It's up to you what you want to go for. Okay. Now, the last point about DynamoDB concepts is about partitions and data distribution. So partition is obviously is the allocation of your storage for a table, which is obviously backed by a solid state drive. Your data is stored in solid state drive, which is what gives the DynamoDB its performance. And it automatically replicated across multiple AZs within your AWS region itself. And this is entirely handled by DynamoDB itself. You never have to manage the partitioning yourself. However, I'll talk about partitioning a little more. So all those things I don't think are given here in the slides. So I'll write it down, and please write it down with me if you want that information. Let me just charge my laptop. Yep. So as I mentioned, the partition management it is handled entirely by DynamoDB. You do not have to worry about it at all. You do not have to configure or manage the partitions. Now, when you create a DynamoDB table, DynamoDB allocates the table's partition according to the provision throughput setting that you specify. This is for your partitions. A single partition, this is not returned, so please note it down. I might not be able to provide this information later because this I'm just typing it from my head. So a single partition, it can hold up to 10 gigabytes of data, and it can support maximum of 3000 RCUs or 1000 WCUs. So if you increase a table's throughput provision and the table's current provisioning schema cannot accommodate your new requirements, in that case, DynamoDB will double the current number of partitions. What I mean to say is, for an example, the same example, e-commerce example, so far you were working with, let's say, 3000 RCUs. That is good enough for your entire year, most of the year. In the sale period, you had to provision about 3000, so now you're working with 3500 RCUs, and 3500 RCUs cannot be stored in single partition. So what AWS will do, they will create two partitions for you. And as I told you, this is automatic. It is dependent on your RCUs, WCUs, so you don't have to worry about it. They will take care of it, but this is how they take care of it. This you might not find in this PPT, so please do note it down. It might be important while you are actually doing it for your certification. All these numbers are usually not that important. Now, what else? Now, to write an item to the table, what DynamoDB uses is something called as value. This information I think is present over here. Yeah, this is present over here. So I do need some space to type. Let me see. Text. Now, to write an item to the table, DynamoDB uses value of the partition key as an input to an internal hash function. And this, I think I have already given you this information. So this X is nothing but value of partition key. This goes as an input to your hash function, and this hash function, the output value from this hash function, it determines the partition in which the item will be stored. Now, to read an item from the table, you must specify the partition key. I have already told you, without partition key, you cannot create a table. Now, DynamoDB, it uses this value as an input to its hash function, returning the partition on which the item can be found. Now, to assist the partitioning algorithm, Amazon recommends that choose a partition key. This, let me see. I don't think they have this information, so let me write it down. So this is Amazon's recommendation, that choose a partition key that can have a large number of distinct values relative to the number of items in your table. Now, indexes are also partitions, just like your base tables. You need to load your data into DynamoDB before you can query or use it. Now, data is normally loaded into DynamoDB via application that is using the NoSQL database as its backend service. These applications, they can be written on various languages, including Java, JavaScript, Node.js, .NET, PHP, obviously Python, or Ruby. There might be few others, but this is what I remember right now. Now tables and items are created, updated and deleted through the DynamoDB API. So whoever was asking that question, how do we query the data? How do we access the data? How do we write to DynamoDB table? It is done through this DynamoDB API. There is no concept of standard DML language like there is. Let me write this down as well. There is no concept of the standard DML language like there is in your relational database world. What is DML language? Something like SQL. There is no SQL for DynamoDB. You cannot write queries in that form over here in DynamoDB. Manipulation of your data in DynamoDB is done only programmatically through object-oriented code. Now it is possible to query data in a DynamoDB table, but this is again done only programmatically through the API because there is no language like SQL over here. So it is important to understand your application's data access pattern well in order to make sure the most effective use of your DynamoDB table. Alternatively, what you can do is, if you want to actually query your data, alternatively, this is the best approach to do it. But let's say you want to do it some other way. You can use Amazon console and your CLI as well to import data from S3 into a DynamoDB table. Another option is to use, I told you, Amazon data pipeline for your question on how to load data to DynamoDB table. This is what perfectly uses combination of S3 and Amazon EMR to load the data into DynamoDB table. There are also few other third-party tools. I'm again, do not take me by its word. It's just as per my experience. This is what I have used and I liked it. So there is something called Razor SQL, and it allows you to. I found it very easy. So it allows you to load DynamoDB data or data into DynamoDB basically. To access DynamoDB data, your application or your reporting tool, what they do is they send an HTTPS request to DynamoDB, and that's how you get the data. So these are the options that you have to access data or manipulate data in DynamoDB. I'll stop here for questions. So you cannot access your DynamoDB data using standard ODBC or JDBC connection or via standard SQL query, which means your standard business intelligence tools like Power BI and Tableau and things like that, they cannot directly access your DynamoDB data sources. However, there is a workaround to it. Always, most of the time there are workarounds to things like this. So there are third-party offerings. Again, if they do not work well, there is some issue. Amazon is not responsible. They are third-party tools, but you can do all these things via CData. It's a third-party tool. It provides a ODBC style driver that will talk to DynamoDB, effectively becoming an interpreter in between. And there are other BI tool vendors. If I remember the name correctly, it's called SciSense. They have also created a DynamoDB access engine for their tool. Apart from this, Amazon is planning to enable access to DynamoDB data from their own service, which is QuickSight, in the future, but this is not done yet. DynamoDB is not relational NoSQL database, and that's why it does not support table joins as well. Table joins are not supported. Instead, applications read data from one table at a time. So if you wish to join data, you will need to retrieve the data from each table and then join it your own application code or your reporting tool by yourself. There is no option of table joining by default. There is, again, this much information is sufficient. There will be addition. Let me see if there is anything more. Yeah, I think that's pretty much it. I want to tell about DynamoDB over here. I've already told more than whatever was expected. Any questions? So yeah, this I was writing so that you know what do you have to focus on for this examination. So do understand what are the key concepts on partitions from this lecture. Understand RCU and WCU. How do they impact performance? Understand how partition key choices impact performance, the same example that we talked about just now. Understand sort key selection, when you are doing it, how it impacts, and things like that. Apart from this, be aware of the underlying storage infrastructure, like how partitioning is working, how partitions are working. Know a little bit about that. Now be aware of what influences the number of partitions, which is your WCUs and RCUs. Know about the capacity, know about performance. In DynamoDB world, it is entirely dependent on your WCU and RCU. Be aware that if they increase, but they don't decrease. Now be aware that table performance is split across the partitions. What you apply at a table level isn't what you often get. True performance, let me write this word, true performance, is based on performance allocated, key structure, and time and key distribution of reads and writes. So it just not increase RCU and you will get good performance. It will increase partitions, and partitions will ensure that you will get good performance. Not the case always. What can happen? You have chosen this well, all of these things, RCUs, partitions, performance, but you ended up choosing a sort key which is underutilized. In this case, you are going to have bad performance. Same goes for you unnecessarily created secondary indexes thinking that they increase the performance all the time. But again, those indexes that you have chosen, nobody is querying on those indexes. So that selection is wrong. Bad performance, increase cost. So other factors are there as well when you're talking about true performance. In concept or in theory, increasing RCU, WCU increases performance, having more partition increases performance, having a sort key increases performance, having a secondary indexes increases the performance, but only when chosen appropriately, not always. So hope that is clear. Yep. So first one, the point, as you can see, as I mentioned already as well, your RDBMS systems, they are good for analytical processing, which means queries which requires joins, lot of like big queries, basically. All those things are required when you want to go for RDBMS kind of solution. But DynamoDB are good for things like gaming leaderboards, e-commerce website, web scale applications, where you want all the social networks and all these things where you just want OLTP kind of transactions. It is good for those. Next one, you can use all of these things and the other things which I have mentioned as well, like Razor, SQL, and all the third-party tools. Those can be used as well in order to access data. Performance. Okay, so this one is more for storage and this one is more for compute. So things like that, whenever you need this kind of things, like, okay, get this data quickly as soon as possible within multi-second latency, milliseconds latency, DynamoDB is your go-to tool. And if you have worked with RDBMS, they are usually not that quick because they're not designed for that. They are designed for optimizing storage. They want to handle a lot of data. They want to handle processing of the data in a longer run for all this analytical queries where millisecond latency is not required. Scaling. Yep. So we have seen with the DynamoDB is a distributed architecture. So you can have low cost hardware and you can just keep on increasing those low cost hardware, and that will not cost you as much as scaling for an RDBMS system will cost you. What else is there? this we have seen. If you want to reach out to your DynamoDB, all you have to do is create a HTTPS connection. API, DynamoDB API is there. You will ask me, give me that data. DynamoDB will give you that data with a 200 OK response. Here you write a SQL query to your relational database, and it returns a data from that SQL data. I mean, your database system. This is important, DynamoDB replication. So let me start talking about that. There is a concept of global tables over here. So before that, I'll give you a little more additional information. So now there is something called as DynamoDB streams as well, which I didn't talk about earlier. But let me do it now. DynamoDB streams. Why this is so big? And replication. So what is a DynamoDB stream? So this is what it is, an ordered record of updates to a DynamoDB. I'm just writing a DDB table. So when a stream is enabled on a table, so stream equals to true, it records changes to a table and stores those values for 24 hours. Now a stream can be enabled on a table via a console or an API, but it can only be read or processed via the streams endpoint and API requests. So now AWS guarantees that each change to a DynamoDB table occur in the stream once and only once, and that all changes to the table occur in the stream in the near real time. So let's look at how this works in practice. So let's say we have a DynamoDB table, and that table kind of looks like this. Insert table 1 2 3 blah, blah, blah. Let's say I have a table like this. This is my table. This table has a partition key. This table has another partition key, and this one has another partition key. Now let's start with the DynamoDB table and then add a stream. In that case, what will happen is that now changes recorded in the streams, they have a limitation. So whatever you started a table with one partition key, that change will be recorded in this particular stream, that okay, in 24 hours this is what happened here, this is what happens here. So in those kind of scenarios where you want to capture all these changes and have some application which requires all these changes, in that case you can just enable this DynamoDB streams. Or you have a requirement where you want to access data in near real time, or you have a requirement where it makes sure that your data can be read only once and only once. In those situations, DB streams make sense. Again, if you do not understand this, you do not need to understand this in detail. It is for another certification altogether. It just came to my mind, so I thought of sharing this as well. Now what else? I think that's pretty much it about streams. Now DynamoDB replication. Now global tables, they build upon your DynamoDB's global footprint, because AWS services are all over the world, and it provides you a fully managed multi-region and multi-master database, which gives you faster local reads and write performance for your massively scaled global applications. So what happens is that, yeah, sorry for that. In this example, as you can see, my application, let's say it's facebook.com, and facebook.com, again, it is in North America, it is in Europe, it is in rest of the world as well, or Asia, let's say. What I'm doing is I have the same data, I'm just keeping it in different places, so that people from, let's say, Asia, they can reach out to this Asia cluster instead of North America cluster, which would give them much more latency. And that's all the concept of this DynamoDB replication. That's all there is to know about replication, that for a global table, you can just enable this concept called global table, and it will make sure that whatever places AWS is present in, you have obviously the option of defining, I want a table in North America, I want a table in Asia, or I want in both America, Asia, as well as Europe, All these options are there. Your data will be replicated automatically, and it will give you faster local reads and write, and they will handle all this replication by themselves. Question. Okay, this is again not required for certification, but again, as it came to my mind, let me share that. So slide, new slide. This is for the actual working. Let's say you want to know how many partitions I kind of need. So there are two formulas that you can use based on the performance and the other one on capacity. So let's see the performance one first. And if you want to calculate partitions, how you can do it is, first you should know your desired RCU divided by 3000 RCU, and you should know why I have written 3000 here, plus desired WCU divided by 1000 WCU. Sorry, desired WCU divided by 1000 WCU, and again you should know again why I've written 1000 WCU over here as well. And the other one, another formula for partitions is 7500 RCU divided by 3000 RCU plus 3000. I mean, this is just an example of the same thing. Like, let's say I have a desired, I want 7500 RCUs, dividing it by 3000 RCU plus 1000 WCU divided by 1000 WCU. It will give me 2.5 plus 3, which is equivalent to 5.5. We can't have 5.5 partitions. So that gives me, in this situation, I need to have 6 partitions. Again, an additional information, how a general thumb rule to calculate how many partitions I might need. And another formula based on size is following. So if you want to know how many partitions you should have, so you should know the data size in gigabytes divided by 10 gigabytes. And that would give you, let's say you have a data of 65 gigabytes, and dividing that by 10 gigabytes would give you 6.5. That means you need to have 7, which basically is max of 6,7, and that is obviously 7. So in this case you need to have 7 partitions. Make sense? General thumb rule formulas, there is nothing as such what is going on and things like that. You can have more, you can have less as well. Clear? What else do we have? Backup and restore. All these things are pretty simple. I don't know. Okay, I'll just read it for you. So on-demand backup, when we create an on-demand backup, a time marker of the request is cataloged. The backup is created asynchronously by applying all the changes until the time of request to the last full table snapshot. There's no limit to the number of on-demand backups that can be taken. So it's basically simple. You want it whenever you want it. So let's say I want it 10 p.m. tonight. I'll do it at 10 p.m. and it will happen asynchronously. It does not stop any of your processes. It will happen in the background, and what it will do is it will have a backup of whatever data you had from start till that point when you requested the data, and that much backup will be created for you. Restore, so you do a restore without consuming any throughput on the table. You can do a full table restore from your backup. And restore, you change certain things like global secondary indexes, local secondary indexes, billing mode, provision read and write capacity, encryption settings. Apart from that, everything else is all the settings are restored as well. Point in time recovery, so they do allow continuous backups using something called as point in time recovery, and this helps to protect your DynamoDB tables from accidental reads or writes. So even if you're not looking for a backup, or you're not requesting a backup, they keep on doing certain backups after a certain period of time. And so if something happens by default, by accident, you delete a table or something, you can use this point in time recovery. And so for an example, they have given an example over here as well. So a test script writes accidentally to a production DynamoDB table. With point in time recovery, we can restore the table to any point in during the last 35 days. So any 35 days, I made a mistake now. I can go to the yesterday's state just with this option of point in time recovery. So with this, we are at the end of DynamoDB, and this is basic DynamoDB best practices that you should keep the number of indexes to a minimum. You should set different provision read capacity for different readers. You should store large attribute values in Amazon S3 and store the object identifier in DynamoDB. And what this basically means is, if let's say you have images, you can do it, but you should not store your actual images in DynamoDB, and you should store them in S3. And but in your application in e-commerce website, you are using DynamoDB as your database. So what you can do is, in DynamoDB, as it is a key value pair store, you can say amazon.png logo. You can give this as a key to your DynamoDB, and its value would be S3 dot Dynamo table resources XYZ, some neighbor name of the table, your bucket, and inside it all my images. So this is how you actually should store data which is very big in size. Large attribute values is what they mean over here. Maintain as few tables as possible in your DynamoDB application. In general, basic recommendations that they provide for best practices. Okay, we'll get started with S3 Glacier. And yeah, I want one of you to tell me about it. Start talking about it. So Amazon Glacier, as you mentioned, it is designed for long-term data storage for your cold data that is not needed to be retrieved very frequently and very quickly. It can be used as a backup service as well, used to back up your infrequently accessed data in S3. So that's all it is. Then there is concept of Glacier vaults and archives, so or you can have all of these files. Mostly it follows that everything goes to your Glacier vault, all your archives and things like that, and that's why it takes little time. So basically what happens over here is, your actual data is stored in this archives, and you store any type of data in an archive. What happens is, all your images, video, or whatever, you upload all these files separately, but they can upload a single file. They can create an archive of it using a tar or a zip file, and they upload that single file to an archive, and that's what saves money for them and you as well. And vaults are basically just containers where you can store this multiple archives, and by default 1,000 vaults are allowed for a single account. And use cases are pretty simple. Why do you want to use S3 Glacier?
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
And that's pretty much it. You should just know what exactly is S3 Glacier. That's all. Now, RDS. Tell me something about RDS. So these are the databases that it supports. It's a relational database service present in the cloud. Uh, it supports all your famous ones like Microsoft SQL Server, MariaDB, PostgreSQL, MySQL, Oracle, mostly frequently used ones. And apart from that, they have something called as Amazon Aurora, which is their own relational database. And there are much more advantages to Amazon Aurora. But yeah, let's see. Yep. So this is what they claim, that 5 times the performance of MySQL is what Amazon Aurora delivers, 3 times the performance of PostgreSQL. So that's what they claim, and they have made it. Obviously, even if it is not 5 times, it would be 4 times, 3 times, but definitely they have made it better, and it has a lot of advantages. Like, firstly, it's in the cloud. Then just there is another thing called Amazon. So by default, all your MySQL, PostgreSQL, your data is replicated across 3 regions. In Aurora, it is replicated across 6 regions. So there are advantages like that using Aurora. And on top of that, it is cheaper than those solutions. So they just want to drive your attention to their own offering, and that's why they have made it better and cheaper. So again, yeah, not much more to know about it for this certification. Basics, blah 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 blah. You can just read it. There is nothing over here. till then we can discuss what is the next agenda. We are done with the module 2 as well, where we saw the storage options. In storage options, majorly we focused on DynamoDB and we went properly in depth about DynamoDB. Then on an overview, we saw about RDS as well as S3 Glacier and how do they compare relational databases with your DynamoDB. And now the next module is going to be about data processing. And here major focus would be on Amazon EMR, which is your Elastic MapReduce service in the cloud. And apart from that, we are going to discuss Glue as well as Amazon Lambda or AWS Lambda function. So this would be the agenda. And anyway, let me give you the brief about what we are going to do in this particular demo. So in this particular demo, I will create an Amazon Aurora MySQL database. First, in that database, once it is created, we will verify that the security groups, NSCL, NACL, and the route tables, they are configured properly. And because that is required or configured to allow communication between an instance in your public subnet and RDS database in a private subnet. And yeah, somebody tell me, why do we need that? A database to be in a private subnet. So obviously you, let's say again, being a e-commerce website, you're storing confidential information like credit card, their addresses, information about whatever they're ordering and things like that. You don't want that information to be public so that anybody can come and access that information. And that's why it is to ensure that your databases are in private environment. You keep your databases in private subnet. However, your internet application, whatever you have created, let's say Amazon.com, that is public. Anybody can come and access that website, see all the pages and do whatever they want over there. But that should not give them a free pass to sneak around your databases as well. And that's why we need a database in a private subnet. And in this demo, we are going to see how we configure tables to allow that to happen. A database to be in a private subnet and allow communication from an instance which is in public subnet to a database which is in private subnet. After verifying this appropriate settings are in place, we will create the database. And once that is done, we will use something called as Bastion host. Anybody aware about Bastion host? Somebody who is in Australia, they might call it jump boxes, but they are essentially the same thing. Anybody aware about the concept of Bastion host? You can say no, obviously. Okay, apart from that, so yeah, we are going to use an EC2 instance, which will act as this bastion to allow us to connect to a private database from an external source. And that we would be the external source. And finally, we will utilize MySQL Workbench to connect to a private RDS Aurora database through the public EC2 bastion. So this is what we are going to be doing. And I think I've done everything. Let me just install something so you can. So basically, and what I'm doing is like, let's say, to show you, I need to have an EC2 instance in place. So I'm creating that EC2 instance. I need to have RDS. If I do it in front of you, it takes like 15-20 minutes. So I don't want to waste that much time. So I did all that before starting this lab when we went on a break. So all those basic things I did, and I'll show you whatever I have done over here as well. That's not a problem. So yeah, I hope I made the what we are going to do that clear already. Now, first thing that we are going to do is we'll validate the security group, route tables, and NACLs are configured correctly or not. So first thing you have to do is go and get your EC2 instance. And as I mentioned, you should ideally already know how to create an EC2 instance. If not, sometime later, let me know and I'll show you once. That's fairly simple. So as you can see, I have already created one EC2 instance by the name Bastion host. It's a T3.micro instance, which is sufficient for this demo. And all the details about this instance are present over here. All I have to do is just click on this and this should expand. You should start seeing all this details, security, networking, and all these tabs over here. In this particular section, select and then navigate to the route table section. Public subnet 1. We'll go to route table. And in this route table, what we have to do is we have to verify that there is both a local route and an internet gateway under target. So this is my route table. And as you can see, this is my local route. And this is a internet gateway that I have created. Creating internet gateway is simple. Just click on create internet gateway and give it a name. That's all you have to do. That's what I have done. So I have created an internet gateway by no name, and I have just attached this internet gateway to the subnet, which is my public subnet 1. And in this public subnet 1, I have a route table. Let me click on it. That's easy. So this is my subnet. Under it, routes table. This is the name of my route table. I was just too lazy to give it proper names. Otherwise, I usually, when I'm showing a demo on VPC or something, I call it public route table, blah, blah, blah. Right now, I just gave it some random numbers. So all you have to do is make sure you have a local route over here and there is an internet gateway attached to it. Let me know if it is clear so far, because this is important. Otherwise, this will not work. Okay, so this much is done. We went to the route table and we verified that there is both a local route and an internet gateway under target. Now we'll navigate to the network ACL or NACL tab, this one. And here we have to verify that an inbound and outbound allow all TCP traffic and all other traffic is denied, is what we have to ensure over here. So as you can see, I have already created a rule over here that my inbound and outbound, they are allowing all TCP traffic. So this all TCP traffic, sorry, the TCP traffic over here on all the port ranges, it is by default allowed by me. Same goes for my outbound as well. So anything can come and anything can go via this TCP rules. Anything apart from that, all basically is denied. And if you know about NACL, the rules are explicit instead of being implicit. So what it basically follows in order. It sees, okay, TCP I have to deny, it will deny all TCP. Then it sees, okay, all, sorry, it will enable all TCP. It sees that all other traffic, it should be denied. It will deny all other traffic. What else? Navigate. What else do we do? Yeah, now I'll show you the private subnet. So my subnets, and I'll show you private subnet 1. I'll just click on it. And here, what do you think I have to see here in route table? What should be there? What kind of route it should contain? Okay, let me simplify or make the question much more easy. Do you think an internet gateway should be here or not? Private subnet 1, do you think an internet gateway should be there or not? Strangely, both are wrong. It's a private subnet. What an internet would do over here. I do not need internet access for this private subnet, right? So internet does not make sense over here. That we needed in our public instance. That's why we had to make sure that there is a local route and there is an internet gateway in my public subnet. Here, I just need a connection between EC2 instance to this private subnet to talk to each other. But I don't want outside people to come and talk to this private subnet. That's why I just need a local route over here. And that's what you have to verify over here. And last thing that we have to do is we'll go to security group. So over here, security group, and we'll see the box called SSH. And what do you have to verify over here is that this security group should exist, permitting SSH traffic to the Bastion host. So my Bastion host should have the access. So as you can see, this is attached to the type SSH. Port number 22 is for SSH, and it allows all traffic on my EC2 instance, because that's what I want. My EC2 instance should have all public, like anybody from all over the world should be able to come and SSH into that instance, because I might be using this laptop today, another laptop tomorrow, and I am the owner of the database, or I want to see the database. So my instance should be allowed to open from anywhere in the world. That's why I need this 22 port range with a public IP address, IP range. Does that make sense? Okay. Now we'll see another security group that I've created, and that is my MySQL security group. And over here, what do we have to verify is that here we have to confirm that it permits port range 3306. Why 3306? Yes, so it's my database port for MySQL, and obviously I want my database to have some sort of access from a local route. So my private subnet, if you remember the route to the local traffic, I'll show you again if you forgot. So route table, this is the destination or IP address of my local route, and that's what should be there in your 3306 port number. So I'll come to security groups again. Where is security groups? Over here, MySQL. Open that and see that port range 3306 only has a local route. I do not want internet to come and access this. So it does not have 0.0.0.0. It has my local route. Make sense? Okay, thank you for confirming. The last thing, I have to go to my EC2 instance, and then I just have to verify what security group it is using. So under security group, where is security? Blah, 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 blah. I think it's in security itself. Yep. So I have to make sure that it is using the same security group that we just saw. So that is port number 22, allowed from anywhere. And this is what we wanted. So everything that we wanted to verify is fine. And you asked for a checklist, what all we did over here. So let me type it down. I'll give you better instruction later as well. But yeah, this is for a right now kind of thing. So what we did is, I mean, it's for summary as well, so it will serve both the purposes. So we saw that there is a public subnet by whatever name. In that public subnet, we checked if it has a route table. Then we checked or verified that it is both it should have two routes, a local route and an internet gateway. This is the first thing that we checked. After that, we checked NACL. In NACL, we saw that both inbound as well as outbound allows all TCP traffic. All the TCP traffic should be allowed, and everything else, or it is called as all in this world. So all should be denied. There were two rules basically in NACLs, and this are the two rules description. Then the last thing that we checked is, no, not the last thing, second last thing. Then we checked private subnet, and my private subnet should have just the local route is what we checked. Then we check security group. In security group, we check two things. First is your SSH for EC2 instance. EC2 instance should have an SSH instance on port number 22, allowed from anywhere in the world. So it should have an IP address of this. Then we saw the security group for my MySQL port, and port for that is 3306. And over so 3306, and here I want access only from a private route. And if you remember private route, it was this. And yeah, that's it. I think, did I miss anything? And yeah, finally we saw one thing. Correct security group is assigned to an EC2 instance or not, is what we checked last. So with this, we are done with like initial set of checks that we wanted to do. Now we are going to create a subnet group for our Aurora cluster that we are going to create, containing only private subnet. And how do we do that? And this will give you idea on how I created all the other subnets as well. So I'll go and search for RDS. Over here, you should see subnet groups. Click on that. And here, create DB subnet group. Provide name, whatever you want to call it. I'm going to call mine Aurora Lab subnet group. Group spelling is wrong. Description, I'll keep the same. VPC, I have already created a VPC. You can create whatever VPC you want. Then availability zones, you can choose whatever availability zones you want. I'll choose 1B and 1C. And both should have my private subnet. And which one is private? Let me see the name. I've forgotten. So VPC. That's why you should name it properly and should not be a lazy like me. Sorry, I have to check subnets. Why I'm checking security groups. So the private subnet one ends with 528. 528 is this one. So I'll select this one for my EB, and that's pretty much it. I think I can select both. So as you can see, I have chosen two availability zones because I want to keep cost to minimum, just to show you this example because I am paying for it. And then I've chosen two private subnets which I've already created. These are the private subnet that I have: private subnet 1, private subnet 2. If you'll open both, you will see that both have only a route table which has a route to a local only. This is one, this is another. I'll show you other as well. Private subnet 2, showing you the route table again. This also has a local route only. And to show you this example, I've chosen two availability zone, 1B, 1C, and I've chosen two private subnet for those: 10.0.2.0, 10.0.3.0. Hope it is clear so far. We have created a subnet group. Let me know if it is clear, and I want more people to acknowledge this time. So subnet is basically to define who should have access. So I wanted access only from local or a private place. So what I did is I first created my private subnets. I'll type private subnets 1, private subnet 2. Then I have this group of subnet. I just wanted to group them. There is a concept of secure subnet groups. Why do we have this? Because we can have multiple instances. So it's not like my data is present only in one place. It is here, then there is a copy of this, because in database you cannot afford to not have a copy. So I'm going to show you how to create a cluster with at least two replicas. So in this case, I will have this primary one and this secondary one, and I wanted to place them both in different places. So this one is attached, this one, private subnet 1, private subnet 2. In RDS, I don't want to do all these things again and again. So I create a subnet group. I place all of this private multiple subnets. I can have 6 as well. So I can have 6 copies. In that case, I have to create 6 private subnets. I have to group them here, all 6 of them in one subnet group, like how we did just now. Make sense? You'll understand this once I'll assign this subnet group to an RDS. So that is the next step. So we have created a subnet group. Now in the databases, over here, I'll click on create database. What's the time? Are we running out of time? No. So over here, there are two options. I'm going to create an Amazon Aurora cluster. Here, I'm going to create, there are two options. Either it supports MySQL or it supports PostgreSQL. In the example I'm showing, it's going to be MySQL compatible edition. So I'll select that one. And the next thing that it asks for is whether it's a production use case or a development use case. I want to save cost, so I'll not go for production use case. Under settings, you have to define all the things. So I'll call it Aurora Lab Cluster. I am super lazy, so I'll leave the name as admin itself. Password, I'll give it my favorite password, which is strongpass@123 is what I use for all my demos. Then it is going to ask you about what kind of instance that you want. So this is the vertical scaling. Did I type wrong? Let me be more lazy. 123 123 should be fine now. So yeah, if in case I forget, my password is admin123. So over here, I was talking about this. This is how you handle the vertical scaling. If you have more requirement, you want more IOPS, you want better storage, or what kind of storage you want, whether you want magnetic storage, SSD drives, all those things can be configured by choosing this instance type. Information on this can be found in its documentation, which one means what. But if you are not new to AWS, you basically are familiar with this terminology already. So T3 is the cheapest of all in this list. So I'm going to select that. Hey, this is very costly. Why I'm selecting this? Hey, why it's not giving me that option? Oh, yeah, this one. Sorry, I had to change it to burstable classes. That includes your T classes. So db.t3.small is the smallest that they offer. To save cost, I'm going to select that only. Now, under multi-AZ deployment, we are going to ensure that it creates an Aurora replica or a reader node in a different AZ. It is recommended for scaled availability. So this one, I'm going to make sure that it is selected, because without this, multi-AZ will not be done. There will be no replica, but we have already created 2 subnets because I wanted to show you this example of having 2 replicas at least. Now under connectivity, ensure the public access is set to no. So public access by default is no itself. You just have to make sure it is no. That is done. Apart from that, under existing VPC security groups, over here, my VPC group is selected and a DB subnet group is my Aurora Lab subnet group that I have created for it is selected over here. And finally, the security group, which one should be? Tell me. I have 2 security groups. Which one should I select over here? Do you want to go inside your database and make changes to your database? Or do you want to get data from your database? So in that case, SSH is only to go inside something and do all the operations manually. You do not need to do that with your databases. So SSH is definitely not required. We are talking about database, and by default, the name itself is written over here, MySQL group. If you remember the 3306, so Aurora MySQL, it requires that 3306 port number to be accessible from my private subnet. That's why I need to select this one. Make sense? Yeah, that's pretty much it. Everything else you should leave blank. But yeah, somebody asked a question about subnet group. So subnet group, the DB subnet group defines which subnet and IP ranges the DB cluster can use in the VPC that you selected. So my databases, I want to make sure that my databases are present in 2 subnets, which I defined over here in subnet, public subnet 1, public subnet 2, and the range for this is 10.0.1.0. This one is 10.0.3.0, and I want to ensure somehow that this ranges are accessible or they can be accessed by my database. How do I do that? Either I have to select all the subnets by default manually, or I can create this subnet group which will hold these things together. The subnets that I just showed you, it will have this 10.0.1.0, 10.0.3.0. I can create a group of that and I can select that group. Is it clear why we have this subnet group? Over here, I want to see if I have a MySQL installed. So I have already installed, but if you want to install it, the instructions are present over here. It's fairly simple. You have to log into your Oracle account. If you do not have an Oracle account, you have to create one. It will be downloaded. They will give you instruction, and that's how you can download. So which I have already done it to save time. So as you can see, I have a MySQL already installed. Now MySQL, I'll increase the font size. Is this done? It is almost done. I'll click on it. This one is being created, so I do not have an endpoint. I have to wait for it to be created. And yeah, somebody asked me question about encryption. So I forgot to not check encryption. You actually pay more for encryption, but I forgot that. So it has created an encryption key already for me using KMS. Encryption is enabled. Ideally, you should do it with your databases, but for the demo, it is obviously not required. I should not have done it, but fine. So it is available. So copy this endpoint name, which is next to writer instance. We want that. And we'll be using that endpoint to authenticate to connect to our Aurora cluster. So the command for that is mysql -h, then your writer endpoint, u, which is admin password, hit enter. It is going to ask you for your database password. My password was admin123. Obviously you have to change the endpoint. So if I've done everything correctly, it should ideally connect, but I don't know why it is taking time. I think because this is not done yet. So yeah, with this, as you can see, I can connect to my MySQL connection, and the ID is this. Now you can ask a question, sorry. So as you can see, show databases shows all of my default databases, whichever are present. We'll see global variables like Aurora server ID to see what is our server ID. What did I do wrong? Oh, so this is my Aurora server ID, the name of my Aurora instance. And what else? We'll go back to RDS and we'll see if the reader instance is available, and if it is enabled, what we'll do is basically we'll copy that and come here. It is still creating. Oh, that's why I was not able to connect to that instance. Configured enhanced monitoring. So once it starts showing this configured enhanced monitoring is when you can basically configuration is almost complete and you can connect to it. So far, if I'll try it for my reader instance, I will not be able to connect. So I have to wait a little more. But we are actually almost done. Next thing I'm just going to show is instead of this, I'm just going to copy this instance and connect with that.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
But I think we are over time. So I hope I can skip this much. All I'm going to do is copy this endpoint, which I have over here. Where is it? And just connect to it. Does that make sense? It help you how what all is required to connect to a database, all about security related things like what should be private, what should be public, and how do you create an instance. So before talking about EMR, first thing I want to introduce is MapReduce. So MapReduce, it's a technique that data scientists or big data engineers, they use in order to distribute workloads across many different computing nodes. So as you can see in this diagram, you are seeing a lot of different computers. So they are nothing but different nodes. And using this different nodes, what we are trying to do, we are trying to process different kinds of data and process this data in order to get some information back a little quicker than what we are expecting on a single node. So that's the whole simplified, very high level definition of what MapReduce does. So let's take an example. So for an example, you have three different kinds of data, which is, let's say you have circle and then square, some triangle, and some other figures. And this is n number of times. And what your need here is that you want to calculate or compute. Again, I am not able to draw, but assume that this is in like hundreds or even millions of quantity. So you have like millions of squares, similarly circle and triangle in different variation. And what you want to do, you want to compute quickly how many squares I have or how many circles I have. And you want to do it using big data. So what you're using is MapReduce. And what MapReduce is, it's a combination of two things, a mapper task and a reducer task. So what it does, it will take this file containing millions of images or the shapes, and it will distribute into smaller chunks. Again, don't go by my drawing, but just try to imagine. So what it will do, it will distribute it across this n number of nodes that we have here, and every piece of node will have certain information from here in terms of bytes. So it will have this portion or this many pixels of this image. Another one will have another set of images. So in this mapper task, what it does, it your files or different whatever data you're dealing with, it is broken up or it's split across secondary nodes, and that data, it is also replicated. Again, very simple things, but it makes a lot of sense when we are dealing with a lot of data. All of this are crucial to what Hadoop is, what MapReduce is. So first thing that happens is split of your data, and this task splitting is, there is a term for it which is called DFS. Any idea what DFS is? Absolutely. So if you're interested, there is a research paper on which entire Google is based, and it's based on just these two things, which is your DFS or SDFS and your MapReduce. So it's just like 8 pages of document, but that entire 8 pages makes up what we know of Google. So looks simple, but it's a very niche concepts about it. So is this clear so far? So what we are doing when we are talking about Hadoop. So I've just gone just one layer deep. So we are doing splitting, and that splitting is a simpler term for our understanding for HDFS or distributed file system. In distributed file system, just two things happen. Your files, let's say there is a file 100 megabytes, it gets broken up into smaller chunks, and those chunks are split across this secondary nodes. This is first task of DFS. And second task is that it also replicates those chunks. So basically making it redundant. So even if you lose something on one node, you have a copy or a backup available in another node. Is this clear so far? What is DFS? That's all I'm asking. Thank you. So far we have covered what is DFS. So what is HDFS? Yeah, so the concept we are talking about is distributed file system, but it is more prevalent, or it's more like popular by the name HDFS, because Hadoop is a Apache open source software which helps you to run this distributed file system on different computers or different nodes to solve this problem of having massive amounts of data. So the technology we are dealing with is called DFS or distributed file system, and the software that does this is called HDFS or Hadoop distributed file system. So it is kind of difficult to set up on your own. So what they have done, they have packaged it, they have kind of made it little managed, not as managed as EMR, but HDFS kind of takes away a lot of pain points of doing it all by yourself, splitting of this data, making this replication, and whatever logic are required, operation system level related logic, they have taken care of it. So that's what HDFS is. They have taken a lot of headache from us, a lot of maintenance, a lot of management related tasks into a simpler Hadoop cluster. So they have created a cluster for us to use distributed file system. And then, so we have talked about first thing, which is DFS or SDFS. Second thing that we want to talk about is Elastic MapReduce. I'm not talking about Amazon Elastic MapReduce, but so what they have done, we talked about DFS, then we talked about MapReduce. So combining these two things together, this is what is called as your EMR or Amazon Elastic MapReduce service. So this one, it just splits things. And then this MapReduce, what it does, it takes those split chunks and then it processes those chunks and finally give you output by combining all those different chunks. So that's what this MapReduce does. And the combination of this two is called your Elastic MapReduce or Amazon Elastic MapReduce. So yeah, that's all. Let me see, what do I have in slides? So what I was saying is, in terms of the slides content, same thing that they have shown, that you have your own laptop or whatever device you're using. And at the back end, what Amazon EMR does, it provides you this access to a lot of nodes. And here we are referring to nodes by EC2 instances. Are we aware about EC2 instances already? I'm assuming yes. Okay, so using those EC2 instances, we get our mapper reducer task. And for HDFS, we have, can you guess, as you're already aware, we have access to EC2 instances. So for HDFS, what are we using? So for storage purpose, what are we using? So the primary thing of storage we use for HDFS when we are dealing with EMR is your, sorry, what do we call it? Uh, I'm not getting the name. What comes automatically with EC2 instances for storage? So there are two options that anyway I'm going to talk about when we'll come to that. So first thing that you mentioned, S3, that is absolutely correct, that they provide EMR provides you option to use S3 for HDFS file system. But by default, what it gives you is your EBS volume. So it takes advantage of your EC2 EBS volume in order to handle the storage requirement. Anyway, so yeah, that's the high level definition of EMR. What EMR provides you, it provides you a managed cluster. And what that managed cluster allows you to do, it allows you to run your big data frameworks. And so far we have covered what is Apache Hadoop at a very high level. That it Hadoop, what it contains, it allows you to run very vast amounts of data or very big jobs in a very short amount of time. So it allows you access to a lot of nodes. So that is your mapper reducer portion of it. And it allows you to split your files and make redundant copies of it. So that is Apache Hadoop. And we have covered only till here. We'll be seeing what is Apache Spark. So these are different open source frameworks which are available for specific tasks. So for an example, Hive. Hive allows you to run your SQL queries. So it allows you basically to run your SQL like queries on this big data. So that's what Hive is. Then we have Apache Pig. It allows you to orchestrate jobs. It allows you to have some sort of workflow that you design a certain workflow, and every second week it will run. Again, we are going to talk about them in detail, but so far I'm just giving you a kind of brief. So this is what EMR provides you. It is an open cluster for you. You have access to this cluster, and using that cluster you get access to different softwares or different frameworks that are available. So for an example, Hadoop, Spark, Hive, Pig, and there are various others as well. So that's what EMR will provide you. And again, anytime in for the examination perspective, it is mostly going to be used whenever they are, again, this whole examination is about big data. So let's quickly go by the benefits. So why EMR? Again, I'll allow you to guess first, and then we'll go through all those as well. So what do you think, using Amazon EMR over setting up your own clusters? So for an example, Hadoop cluster, Spark cluster, what benefit Amazon gives you? Absolutely, a very valid point. And if somebody has tried setting up their own cluster by scratch, so I did just three things so far. After that, I started using EMR. So I just created my own Hadoop cluster. I installed Hive inside it, and I did some basic big related workflows. And it literally took me around 4 to 5 days in order to just set up, have all the dependencies and all the libraries which are required for this to happen. Only this much took me like 4 or 5 days. So again, they provide you plethora of services or frameworks, around 9 10 if I'm not wrong, and they might have added more as well. So imagine if you have if you need access to all of those things and you're trying to set up everything from scratch, it is going to cost you an immense amount of time or effort, I would say. So that's a very valid point. Anything else? Okay, let's quickly read. So first thing, it gives you this pay as you go kind of pricing. So it's very cost efficient. And later on, we'll see it allows you to use your spot pricing for EC2 instances. That makes, or that gives you so many cheap options. Then it has very nice AWS integration. Can somebody wanna elaborate this point? What do you think this point means? Again, a very important point. Awesome. Anirudh, thank you for that. That's a very nice point. And as you used Athena and Glue and things like that, I'm assuming, are you something related to database engineer or ETL person? Yeah. So again, so that's what it means. AWS integration, whatever you do, it allows you to take the same advantage of whatever service you are used to using and just convert it to big data scale. So it allows you to very quickly move to this kind of scale in whatever which your relational databases cannot achieve, and you want to use this big data at scale. So it allows you a lot of AWS integration options. So I'll give my example. So by profession, I am a machine learning engineer. So before EMR, there used to be a lot of times when we face problems. Again, it easy to have a lot of variety of label in whatever scale you want. But even with that, we sometimes found that we are not able to process that much information very nicely. And then we got to know an EMR was very recently released that time. So we started exploring EMR, and there is a very nice integration between your Jupyter notebooks and EMR itself. Otherwise, if you're trying to set it up for yourself, you have to do a lot of things. We just went ahead, started using Amazon SageMaker, and it has very nice integration with EMR. Literally, you just type 1 or 2 lines and you have access to big data clusters. So second point basically means that whatever tool, whatever Amazon tool that you are used to using, you can quickly start using with EMR as well. And second is easy deployment. We have emphasized enough on it that it allows you to set up in like literally few minutes your own cluster with whatever frameworks you want. That gives you scalability and flexibility in terms of how much scale you want to go for. And then fifth point that we have is reliable. Obviously, everything that AWS provides, they start up from security, reliability, and those aspects. So I'm not going to explain this any further. Then secure, obviously, as I mentioned, they all of their processes that they launch or services they launch, two pillars that they start with is your security and reliability. So everything starts from there. Easy to monitor, that's a very nice point. So again, if somebody has tried setting it up for themselves, EMR, Hadoop, all of these things are not very GUI oriented. You don't get very nice visualizations. Now they are implementing it, but when I started using it, that time it was like a lot of kind of like MS DOS kind of environment or terminal oriented environment. They didn't have their own GUI. So with EMR, you get a very nice option of monitoring all these activities as well. Whatever you're doing, how many clusters you have, how many clusters are not working, what clusters failed from let's say 8 p.m. to 9 p.m. All those tasks, they provide you a very nice visualization environment, and that's where you can basically it allows you to easily manage those services that they are providing. So these are few benefits which looks very small, but if your daily bread and butter is something related, let's say few people their job revolves around just running Spark jobs, so for them these are immense benefits. So again, as we have discussed, I'm not going point by point, but if you want, I can just stay on the slides for a few seconds and you can read it on your own. Let me know how you want it. I can read it if you want. Sufficient. It allows you to integrate with AWS services very easily. Let's see if we missed something. Yeah, we didn't talk about networking, but again, I mentioned you can integrate with all the AWS services you're using. So let's say you want to keep it under your own virtual private cloud, you can use the VPCs that you're used to using. Easy deployments, we talked about it, scalable and flexible. And this is what I was talking about earlier, that S3 and the other file system. So it is very scalable and flexible. So it allows you to choose between two options. One is EMRFS, which takes advantage of S3, and then SDFS. SDFS is your usual using EBS volumes. Again, I'm going to talk about it later. It's reliable, it's secure, easy to monitor, and it allows you easy management. So let's quickly see what is EMR architecture. And before that, I want a very nice definition from somebody from whatever we have covered so far. So what is EMR doing it for you? What aspect of your life it is making it easy? A little technical, but simplistic enough definition from anybody. For an example, Kubernetes. For Kubernetes, they have their own managed version of Kubernetes as well. So whatever you are used to using in terms of coding, it will remain the same. And in fact, I would say it will become a little easier here. So they have their own version of Kubernetes here as well. Databricks, they don't have, so that you cannot directly use it, but you can install it on their whatever cluster. Let's say you have set up a cluster of 8 nodes or 16 nodes. In that, you can set up your Databricks, and then everything goes around like how you're used to using. So yeah, that's what EMR is targeted at. So it targets at providing you processing patterns at speed and scale that your relational databases usually cannot achieve. So that's what EMR at a high level provides you. And it is primarily designed to deliver batch oriented processing. So anything that you want to process in bulk or batch, that's what EMR is primarily focused on. It allows you to process data. It can also store data as well, which your usual Hadoop cannot do, and we'll talk about it later. So whenever we are choosing a big data storage solution from all the AWS offerings we have, it is important to determine whether that data sources we are primarily storing, it contains structured data, semi-structured, unstructured, and that will typically drive the decision on which AWS service is going to be the best for data pattern or your use case. So if I have to give a little definition to EMR, I would say it is primarily designed to manage your semi-structured data, and it is designed for schema on read. So schema on read is where you apply the structure to the data when you're using it or when you're reading it. So whenever you have this kind of requirement, whenever you are looking for like effectively creating and applying some sort of structure within your code rather than defining the structure in the database before you load it, this is when your EMR is going to be crucial. So it provides you a framework which allows you to easily create, customize, manage big data processing clusters based on your Apache Hadoop ecosystem. And it stands for Elastic MapReduce. Underlying your EMR environment, there are a lot of clusters which Amazon provides in terms of your EC2 instances that house your Hadoop ecosystem. So AWS, they have installed that Hadoop ecosystem on those different EC2 instances, which is your open source applications, whatever Hive, Big, whatever. They have installed those applications, kept it for you. They are providing you access to those clusters or EC2 instances, and that's what they have named it as a managed service, EMR. So now we'll be looking into its architecture. So let's have a look at the architecture that is underpinning this Amazon EMR service. So the architecture, it kind of remains identical to your normal Hadoop cluster as well. So it's based on a clustered architecture, which is often referred as distributed architecture. The core container of your Amazon EMR platform, it is referred as cluster. So let me write down few things. If you want to take notes, you can take it. So currently we are discussing what is a cluster. So cluster, it is composed of one or more elastic compute nodes or cloud instances, and they are referred as your slave nodes. I don't like to use this term, so I would like to call it secondary nodes. But yeah, you might find both of these terms, a master node, slave node, or primary node, secondary node. I like to call it primary and secondary, but both remains the same. So what they does, they execute your code, what processes your data, and every cluster has a primary node. So can you think what primary node will do and what secondary nodes will do? Yeah, absolutely correct. So as it's a tiered architecture or different layered architecture, so we don't have just two kinds of nodes. We actually have three kinds of nodes. So first one is your primary nodes. Again, I'm not writing because this pen thing is terrible here. So first one is your primary nodes. Second one is your secondary nodes. And your secondary nodes consist of two different kinds of nodes. Any idea what those are? We'll come to that. Let's quickly read what is there in the screen, and we'll talk about this in the next slides. So as we talked about, it's a clustered architecture. We also call it distributed architecture. It consists of clusters, and we started talking about what clusters are. Before going to talk about clusters, let's see what are the different kinds of local file system or distributed file system it provides us. So we have two kinds, again, crucial for your certification. First one is the usual one, which is your Hadoop distributed file system. And second one is your EMRFS. These are the two kinds of storage that EMR uses. So this EMRFS, what it does, it extends your Hadoop to add one ability that it does not have, which is to directly access data which is present in your Amazon S3. So let's say you have already a lot of dump. If you're aware, S3 is used as data lake. So let's say you have been using S3 as data lake for a long time, and now your company or organization has this requirement that let's do some sort of analytics on this data that we are anyway storing for a long time. So what they did, they started using EMR. You already had data in S3, and this is why they brought this as well, because they got a lot of requests from a lot of organizations that they like to call them as their partner organizations, that we have data present in S3 and we want to start using that big data using EMR. So that's when they brought this EMRFS. So they have provided two functionalities. One is your usual one, HDFS, and second is to use EMRFS, which has data already present in S3. And there is one more differentiation between these two. HDFS is not persistent. EMRFS, or your which is using S3, you can have a persistent data, because if you're aware, Hadoop usually is not persistent. For whatever time duration you're running your jobs, you will have access to the data, and once you're done, you will lose access to that data. Agree or not? Absolutely correct. So yeah, I didn't went that elaborately, but yeah, that's correct. So we have the data which is persistent in nature in HDFS as well, but that remains there till the time your jobs are running. And your jobs, when you're dealing with big data, it could be running for months, even years. So for that duration, you will have access to that data. So it will be persistent. It's not like that. It's just like 24 hours or something like that, and you will lose. So whatever time duration your jobs are running, SDFS has the data. But let's say you want to store that data forever. In that case, you cannot use SDFS. For that, you have to go for EMRFS, which will be using your Amazon S3 to save this data for a very longer duration of time. So let's come to another layer. So that is your YARN. So YARN stands for yet another resource negotiator. What do you think it does? Everything is in the name actually. If you remember, I talked about the primary node or your master node. So in your master node, basically it uses this concept of YARN. And YARN is again a big data concept or a Hadoop related concept. So what it does, it provides you this resource management layer. And what in simpler terms it provides you, it somebody has already mentioned that it takes care of all the metadata related information, that this particular cluster has this many nodes, this node contains this piece of information, this piece contain, let's say, CSV files of this particular MB in size or whatever, all the metadata related information and which particular cluster will do what job and things like that. All of those things are determined by YARN, and YARN is what is installed actually in your primary nodes. uh, Let me quickly read if there is something important here. So we have talked about EMR in terms of that it provides you this clustered architecture. It provides you this distributed or clustered architecture. And for your storage purposes, it provides you two things, STFS or EMRFS. And then we talked about its layers. So we started talking about YARN. So that's what your core node or your master node or your primary node contains in terms of doing its job. So it takes advantage of something called YARN, which stands for yet another resource negotiator. So going further, I need my pen. I am going to talk about your master node or primary node. So what it does, it manages the cluster by running your centralized software components, which coordinates the distribution of data, how your data is going to be segregated in different nodes, what are the tasks that they are going to be doing, your slave nodes or secondary nodes, what is the task that they are going to be processing, and it also tracks the status of this task and the health of the cluster. So this is what your core node or your primary node does. It sees what data your nodes contains. It sees what is the health of those nodes. It sees what is the status of this task, whether it is finished, it failed, things like that. So these are the things that it does. And what do you think? A cluster can have how many primary nodes? EMR cluster, it cannot have more than one primary node. It can just have one. Then let's talk about, so yeah, thank you. Second thing that we are going to talk about is your secondary nodes. And secondary node consists of two different kinds of nodes. And again, very crucial in terms of if you want to save money, knowing this minute difference between these two different kinds of node is very crucial. And I've literally saved hundreds of dollars by just utilizing one of these two nodes. So we have your core nodes and then task nodes. And sorry for, I probably referred your primary node as core nodes earlier, but yeah, I was wrong then. Whether it's called primary node or your master node, don't call it core node because we are going to be talking about that now. So secondary nodes or your slave nodes, they comes in two variants. You have core node or a task node. Is this clear or did I confuse you already? Okay. So yeah, so far just remember we have talked about primary node or master node. Now we are talking about your secondary or slave nodes, and your slave nodes comes in two flavors. First one is your core node, second one is your task node. So your core node is a secondary node which stores the data. Again, please make your own notes. Don't go by this weird diagrams that I'm doing here. So core node, they store your data in this SDFS fashion or your Hadoop distributed file system related fashion, and it also run tasks. So just remember that your core nodes, it can do both store as well as run task. Whereas your task node, which are the second kind of secondary node, so they only run tasks.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Cannot store data. So what do you think? And this question came in my examination when I appeared for the certification. Uh, which node is more appropriate for using spot instances? So spot node, there are chances that you might lose data. So it doesn't make sense to use node which are storing data as well. In that case, just use the task node which are just running job. And if even if that job fails, you can just have another cluster or another node doing the same job for this particular, but it is not storing data. So I hope this difference is clear. This is what I wanted to highlight. So we have started talking about cluster. Inside cluster, we talked about your master node, slave nodes, two different kinds of slave nodes. So when scaling down your EMR environment, you cannot remove your core nodes, but you can remove your task node. So do remember this. This is because obviously your core node, it holds crucial information or data. So if you were to remove them, you will lose that data. Whereas your task node, they do not hold data. So they are the ones that are used when you want to scale down or scale up as well. So again, something on this line definitely comes in your certification. They test your ability to understand if you understand how EMR can be scaled up or down using a particular kind of node, and that node is your task node. And do you think, are you able to provision a single node cluster? And if you are able to do that, what will happen? What will be the master? What will be the slave? What will be what node? So yeah, in terms of EMR, this is what I like to uh, kind of have an analogy for it. So for cooking a recipe, you can often use like sugar, honey, different kind of molasses in your recipe. They will all sweeten the dish that you want to make. But what final flavor you want for your dish, it depends entirely on you. It gives you a lot of plug and play related options. So you have different components at each layer. They have their own pros and cons, but they will basically change how your EMR solution will work or behave. So the three layers that you need to worry about your EMR clusters are what you use for your storage, processing, and access. And there are a lot of options that we'll see in the screen, whatever different software configuration it provides. Let me start talking about a very important option that it gives in the start itself. So it gives you two kinds of launch modes. First one is called your persistent cluster, and second one is called your transient cluster. Firstly, I want you guys to tell me the difference. Again, it's in the name. And give me an example when you want persistent cluster versus transient cluster. So as you can see, these are the two options that it provides you. Here it calls them as cluster and step execution. Whenever I did my certification, the name was different. So the name was your transient versus persistent cluster. Anyway, the logic remains same. So these are the two launch mode it provides you, cluster and then step execution. What do you think is the difference here? Absolutely. So whenever you have some sort of requirement, as you mentioned, that you want your cluster to be up and running all the time until you decide to terminate it yourself. In that case, you want to go for your cluster launch mode. Otherwise, step execution. Here, what happens? You can define the steps that uh, these are the steps that are going to drive your application, and they will be automatically installed whenever you are creating the cluster. Those steps will be executed, and after that, once those steps are done, you got failure or failed, sorry, success or failure as a notification at last. It will automatically terminate the instance. So again, this seems simpler, but sometimes it saves a lot of money. If your job is kind of a one-off thing, let's say, again, taking my example, you're running some sort of machine learning workload and it's just a one-time thing. You don't want this machine learning job running forever or for a year, for months, things like that. In that case, going for step execution will save you a lot of money, because even though we are using EMR and it's an AWS service, it's very cost effective in terms of, or in comparison to other services. EMR is kind of costly. Even when with one of my classes, I did the EMR demonstration. I created this cluster and I forgot to turn it off for around 20-25 days, and it gave me a huge bill, at least for what I consider as a huge bill. But yeah, it's kind of a costly service. So the step execution saves you a lot of money, and this is what difference it makes. It allows you to add this different steps, and those steps could be anything. And as somebody asked what it can provide you, you can have some sort of streaming program. So for an example, some sort of Spark job, you can have a high program, big program, Spark application itself, or you can have a custom jar. And custom jar, why jar? Again, just a general trivia about Hadoop. Why jar? Correct. So your map reduce, the whole logic of map reduce, it is written in your Java. That's why if you have some sort of custom requirement, you are bound to use Java as well, or jar file. So these are the things that you can do when you're going for step execution. And have you guys already seen how to launch a cluster, which is showing in your this thing? Yeah, as I mentioned, I have not used it, so I'll try this as well. But seems something like that itself. So your data resides in your centralized glue catalog, data catalog, and you're just running whatever jobs you want to run on the data that is present there. Cool. So it asks us for a cluster name, my cluster in this case. Then for logging purposes, it requires some sort of S3 bucket. So it creates a default S3 bucket by itself in order to store all the logs that we have if you want logging. Otherwise, that bucket will not be present. Then we talked about launch mode. So a costlier version of it is going to be a cluster up and running all the time. Another version would be step execution, where you will add all the steps, whatever steps you want to take. You can have customized steps in terms of a custom jar file as well. It will execute all those steps, and after that, it will give it a success or failure message, and it will delete or terminate all the clusters that it has created. But for simplification, I am going with cluster option. Then it allows you to choose the software configuration, and this is a key piece of information that it wants from you. So again, depends entirely on your requirement. So let's say my requirement is to run some sort of batch processing job itself, so I can go for core Hadoop itself. I don't need all this other fancy stuff. Hadoop 2.10 is going to be sufficient. Anyway, it comes with Hive, U, Mahout, Pig, and Taze. Again, all of those things are not required for you to know, but this is the basic flavor it comes with. So your earlier versions of EMR, it uses MapReduce, while the later version, it uses Yarn. Again, general information from my end. You don't need to remember this piece of information. So earlier EMR used to have just MapReduce. Now it uses Yarn instead of MapReduce, and Yarn is nothing but a little better version of MapReduce itself. And the next thing that it asks us to choose is the processing engine that we want. And currently it comes up with this four choices: Hadoop, MapReduce with Taze. Taze, as the name suggests, it's MapReduce itself, but more quicker, kind of a Spark related or much more faster version of MapReduce. So Taze is basically efficient MapReduce, I would like to say. Big, as I mentioned, it's a workflow related thing. Mahout, it provides you option of using machine learning algorithms directly inside your cluster. So that's what Mahout is. Hive, we have seen it provides you this SQL related interface for you to work with the data that you have in S3 or SDFS. Hadoop, we have seen it provides you just mechanism to break down this data, store in multiple places, and then run jobs on that particular data. U is kind of your UI. Again, we'll see all of these things in detail, but for now, just remember what is Hadoop and probably Spark. Then in terms of hardware configuration, this is where you define your requirement. Just like your EC2 instances, it asks you what kind of instances you want to work with. Obviously, it's my personal account, so I'll go for T2, 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 T2. Where is it? Anyway, we are not creating right now, so I'll just choose anything. Number of instance, it can be one. As I mentioned, it can be a single. In this case, you will have a master node and 0 core nodes. But a good design is having at least three instances where you will have one master node and two core nodes. Then cluster scaling, you can choose this option and you can have minimum and maximum defined, just like auto scaling. Then auto termination, you can again customize the setting. In terms of security and access, it kind of remains same, just like your EC2 instances. It asks you to have EC2 key pair if you want to go inside your EC2 instances. But usually I don't need to go inside my EMR instances. They do their job. I have the code. I provide that code. And so usually I don't need to go inside my EC2 instances. But for some reason, you want to customize it more. So you can have EC2 key pairs for those instances as well. EMR role, just like every other service, you require IAM role for it. It has a by default role, and this role gives it access to CloudWatch, EC2, VPC, and basic things. But you can have your own customized role as well, depending on what other integration you want with this service. And that's it. Till then, we can see one more thing. Let's create one more cluster. So instead of doing it this default way, we are going to go to this advanced option. Here, as you can see, they have released a lot of releases for it. So obviously we are going to go with the latest possible one. But if something, your application is running on something prior version or prior release, you have the option of choosing that as well. So here in advanced options, you can choose your software configuration, what exactly you want to work with. So let's say the default one that it comes with Hadoop, Hive, U, and Pig. But let's say I just need Hive. So I have that option of this as well, that I can uncheck all this and I will have only Hive installation done. But let's keep it selected. And as you can see, there are a lot of different options as well. So let's say your job is to just run a Jupyter Hub, you can do that as well. Or you just want to run some Oozy workflows, or you have some custom scripts written in your TensorFlow or MXNet. I don't think they have. Yeah, they don't have. Strange. They have TensorFlow support, MXNet support, but they don't have PySpark. Not PySpark, sorry. So I was looking for this thing, PyTorch. I was not getting the name. So PyTorch, if you're not aware, it's just like TensorFlow and MXNet, different neural networks. PyTorch is one of the prevalent ones as well. One among them. All three are very widely used. Then you have option of entering the configuration as well. So for an example, this is where you provide things like what your data node size is going to be and things like that. So if you have a configuration, otherwise obviously it is going to come up with a already tested kind of configuration that they have worked with. But if you have some custom requirement, you can define here in this section. So for an example, it is written in this kind of fashion: classification equals to Hadoop EMR. Then you define its properties. Again, I'm not writing the actual code, it's a pseudo code for it. So this is what I remember. I did it long back. Something like this, but yeah, you can just Google it or you can just see their documentation, and they have written how you can write this custom configuration here. Again, completely optional. You have the option of providing a JSON as well, which is present in your S3. So whatever software you are downloading, so let's say Hadoop. So Hadoop, it is going to be downloaded with your custom settings, the default settings. But if you have some sort of custom requirements with Hadoop itself, you can define those configuration here. Anything. I just remember Hadoop because that's what I have done. So, but yeah, this is how you classify it. Like I am writing it for Hadoop. So classification, Hadoop, and whatever properties you have. Similarly, you can have classification, Hive, and Hive related properties, but I'm not aware. So I didn't write that. Then in this advanced option, you have the option of steps as well. By default, it is going to create a persistent cluster, but if you have some sort of steps related requirement, you can have that here as well, that your cluster will auto terminate after all of the steps. So you can add different steps. So these are the two options that you have in order to create a cluster. First one was the default one, and the second one is your advanced one. So advanced one, you just go to advanced and you provide all of these options. Then you go back, let me see. Yeah, you go back and it gives you the normal options of choosing hardware. What do you want? So for your master node, you want a 4-core M5.x large core nodes. You can customize these settings, and this is where you get this option of core node and task node. And as you can see, on demand, spot, more options related to that. Have this auto termination option if you're enabling it. So let's say you have this kind of configuration. So your job run that is running, that means that time you're utilizing some sort of compute power, and it will see whether it is idle for some time. So you can define, let's say, whether it is idle for 1 hour, 2 hours, whatever, and after that you can decide to terminate it. This is how it works in terms of this. Otherwise, I showed you this option of the steps. That is much efficient option, I feel, instead of just going for this auto termination. So I usually work with steps because in steps it gives you this flexibility of having multiple things. So let's say, again, same example that you mentioned, at 1 a.m. It is running some sort of batch processing job. So in steps you have this option of defining whether it's successful, then only terminate, or just terminate it even if it is failed or something like that. And let me think if I have something else. So after this, anyway, cluster will be created. Next thing that you guys mentioned, we'll try to use our U in order to set up its GUI interface or the web interface. So I don't think it will work directly. Security. Let me remember, what do we do for it? I think some sort of master public DNS. Connect to the master node using fetch. Yep, this is what I want. Can you see my terminal? Terminal itself directly. I
Just okay.
I just
So
opened my terminal. Where is my file? Where was it downloaded? No, that I don't think. Oh, sorry. SSH. It should connect now. Nope, it should not take this long. Open a terminal on your Mac OS, application to blah 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 blah. Security group. I think this is the culprit here. Security group for master.
Yeah. Edit inbound rules, all traffic.
There is SSH.
SSH
There
is
is no
not.
SSH. All. That's why.
Yeah. SHS, all traffic. Anyway, okay.
Guys, I'm assuming you already know all this because it's your second certification or something. But if you have any questions, you can ask me. Now I should be able to. Yep. Bad permissions. It is required that your private key are not accessible. Blah 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 blah. Okay, just a warning. Unprotected private key file. chmod 400. Finally, after so much trouble. So as you can see, we are in our Hadoop cluster. It is showing the IP address of my cluster, Hadoop at the red blah blah IP.
So you give permissions to your PEM file, right? That's
Key.
what.
Yeah.
Okay.
So it didn't have correct permissions. So I changed the permission by this chmod, chamod, whatever people like to call it. I call it chmod. And that's how we were able to access it after. Okay, let's see if we are able to open this in the. So using terminal, whoever was asking, are we able to connect or not? So now we are connected using our terminal to our Hadoop cluster. Now, obviously it does not contain anything, but I can have my files here. You can't, because that's what SSH is. Anybody who has your PEM file or PPK file and they have your this thing URL, they can connect. So it can't differentiate whether it's me or not. That's why it asks you and do not share your PEM file and things like that. I created this demo file here. Why I'm not able to get you? That's I have to figure out. Again, I think same issue. What was the port for you? 4 times 8. 4 times 8. Let's see now. So this is you. Yep. Now we are able to. Any questions on why we were not able to connect and why we are able to now? So as you can see, we are inside you as well. I've logged in with my host name, then colon 4 times 8, and then U editor. So this is how your U editor looks like. Whatever file I have in my Hadoop, I can just directly run SQL queries on it. And I have other options as well. As you can see, MySQL, Hive, and other options, whatever I'm interested in. I can submit my Spark jobs from here. I can submit Scala jobs as well and other things. And this is interesting. If you are into workflow related things, I usually deal with this kind of things. So I like working on it. So you can have all these workflows as well. Currently, I have some sort of issues in terms of access related issue, but again, that's not the point. This is how you works. Any question, what it shows, what is you. Again, the whole point was to just create a cluster and show you how you can access it using CLI and using web interface as well. Primary node that you created, it contains this information. Again, it's not, it's like hidden from everybody. So even if somebody, let's say I'm already inside this, I cannot just, it's not present here directly. By doing ls, you'll get to find it. You have to do some sort of administrative codes in order to get that username and password. So usually one person, whoever is handling this cluster, they create this super user, and whatever admins they want to work with, they provide that username and password to other people, and that's how you works. You cannot create different account for different sorry, it's specific to your cluster itself. So one cluster usually have one id and password, and you distribute that password as per your requirements. That you can do, but by default it gives you the ability of creating just one. That again, the thing that you're mentioning, if you're working in a project and you want 5 account, so that you have to write. If you remember, I was showing you that configuration section,
Okay.
the configuration that we wrote. So in that configuration, these are the configuration things that you usually change. So let's say I wrote something about Hadoop. You want to create different accounts for you, so you will write this configuration by yourself that, okay, I want number of login users or for you 5 and things like that. You have that option, but by default it's usually a recommended practice that only one person handle this administrative task. But what you're saying is completely valid, but for that you have to provide that custom configuration. And again, it's a very easy thing to do. Even if you don't know how to write that, they have provided in their documentation itself. It's just copy paste kind of thing. Let's open this as well. I'll show you this. Not required though, but okay. Let's see the name node information as well. So this I usually work with. So this is basically showing you the entire, what do you say, bio data of how your node is working. So basically this is the UI for your Hadoop, and this is not AWS created UI, it's Apache Hadoop created UI. So even if you have installed it in your own uh, local computer, the same UI you will see there as well.
Sorry.
So yeah, this is how you get the entire information about your Hadoop cluster. So it's showing when it was started, version, and basic cluster ID, summary, whatever other things are present here, how much storage I have, and things like that. Interesting things I'll show you. So this was the overview. Then it is giving you more. So this is basically, it provides you for, in order to set this up as well, kind of you would have wasted around 20 to 30 minutes depending on your skill set just to get this much information in UI. You can definitely see the same information in your CLI here itself. Again, I don't remember the exact commands for that, but you can see all of this information here too. But to see it in a UI, you have to set up this name node configuration, which AWS provides you with just one click. As you can see, they have provided this URL directly. You just click on it, you have this information available for you. These are the 2 nodes that I have in operation. This is showing information about my slave nodes. Currently everything is in service, but here if you have, let's say, 100 slave nodes, it will show you how many are down, how many you have decommissioned, how many are dead, how many are in maintenance and are dead. There are no failures so far, that's why it's not showing anything, but you have option of seeing all those failures as well. Then snapshot, we'll come to it later actually. And this I like. So under utilities, you have this option. So, and we'll do a demo on this actually. So I'll have some files, let's say in S3. I'll put those files from S3 to this EMR cluster, and then we'll play around with those files by doing all those step execution and things like that, but probably later because I didn't prepare anything for it. I have to have those files and few things set up in my AWS account to show that, but we are
Okay,
going to
Harsh.
work on it. Okay, so yeah, this is not EMRFS. EMRFS, I didn't just check that option. Again, there's nothing to set up. I just have to click on that and it gives you that, but I have not done that because a lot of security reasons. You don't want access to your entire S3 bucket. You want it to a particular folder and things like that. I didn't want to make it a little complex, so I didn't do that. But yeah, what I was mentioning is, even though let's say I'm working with SDFS itself, my requirement, again, if out of the 2 options, I usually, my job is to make things little cheaper. So out of those 2 options, EMRFS versus SDFS, EMRFS charges you a little extra. It's not much, but it's little extra, and I work with like petabytes and more than that amount of data, so it kind of makes difference. So I usually work with SDFS itself. So in the next demo I was mentioning, what we'll do, we'll have files in S3. Instead of just using EMRFS and getting access to all the files, what I'll do is I'll just get whatever files I need from S3 inside my SDFS volume, and then we'll do all the batch processing and all those tasks. Is that clear? Okay, let's play around a little more. So this is my name node configuration. Where is my U? Okay, it's in Chrome. Let me just take it to Safari itself. So next thing that we are doing is, I think I created this cluster with Hive as well. Yes, no? Anybody remember? Anyway, let's see. Oh yeah, yeah, here. I have Hive. Hive, U, Mahot, Big, and these unnecessary things.
Okay.
Basically, if you have heard about sklearn, so all those algorithms that sklearn provides you, Mahot provides the same, but it allows you to directly work with big data. Use putty because I'm not on Windows, but if you're on Windows, then you can do the same thing. It's just few additional steps. And let me show you. It gives you this option, connect to the master node. I did this thing, Mac Linux thing, but it has all the steps for your putty as well. Very simple. It's just that it has this additional check which putty requires, but rest other things remain same. Does that answer your question? Okay. So let's do something very basic with Hive as well. So we have logged into U, and for that I need some file. Let's create a file. Quickly tell me your name, age, and your job role, and we'll create a basic file here. Anybody? Let's make it personal, otherwise I can obviously write John Doe. Firstly, main objective was to know you guys. Second is I'll just upload this basic text file that I've created in S3, and then we'll bring that file to our U just to run a basic. We'll first create a table, and we'll have all this data populated in that table. That's my intention. Let's see if I'm able to achieve that or not.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Basically, I wanted to introduce Hive to you, Hive inside Hadoop ecosystem. Hope that is not lame enough. S3, why do I have this much? That's why I'm getting charged for my AWS account. I have to delete all this thing. Let's create a bucket. My Intellipaat class. Okay, that file is uploaded. Where is my U? I'll go to Hive. I'll type use default. Okay, that did run. No issues so far. Let's create a table. Database engineers, please help me. Bad with database. String. What else was there? Age. And last thing, job in string. Correct. So in this case, as you can see, we have provided this row format delimited by comma. So wherever it will see a comma, it will know, okay, this I'm referring to the next set of column. and lines terminated by this, it will know that this particular row is finished here. So usually this is the format Hive works with. Okay. Good question though. I think I'll run into some issue related to S3 access, but let's see. So location, I've provided it here. I think we need to provide a semicolon as well. Why the my failed password message to S3 location? What is the problem? Oh yeah,
Yeah.
sorry. Yep, it ran. No, it didn't. Huh. So it has created this table as you can see, but I don't think it will have any data. Let's confirm that as well. Strange. I didn't expect this, but yep.
Okay.
So,
It's not
but then you have IAM role in place. Currently, I have access to only S3 buckets that are present in my account. So let's try to run this query one more time. Now we have two files uploaded here. One is transactions.csv and another one was some demo.txt. And let's see what happens. So create table, new table 2. I think still it will be able to create one table. I think what it is doing internally is it is checking whether it has this three things present. Anyway, let's not assume.
let it go.
So as you can see in my location, there is just the bucket path and not the file path.
Correct.
Error while compiling is failed path, cannot recognize input near name string. So as you can see, this time it's not running because I don't have just one file, but two. And let's try to do. Let's try one more approach. I am providing the exact path of the file that I have there as well. And let's see if it is able to do it now. I think it will. No. And now what do you want? You want me to provide the same bucket path, right?
Right.
Related path is in path to this particular file demo2.
Yeah.
As well. Saved queries. Oh, query history. Select all from new table 2. So I guess it appends to it. So as you can see from her till this Shikha, it has file 1, then it got the file 2, and it appended the file what transaction.csv file that I uploaded without any context. That's intentionally we did that. We wanted to see what happens if we don't provide the exact file path.
Correct.
So let's do one last test and we'll
Yeah. So
call it new table 3. And this time I'll provide the exact path. Why did I do that? First demo 2, copy S3 URI. So table 3, that is correct, right? Yeah. I think it will give an error. Yep. I think we have to provide one slash here. Still an error. Completed executing blah 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 blah. Execution error, return code, meta exception. Okay, is not in directory or unable to create one. It wants a directory itself. It cannot take the direct file path. They're correct. Individual file must be inside an individual bucket. New lesson for me as well. But yeah, that can be automated. Whatever code you are dealing with, you can have it to create mkdir, some sort of uh, folder for every time you're creating a file and then consuming that file. That is the basic logic. Getting confused between Hadoop operation and Hive operation. What you're mentioning is Hadoop operation. So whenever
okay.
you, let's say, you have some sort of requirement that you are dealing with, let's say, video data, and you are storing like millions of images because it
Mhm.
has a lot of frames. So in
Mhm.
that case, it is not required that every frame or every image is stored inside one folder, because
Okay.
that way you're dealing with Hadoop. You can have one folder, let's say Hirsch face, and inside that entire video, 1 hour video containing millions of images of my face in one folder itself. Currently, we are dealing with Hive. Hive is for your SQL related queries. So for that, it requires a bucket. So DynamoDB is mostly used whenever you're dealing with like single digit latency. And basically all these web applications that you use nowadays, they are built on some sort of NoSQL database. At the backend, they might be using Cassandra, RockDB, whatever. And DynamoDB is just a NoSQL database, just like them. It's a managed service by them. So any web application that you're dealing with, I can be like 80 to 90% certain that they are using some sort of NoSQL database. And if they're using AWS, it is going to be DynamoDB. So anything which requires like, for an example, if I usually give AWS related examples because I work there. So for an example in Amazon, whenever you are dealing with their product page and you're dealing with top 10 products, or you want to see what is the highest sold products or lightning deals product, things like that, all those information comes from your DynamoDB, because there you require data which is like in cache or very frequently accessed data. In that case, DynamoDB is the most suitable. But again, you can customize it to suit lot of relational databases related workload as well, but it's not ideally made for that. Does that answer your question? Or I'll give you a better example. So for an example, you're dealing with some sort of, let's say if you play Fortnite or something like any sort of game, in that case, whatever leaderboard you have, those leaderboards are 100% on NoSQL database or DynamoDB kind of application. Okay, so true. So all are valid points. And this is actually what you need to know for this examination as well. So what you need to know is what HBase is, how it is different from DynamoDB, how it is different from Redshift. And that's pretty much it. And some use cases where you might be using HBase. And if you are aware about that, please go ahead and share. And anyway, I'm going to share what I know as well in terms of its formal definition. So HBase, it's a massively scalable, distributed big data store in your Apache Hadoop ecosystem. So you mentioned it correctly that it is tightly integrated with the Hadoop and the Apache ecosystem itself. So firstly, it's open source. Then secondly, it's a non-relational database or data store, whatever you want to call it. And it's a version database as well. And what it runs on top of is it could run on top of your S3, or it could run on top of your SDFS, as we have seen in the last class. So it supports both. So whatever you want to work with, HBase supports both as well. And what it is built for, it is built for random, strictly consistent, real-time access for tables with like, and we already mentioned that it's made for scalability. So it works really well whenever we are dealing with like billions of rows. Again, I for some reason cannot use my pen, so please bear with it and make your notes accordingly. It's an open source, non-relational version database. What it runs on top of, it runs on top of your S3, or it runs on top of your S3 or SDFS. And what it is made for, it is made for random, strictly consistent, real-time access for tables, which consist of like billions of rows and millions of columns. So if you have any use case which requires that many rows and columns, HBase is kind of very nice to be used in that kind of scenarios. Secondly, as we saw, that it integrates very well with your Hadoop ecosystem. So anytime you want to work along with Hadoop, you want to work along with Hive, and you want to use Apache Phoenix, which I don't think is required for this examination, but I'll tell you a little later in at a very high level what Apache Phoenix is. So whenever you have requirement of all of this thing, Hadoop, Hive, Apache Phoenix, in order to run massively parallel analytics, apart from just storing your data. So HBase, it will support you with the storage of your data, which is in scale of billions of rows and millions of column. And on top of that, if you want to run analytics, which could be using Hive, Phoenix, or your Hadoop ecosystem, you can do all of that because they are tightly integrated or very nicely coupled with each other. Later on this lecture, I'll show you a demo of how HBase and Hive integrate together. So after this, let's take a look at some of the use cases for HBase. So let me think. Let me first clear my screen. Let me first try to open a document where I can type in few things. So yeah, can you see a document? So as I want to create few of my notes, I am using this. So for an example, if an ad tech company who want to run some sort of, so I was mentioning what could be the use cases of HBase. So it will help you visualize where exactly you can use HBase, because your examination is going to test you on. They'll give you some sort of scenario and they'll ask you to differentiate whether DynamoDB is a good scenario or a good application to be used here, or it could be HBase, or it could be something else, Presto or anything. So that's where you should know where HBase might be used. If you have any guesses as per the definition that we have seen, please feel free to pitch in here. So as per me, for an example, edtech companies who wish to do click stream analysis, HBase in that scenario can be a very useful tool where they need to have like move incremental data to a data store for analytics, processing, as well as serving. So in order to move this data, they can directly use HBase. For processing, they can use Hadoop power of MapReduce. And for serving it again, they can probably share some sort of result using Hive. They want to filter, they use some sort of joins and things like that. Basic thing which SQL queries can do. HBase, as it integrates with Hive, they can do it there as well. So one use case would be your clickstream analysis. Another, and this is a real use case. So I was reading about it recently, and Facebook and Spotify both, they use HBase. And where do you think they might be using HBase? User logs, okay, that's one thing. They obviously can use it there. Anything user oriented or the customer oriented? User would be your employee oriented. No, that's what I mentioned. Anything user oriented feature, like logs are more employee oriented. Anyway, I'll tell. Absolutely. So we mentioned that HBase is very nice for things which are at very big scale. Big data, basically, we are dealing with entire certification about big data. So we are dealing with scalability at first. So what is Facebook's thing, which is at like immense scale? I would say their messages, and specifically for their messenger feature, where again now WhatsApp is Facebook as well. So all of the messages that we are sending through Messenger, WhatsApp, whatever, it needs to be saved somewhere. And this messages, They need to integrate it with email, they need to integrate with instant messages, text messages, on-site Facebook messages, and so on. So what they did, they chose HBase because of its scalability, because they know that their messages are going to be at, like, obviously more than billions, I would say. I am not sure about the exact figure, but yeah, obviously it would be at least that much scale. So HBase, it also supports very high rates of role level updates over your massive amounts of data. So that is another good example or good use case why they are using HBase. Then HBase is also very useful for Facebook, because when you have like variety of application clients, such as your Facebook can be used in browsers, it can be used in your mobile devices, and so on. So each client, they need the same content, but in a different format. So whenever you have this requirement of this kind of requirement, uh, HBase again serves well for this requirement. So what do I call it? I don't know what to name it. I would say anything, any suggested name, again, because I am naming, I don't know what is this feature called of HBase. Platforms I would write here, but yeah, I hope you got the point what I'm saying, because whenever you have a requirement where you want to serve the same data but to different platforms, in this example your web browser, your application, mobile applications, or things like that. So in that case, HBase is very nice for that kind of feature or use case. Then apart from that, you have your users not only consuming content, but they are also producing variety of content in huge volume and at very high speed as well. So for an example, your tweets, Facebook posts, uploading of images, blogging, whatever. So whenever you have requirement where you're not just saving, I mean, you're not just serving the content that is already saved, but you are also storing content at the same time. So HBase is very good for that scenario as well. It's basically it's a perfect choice of a backend for applications such as Facebook, because they know that it's going to be at a very huge scale. It is going to be served on different platforms. Apart from that, at the same time, people are not just going to consume the content, they're producing the content as well. So something which can do both, to show whatever the content which they have already saved, they want to show it. At the same time, whatever new content they are generating, you want to store it at the same time. HBase is a very good place to start off with. So that's why HBase becomes the perfect choice of a backend for Facebook. Apart from those, I know that there are a lot of people here in this class from US, so you might probably would have heard of FINRA. So for those of you who don't know about it, or they have not heard about FINRA, so it stands for your Financial Industry Regulatory Authority, and they are an independent financial securities regulator in USA, and their main role is to monitor and regulate your financial trading practices. And FINRA is a very large AWS customer, and they run this HBase on EMR backed by S3 for their random access on what was the figure, 3 trillion records. If you're interested, there is an entire blog post, very cool blog post about usage of this EMR using S3, sorry, HBase using EMR using S3, and it is written by the Director of Performance Engineering at FINRA. So if you want, I can give you the link of that blog post, and it will give you a very much idea of what EMR is and what specifically HBase is. It's not based on EMR, but more on HBase. So for basically, let me write it down if you wanna know. So this blog post, just even if I don't share the link, you just have to type FINRA AWS blog post and it will come up. A very nice blog post if you want to know more in detail, which is not required for this certification, but yeah, just for your curiosity. So let's go a step further. So whenever you have large amounts of data, essentially, let's give some number to it. So whenever you're dealing with the data which is in gigabytes to petabytes of range, and you need that data in a distributed environment, HBase is going to be a very good candidate. Okay, so besides having large amounts of data, you should use HBase if you have high write throughput and update rates as well. So high write throughput, and somebody who wanna pitch in and explain what is high write throughput. I want answers from you. Obviously, you might have covered it already in the content that you have already covered about this certification so far. Somebody? Or do you want to guess as well from the name? Name is written in front of you. High write throughput. Yeah, Facebook uploading of images or generation of posts or sending of messages. All of these things are coming at very high the write throughput is very high in those cases, and the update rate is going to be very high as well. What does that mean? So for an example, people are not just writing content or not generating content immediately, they are just making more put requests as well. That means they're updating content as well. So HBase is a good candidate whenever there is a high update rate as well. People are going to be updating the content again and again, again and again. HBase supports that. Apart from that, HBase supports low latency lookups. So whenever you have a requirement, if you wanna scan your data, query it, and show it to the user what are the results of that particular query, HBase supports that as well. It supports both lookup and it supports your scans both, and it supports efficient updates and deletions as well of individual records. So HBase, in short, it can also be used if you have a NoSQL flexible schema requirement for your application. So it supports that, and somebody already mentioned this. So there are two operations. If you have covered DynamoDB, you should know that AWS supports both your queries and scans. So it is the same scan. So scan is basically, let's say you have a table containing 1 million records. So it will go through that entire table. It will basically scan that entire table. But out of that table, you did some sort of where clause, and the final output is going to be just 10 rows from that particular table. So in some scenarios, obviously it looks very inefficient that you have a table containing 1 million rows, and then finally you want result out of that of 10 rows itself. So in the first place, why you're scanning 1 million rows? But in some cases, scans are preferred, very few cases, but it supports that as well. Query, in on the other hand, what it does, if you have a requirement of final output is going to require just like 10, 20 or 100 rows, it is not going to scan your entire table and waste resources there. It will just scan that particular portion of your table. Okay, moving on. So in summary, if you require fast access to your data and you need random and real-time access to that data, then HBase is going to be a very suitable candidate. Whenever you require low latency lookup, whenever you require a NoSQL flexible schema kind of requirement, and whenever you have a scalability kind of a table is going to be a huge scale, it is going to require high write throughput, HBase is probably going to be your solution. But yeah, obviously, if you are aware about, I think you guys have gone through DynamoDB by your previous trainer, so you might be thinking why we are not using DynamoDB. All of these things, whatever we have covered here, it could be done not just by DynamoDB, but few other things as well. So why we are even discussing this? So if you have that question, that is very nice, because that's what they are going to gauge your understanding on. So it finally boils down to what kind of use case you are going to be you are presented with, and basis that use case your requirement change. And I'll try to cover a few use cases, just like I have covered how Facebook is using, how Spotify is using. So there are few use cases where it is highly beneficial, and we have seen those use cases. And then there are few things where it is not going to be very usable. So I'll write it down for your notes kind of per se as well. So please write it down. I'll probably will forget to share this additional document that I'm creating here, or you can take screenshot if that is permitted from your application. So first we'll see where you should be using HBase. So whenever you have large amount of data, and when I say large amount of data, I'm talking 100 gigabyte to petabyte scale. That much it can support. Apart from that, we have seen whenever you have a high throughput and update rate kind of requirement, I hope that is clear. Then you have a NoSQL flexible schema kind of requirement. Apart from that, you need fast access to that data. It's not just about storing the generated content, but you want to access that data very quickly as well. And it could be very random. And lastly, very important thing, it could be real time. And finally, whenever you have a requirement where you want fault tolerance in your NoSQL kind of environment. So in all of this use cases, any use case which is presented to you in your certification, which covers 2 to 3 points from this list of the use cases that I've mentioned here, HBase is going to be your answer there. And now we'll see when not to use HBase. Can you think of a scenario where HBase is not going to be a good candidate? Absolutely. So joining complex join queries, it does not support that. Even if it can support that, it is not going to be efficient. Yeah. So basically this complex join queries, you mentioned something very specific, but I'll write relational database type of features. So anything which requires like ACID compliance and things, those features which your relational database supports, it is not going to be very good. It usually supports NoSQL related database and all those use cases that NoSQL databases are good for. Then I would say very important thing. This came in my examination, so I remember. So whenever you have transaction applications, and can you give me an example of this? Okay, I'll give an example. So again, taking my own example. So whenever you have a requirement for online retail store, so for example, Amazon taking a lot of orders, in that case, your application requires RDBMS like features. So in that case, for an example, you want all or nothing kind of thing that uh, if we have received payment, then only place the order, otherwise don't do it. So that kind of requirement, all or nothing kind of requirement, which your relational databases are very good for. If you have those kind of transactional requirement, then do not choose HBase as your solution. It is not going to be very, what do you say, preferred there in that scenario. And apart from that, if you need some sort of triggers, complex joins, and so on, HBase is not a solution for you. And lastly, I would say if you have small amounts of data. So if you're dealing with small amounts of data, it may not be worth spending the time to implement that solution in HBase because HBase is kind of tricky. So because of all of these reasons, I can think of, there could be many, but for your examination, this would suffice. There's an entire white paper if you're interested about exactly when to use HBase. It supports, it is not efficient for that, and does not mean that every time you have like billions of rows and millions of columns that your final use case, what data you want to present, it is going to require complex joins. I do not agree with that point that every time you have a big table, that means you will have usage of joins. It could be simple. So for an example, clickstream data, let's say I am storing so many parameters, but at the end, whatever application or the use case of that particular application I'm dealing with, it just requires one simple join or two simple joins of two tables, and that's all. So again, that's why. So whenever there is a scenario you think which requires joins, HBase is not going to be a solution for you. There are different alternatives for you definitely in those scenarios.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Okay. So obviously there are few similarities in terms of like basic similarities that both are NoSQL databases. I'll just give you my points which you need to take care for this examination and to differentiate whether that application should be used using HBase or DynamoDB. So firstly, there'll be something like database model. What is the database model of HBase? Idea? It is key. It's NoSQL, so it's key value. But what exactly? Even in that, there are like few intricacies there. So it's a wide column store, HBase database model. On the other hand, DynamoDB is simply just key value. Anything JSON like you are bringing, it could be a document, it could be just a JSON file. All of those things are supported. So yeah, whenever whatever scenario is presented to you, it requires some sort of columnar storage. HBase is much more preferred there. And second, I would say second point would be row sizes. So DynamoDB, you have already learned what is DynamoDB. So can somebody tell me what is the restriction in DynamoDB for a row size? Here, absolutely, you are correct that there is no as such restriction for your HBase. It's unlimited. Whereas, and again, we are not talking about number of rows supported. We are talking what is the, for an example, I have 10 rows, but what first row can contain, how many bytes it can contain, we are talking about that. So HBase has no relationship there. I mean, no restriction there. On the other hand, your DynamoDB has a restriction, and as you have already gone through that, so please know that restriction. There are a lot of questions related to that. So it's 400 bytes if I'm not wrong. Then third point I would say, and this particular thing is very useful. So for an example, same use case of Facebook, why they are using HBase and not something like Cassandra or DynamoDB is that they don't have just data coming in. So for an example, firstly, their messages, it could be much more than 400 kilobytes or whatever DynamoDB supports. Their messages, post, blog, it could be much more than that. So they needed this particular second point to be fulfilled by whatever backend they were using. So all of this Cassandra and all of those, they have certain limited. There's 256 MB in Cassandra and something else in others. I'm just aware about Cassandra, Redis, and few. So yeah, there are certain restriction, but HBase has no restriction over there. And they have, for an example, a lot of images, and your images, they are stored in your byte format. So even that, it becomes bigger than whatever restrictions are placed. So for that one reason itself, HBase is a very good solution. Then you have flexible row key data types. On the other hand, your DynamoDB, it just supports the scalar data types. So somebody who wants to elaborate this point, what does flexible row key data types mean? And again, I have kind of covered it already, but yeah, little more elaboration there. So talking about this, so scalar data types means that whatever your primitive data types are there in float, double, string, varchar, whatever, all those are your scalar data types. But apart from that, your HBase supports much more intricate ones as well. So for an example, this image, you can store image directly as a blob, something like that. I'm just giving one example, but it supports, it is much more flexible in terms of what data types it can store. But DynamoDB is not that much supported. It just supports the scalar data types. So again, if you have any requirement which goes beyond the primitive data types, you cannot use DynamoDB over there, and you have to shift to HBase. And finally, I can think of your index creation. Index creation in case of HBase is going to be manual. So if you have something, it could be a pro and a con both. So whenever you have a requirement where you want indexes, DynamoDB is going to be a good solution because creation of indexes over there is pretty easy. On the other hand, in HBase, it's much more complicated because it is manual. So because of, just remember all of these points whenever you are presented with the solution to compare between HBase versus DynamoDB. Second thing, so we already saw the difference between your HBase versus DynamoDB. Now we'll see HBase versus Redshift. So first thing, can somebody start by saying what is common in both HBase and Redshift? I know you might not have already covered Redshift, and I'll talk about Redshift in much more detail. But if somebody has an idea what Redshift is, what do you think is common in both? It is in terms of your database model. Both are column oriented. Both are columnar databases. So this and this is their similarity. So why HBase over Redshift? So in this case, we have already seen that your write throughput and your updates, they perform pretty well with HBase. On the other hand, Redshift is mainly for your batch writes. So for an example, if you're aware about this copy command, if not, I'll cover this later in our Redshift session. But for that, it is pretty good. So whenever you have a requirement of batch writes, you will go for Redshift. On the other hand, if you have if you require very high throughput in terms of writes, and if you have too many updates coming in, you will go for HBase. Then what else? Let me think. This is again a very big thing. So if you're aware about Redshift, it's all about OLAP. If you have all this complex joins, complex queries, if you have a requirement for that, please go for Redshift. It's made for that. It supports all possible complex join queries, whatever you can think of. Basically, complex query aggregations, all those things are pretty much supported and actually welcomed in Redshift. On the other hand, if you have a requirement where you want like near real-time lookups, basic things you want to query from your data and show it to your customers, in that case, HBase is a very preferred solution, much more than Redshift. Redshift is all about complex queries, aggregations, and all those things. So you have a requirement where your data is changing rapidly and you want near accurate results. In that case, HBase again is preferred over Redshift or even DynamoDB. So these are the few differences I want you to remember going forward in your examination, because that's all they are going to gauge your understanding on, whether you know what HBase is, what are the use cases it is preferred for, how it is different from your DynamoDB, how it is different from Redshift. Uh, in your examination, you don't need to know what is the architecture of HBase, but I'll just give you few points. Let me see if I can draw. So Redshift supports around like 40 petabytes of data. So that is pretty huge, and that pretty much covers all the requirements, even for this top four banking companies as well. And even if they have a requirement, let's say over 40 petabytes, they can go for directly HDFS itself. HBase obviously will not be considered in that scenario. Anything banking, anything transaction, HBase is not your solution. Okay, so let me first try to draw a diagram here, then I'll explain you that diagram. It's kind of difficult to draw a diagram here, but I'll try. Again, this architecture you don't need to remember going forward in your examination. It's just for the people who are curious and having little more understanding helps them to understand the concept. It's for those kind of audience. So even if you're not able to understand it, it's perfectly fine. You can think of it as something optional. And if you want this, please take a screenshot. All of these things, I just do it kind of ad hoc here, and I just clear it after showing it here. After this, the next thing that I will be showing you is the demo of this entire thing, and it's gonna take little time. So let's do it. So it will be done in the backend. So I'll be creating a cluster, and I'll be showing you how you can use HBase along with your Hive. So for that, I'm not going with this basic cluster. I'm going with the advanced option, and an advanced option, whatever by default they have chosen. I'll show you again whatever I'm doing on screen. Don't worry about it. Yeah, that's all I think we are going to require. Next, this I don't need, so I'll just do 0. My cluster log, all things default is fine for me. Create cluster. Okay, so hopefully it will be done in the backend. Until then, we can discuss what we were doing already. So this diagram, can you see and probably read few things here? Before that, again, this thing, as I mentioned already, mentioning this again and being redundant here. So you don't need to know this architecture going forward in your examination. And for your examination, what you really need to know is what HBase is, what are its use cases, when to use it, when not to use it, how it is different from your Redshift and DynamoDB. That's all is required for your examination. So you don't get tested on the internal operations of HBase. However, it is just good to know what is the HBase architecture, and that's why we are going to discuss it here, even though you won't be getting tested on it. So let's first start with Zookeeper. So this component here that you're seeing, this is your Zookeeper. I'll just write ZK here. So this square or rectangle that you're seeing here is your Zookeeper. And sorry, and what is Zookeeper actually? It's a distributed coordination service to maintain your service state in a cluster. So whatever cluster we are creating, it helps to coordinate different operations inside that particular cluster. So even Hadoop uses Zookeeper for few of its operation. Few other things uses Zookeeper. All this Apache ecosystem, a lot of them uses Zookeeper. So again, we are discussing at a high level. So what Zookeeper does, it maintains which servers are alive, what servers are currently available, and it provides service failure notification as well. So whenever something fails, it provides this failure notification that this particular server is down and things like that. So that's what Zookeeper at a very high level does. So coming back to HBase, in your HBase, what happens is your tables are split into different regions. So as you can see, this is your region server 1, this is your region server 2. That's what this RS stands for, region server. So your tables, they're split into these different regions and they are served by this region servers. And then your H master, what is written here is H master. So if you can't read it, please note it down. This is H master. So what H master does, so this H master distributes services to different servers. So as you can see, it is distributing something here, it is distributing something to this particular region server, and it also assigns regions to your region server. So inside this R that you're seeing, this are different regions. So for an example, taking basic examples, for an example, this is your US East region, and this server is located here. Inside that region, there might be Northern Virginia, there might be Oregon. So all these R's, there are different regions, and that's what your H master does. Whatever task or table it is getting from your client, it distributes that particular task into this region servers, and it also takes care of creating this different regions. And finally, note that your HBase is built on top of HDFS. So this last layer that you're seeing here is nothing but your HDFS. So that's what your HBase is built on at the back end. It is using HDFS, Hadoop distributed file system. So it's built on top of that. So when running HBase on EMR, you can run Zookeeper on your EMR cluster. Your core nodes and your task nodes would essentially be your this region servers. And if you choose to use HDFS, then you would run HDFS on your core nodes because your task node, they are not persistent. But you do have the benefits of using EMRFS as well, which takes full advantage of S3. So you have both options. You can go for SDFS or you can go for S3 as well. But in our example that I'll show you after this, we'll be using the default SDFS one. And this region servers, they are nothing but your core nodes. And this will be much more clearer when I'll show you how to create this HBase in our actual console itself. So I hope you are with me so far. So we have a client which is generating all these tables, and all those things goes to HMasters. And HMasters, what its job is? Its job is to distribute all the tasks it is getting into the different region servers, and also to create different regions inside it. Then I mentioned that your HBase is built on top of your HDFS. It could be S3 as well using EMRFS. So that is the architecture of it. These are the components. So this is your Zookeeper, this is your HMaster, this is your client. Everything is built on top of HDFS. These two squares or rectangles that you're seeing, they are different region servers, and inside that you have this different regions. So I hope that is clear. If it is not, please don't ask questions because this was an optional thing anyway. So that's all I wanted to explain about the HBase architecture. If you want, and if you can understand something from this terrible diagram, please take a screenshot and let me know if you're doing it so that I can clear it as per your acknowledgement. So apart from this, what I wanted to share about HBase is nothing much is remaining. So basically, I wanted to talk about integration, which probably I already have, but let me do it again. So other integration includes, let me first go to pointer so that I can type it directly instead of drawing things here. So talking about integrations, what HBase supports your ability to use Hive directly along with your HBase tables. Then you can use Apache Phoenix as well to access those tables. And if you're not aware about Apache Phoenix, I'll just tell you quickly at a very high level that it is used for OLTP and operational analytics, allowing you to use standard SQL queries. That's all Apache Phoenix is. And it allows you to use JDBC APIs to work with HBase. Please see the documentation of HBase and all of these things, which will be much clearer to you. So yeah, not wasting any further time here. Let's quickly jump into a quick demo of how we can use HBase shell and also how we can use Hive to connect to HBase. So here I am in the console. Service or default is insufficient. I don't know what is happening. I'm not able to create a cluster. So let me just open a different AWS account altogether. I think I have some issues with this AWS account. For some reason, there is lag. Whatever screen I am on, you get to see that screen 1 second later. So sign into the console, sign in using the root user, my email ID. What was my password? Damn. Okay. I actually don't remember my password, so let me, oh yeah, it's saved in my Safari, so let me open that. Yep, awesome. Oh, they changed the console home. Maybe later I'll check. So here we are in the AWS console and we are in EMR. I'll click on create cluster. Oh, this one is being terminated. Oh, this is the one that we used on last class. So I'll go to create cluster, then I'll click on advanced option. And apart from the defaults that are already selected, in addition to that, I'll select HBase and Zookeeper. So as you can see, if I want to use HBase, I need to have Zookeeper. And the whole reason of doing that entire demo was to show this, that HBase, you cannot use it just directly. You need to have Zookeeper because it's part of its architecture. So I hope it is clear now why I did that terrible diagram earlier. So yeah, as earlier I mentioned that you can use SDFS along or S3. So let me check, where is that option? It should be somewhere here. Anyway, and I so for this particular demo about HBase, this is the only thing that we need to select, HBase and Zookeeper. But I'm selecting few other things which are going to be part of next demos. So for an example, I'll be showing you Spark. So I'll select that. I don't know if I'll be showing you Presto or not, but I'll still select it. So currently, just remember, these are the things which are not required now, but I don't want to create a cluster again. So I'm just choosing these options as well. Then I told you, we saw that HBase is built on top of HDFS, but as you are using it on EMR, EMR gives you another option of using EMRFS as well. So you have this option of S3 too. But in this case, I'm just going to leave the default of HDFS and click next because that is sufficient for this particular demo. Apart from this, if you want, you can pick your own VPC, you can pick a subnet that you want to work in, but as it is a demo, I'm not going to do any of this task. Then to keep things simple and save cost of my own personal account, I am not creating core nodes. And if you remember, I told you last time, if you don't select any core nodes in EMR, then your master node is also the core node. So just to keep cost to minimum, I am doing this, but feel free to do as per whatever task you're dealing with. And I'll also change configuration to c1.xlarge. Then I'll click next. Then I'm going to leave the defaults here for my cluster name and for logging, whatever folder it is creating in S3 bucket, I'm fine with it, but you can definitely change it as per your requirement. So I'll go ahead and click next. Then after this, I'll go ahead and choose the key pair that I created in the last class so that I can SSH into my master node. And finally, this will be my last step. I'll click on create cluster. So I hope this is fine and you're okay with the steps that we did here. You know how to initiate a HBase cluster on top of your EMR cluster. Okay, so anyway, as it's gonna take 5 minutes, so let's come back after a 5 minutes breather. It will give you rest. And okay, so we'll wait for one more time. Until then, we can go back to discussing little more theory, and that is going to be about Presto. So I'll start with the same thing that we do here. You tell me what you know about Presto, then I'll start. So what is Presto? So Presto, it's an open source in-memory. This why I'm writing is because I don't have notes or slides content for it. So bear with it. Fast SQL query engine. So as simple as that. And I'll give you an interesting fact as well. Anybody who has used Athena here? Seriously? I thought people have done other certifications and they are ETL engineers and database engineers here. Anyway, so your Athena, if you're aware about it, it allows you to run SQL queries on the data that is stored in your S3 or Glue data catalog. So your Athena, it's built on top of Presto. So what AWS has done, they have taken this open source thing called Presto. They have used that to build their own proprietary product, Athena, and they charge you for that. As simple as that. So they have taken a product which was open source. They have made few adjustments there and much more integrations in their AWS ecosystem, and that's how they are earning. That's what they do with a lot of products actually. But yeah, it's pretty nice. So yeah, just the fact that Athena actually is nothing but Presto, which is much more refined for a corporate product instead of an open source product. That's all Athena is. So Athena, oh sorry, Presto is your open source in-memory distributed fast SQL query engine. It allows you to use ANSI SQL, so you don't have to learn any other programming language to use it. It allows you to run SQL interactive queries, analytic queries against a variety of data sources with sizes ranging from, again, gigabytes to petabytes. It allows that much. One interesting fact, again, and important for your examination is your Presto is significantly faster than Hive. And we'll see that in a demo as well. We'll try to query something using Hive. We'll try to query the same thing using Presto. And probably we can skip that as well because it's going to take 10-15 minutes and it will just show you. So I did that test before giving you this fact just before this class. So I queried a table containing 100 rows itself, and Hive gave me results in 8 seconds. On the other hand, Presto gave me the same results. I did just the select all from table query, which was basic. So Hive gave me results in 8 seconds versus Presto gave me results, same results in 2 seconds. So yeah, Presto is pretty, actually a lot faster, significantly faster than Hive. So let's quickly go over some advantages of using Presto. And let me see if my cluster is starting. I think it is starting. So what Presto's advantages are, Presto allows you to run queries over different kinds of data sources. It supports both your relational as well as NoSQL databases. It also supports different kind of frameworks. And what basically that means that it allows you to run Hive to Kafka, things like that. It works pretty well with Hive as well as Kafka. So it works with different kinds of databases. It works with different kind of frameworks. So that's one advantage of using Presto. Then there are different connectors in Presto. And so what are these connectors for? So all of these things, like if you want to use Cassandra, if you want to use Hive, Kafka, MongoDB, MySQL, PostgreSQL, Redis, just to name a few. There are much more, and you can see AWS documentation to know what are the different kind of connectors. So these connectors, they weren't created by Presto, obviously, but they are available with EMR to use. So this is something that AWS has done additionally to Presto. They have created this different Presto connectors so that you can quickly query whatever database you want to do using Presto itself. And Presto is much more, as we have seen, using all of these things natively. Presto is much more faster than all of this. So yeah, that's why we'll be using this connectors, and these are created by AWS and not by Presto. So having this connectors is pretty helpful, because if let's say you have a company with petabytes of data stored and you have got hundreds of employees querying that particular data, so then being able to use Presto is very convenient, because at one time you could query Cassandra and the next time you could query against Hive. So it's pretty convenient, I think, because I usually am currently working with something that requires Redis, Cassandra, and Hive. And all of these things I have made separate connections, and those are all custom connections. So sometimes I face a lot of problems here and there. I have to remember ID and password for all of them, or I have to store them somewhere convenient. I have to keep on changing those ID password and a lot of things. So if there is something like Presto connectors where I can just switch in quickly from Cassandra to Hive, that'll be very convenient, I feel. So to launch a cluster with your connector and configure it, what it allows you to do, it allows you to use a JSON file. And if possible, I'll show you while I'm showing you the demo how you can use this JSON file, which will be stored in your S3 bucket directly to allow this different connectors. So whenever you're launching the cluster, it could be through your CLI console. You can just call this particular JSON file, and that particular connector, let's say Cassandra connector, it will be installed and configured as well. All of that is done using a JSON file. Just remember this fact. Apart from that, Presto allows high concurrency. So that's another thing about Presto, that it allows you to run highly concurrent queries. It allows users to run thousands of queries per day, and these queries can take anywhere from sub-second to minutes to complete. So it has this much of concurrency possible. With Presto, it allows in-memory processing, and this in-memory processing, as the name suggests, you can imagine that it will avoid any unnecessary input output operations, which will lead to low latency. Then your Presto queries, they run directly against the Presto engine. There is something called Presto engine. So what basically this means, running queries directly on Presto engine, that you don't need an interpreter layer, which is required in case of Hive. So again, one component is gone. As that component is gone, it leads to low latency again. So that's why that comparison I told you, 8 seconds versus 2 seconds, because of these 2 points. This one is in memory processing, so it avoids all this input output operations. Second one is usage of Presto engine, because when you are running Hive, it requires an interpreter and Presto does not require one. So there are a couple of Presto questions on your examination, and for the same reason, I have covered what Presto should be used for. But
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
we'll see what it should not be used for. So we have seen the advantages where you can get the idea where exactly you should be using, where exactly you should not use Presto. We'll see that now. So again, whenever you are dealing with a traditional databases, basically something that is not designed for OLTP kind of operations, uh, Presto should not be used. Presto is much more convenient for OLAP operations. So if you're joining extremely large tables, then Presto requires certain optimizations. So instead of doing that, just use Hive. Hive does not require that. So whenever you have a requirement of joining extremely large tables, don't use Presto, just use Hive instead. Hive is much more convenient in that particular scenario. Apart from that, do not use Presto for batch processing. With Presto, there is no disk input output operation, and the data being queried from your multiple data stores it needs to fit into the memory. So do not do an batch processing kind of operations there. Queries, basically queries that requires a lot of memories can fail here in Presto. So that is why Presto is good for interactive queries rather than very large batch drops. So yeah, that's all I wanted to cover about Presto. And let's go back and see if our cluster is up and running. So yeah, it's up and running. So yeah, we have, why my cluster is showing waiting. Did I create a step cluster? Anyway, so we know that we need to change the security group few things. So let's quickly do that. So for this particular demo, I think we just need the SSH port. Do we have that? No. SSH, and I don't know my IP address, so I'll just keep it. So that is done. We just need to go to terminal and SSH into it. Damn, that is EMR. Okay, so next thing that we have to do is SSH into our EMR cluster that we created. So for that, I like to do this, which is simple. Copy this, go to terminal. Terminal font size I know is going to be small for you. I really have to know the shortcut for this. Huh. It's command plus. Is it big enough? Okay. So for that, first I need to cd into my downloads. SSH. No. Let's first try this. Okay, my PEM file is not here. Let me quickly check where is my PEM file. It was named demo. Yeah, it is in downloads. It's giving me this. Oh, got it. What I've copied is this path, but I need to just do this. Should work. Yep. So we are SSH'd into the EMR cluster that we created. Now, next thing that we have to do is I'll show you how to use HBase. So for that, you just type HBase space shell. So as you can see here, we are inside HBase as well now. So as simple as that, you just type HBase shell. And now what I'll do is I'll create a very simple table called something. Teams. So it has created a table for me. It's just a schema. It does not have any rows inside it. Then I'll, sorry. I'll put a single record in this table. So put EPL, comma, R1 inside a column which is named team1, which is my column 1. I just have one column, and the record that I want to provide there is the name of my favorite team. So that's all. So it has put one record in. No, it didn't for some reason. What I did wrong. Put TPL comma 1. So apparently I've forgotten how to write this, but I think this is the way. Strange. Okay, give me a second. I'll try something, then I'll let you know the exact steps. So I've come out of HBase and I'm just trying to query that table using Hive. And in order to use Hive, we need to do a simple thing before that. So what we want to do, we want to connect our HBase with Hive. And for that, we need to tell Zookeeper that this is my particular server that I'm using. So currently we just have one master node, which is the core node itself. But whenever you have multiple core nodes, whatever core node you want to use, you want to give the path of that. For me, it's going to be simple because my master node is the core node. Column. I have to just copy this. So I'll copy this, paste, and hit enter. And I'll create a table in Hive, and for that we saw the command last time. So create external table. I'll call this one EPL Hive. Other one was just EPL. I should have actually made a note of it and used the copy paste. So avoid my keyboard typing sound. Again, all of this thing that I'm doing here, you will find it in AWS documentation. So nothing to remember or know already. Columns dot mapping. Hopefully I'm typing it correctly. If not, I'll just quickly see it in the documentation. So in this particular line, we'll define what table we want to create. So I'm just giving the table name that my HBase table name is EPL. So just take that table and create a table in Hive using that. So that's what we are doing here. And yep, my query was correct. So it has created a table in Hive. And let's quickly try to query that table to see if it has data or not. Huh, it has. I don't know why it was showing like this here. So when I inserted this record, for some reason the Arsenal record didn't went through. But when I did this, put EPL R1 teams column 1 Liverpool, it showed me here 0 rows were inserted in this many seconds. But in fact, one row was inserted. So there's some issues at their end. Ideally, it should show one row and then the row related details was inserted here itself. But yeah, good for us that it was created. So as you can see, uh, this particular row was created. I just created two columns itself, R1 and Liverpool. That's all. So that is done. So yeah, this was the entire demo. I just wanted to show how to use HBase using HBase shell. So again, we just did a very basic thing. We created a table and we just created one record over there. There are a lot of things that you can do and take it to much more advanced level. And then finally, I wanted to show how you can create a Hive table using HBase. So yeah, that's all this demo was going to be about. So I hope that is clear. And so yeah, just to summarize what we saw so far. So for your examination, these are the things that you should be aware of. So what is HBase? When to use HBase and when not to. So I hope that is covered and clear to you as well. Then how it is compared to your DynamoDB and Redshift. What are the differences when you will be using what? And then HBase, it can be integrated with Hadoop, Hive, Phoenix, HDFS, EMRFS, whatever. And we have seen in this demo one integration, which is HBase integration with Hive. So that's all we have covered today. And if you have any questions based on this many points, please go ahead and ask.
So Harsha, this is Prakash
Yeah.
here. Related to this Presto, right? You are saying that Athena is built on top of Presto, right?
Correct.
So in general computation purpose from client perspective, if you use Athena, you'll get charged, right? You have to pay, right? By queries, whatever you're trying to trigger. But can we use Presto? Can we use Presto and do the querying part and avoid charges directly?
Absolutely, you can do that. But again, I would say depends on the use case. So if you are using Athena for like kind of, let's say you have some sort of requirement, your manager gave you some task that we have this particular table stored in S3 or we have this data stored in S3 or Glue, whatever, and you just want to run quick ad hoc query and generate a one report, which is going to be a one-off thing. In that case, I would say stick to Athena, because Athena, what they charge you for the queries. So let's say you're just running 10 queries. For 10 queries, you're not going to even spend 10 cents over there. However, if you're trying to do the same thing over in EMR, in this, let's say for this particular demo, whatever I did so far, whatever I did, it was in HBase and this thing, Hive. But if you're doing the same task for Presto as well, we have already spend more than 10 cents for sure. So it kind of depends on the use case you're working with. If you are going to run immense number of queries, immense number of concurrent queries, like for an example, you are not doing that use case which I mentioned, which is a one-off thing of creating one report for your manager. But what you're doing, you're using Presto, or you want to run a lot of SQL queries for like, let's say 100 employees, all of them want to run queries for like 7 days. In that case, I would say go for this Presto architecture and go for this EMR using Presto. It will be cheaper for you. So yeah,
Oh, but still Presto also we get charges. That's what my question is. Presto also you need to pay.
For using Presto, you're not paying. You are paying for the usage of EC2. In this case, you are using EMR. At the backend, it is using EC2. So whatever charges you are going to incur for EC2 instances, that's what you're paying. You're not paying for Presto. So in this
Yeah.
case, if you remember, when I was creating this cluster, I chose HDFS, which was the default. If you want to use S3, you just check that box asking you to choose which is S3. I'll show you quickly. So in console, when you're creating cluster, uh, then blah blah blah, HBase, Presto, and as you can see, you want to connect S3, you provide whatever S3 bucket, folder, directory, whatever you have there, you provide that here. That's all. Cool. So yeah, again, coming back to Presto. So whatever I have already covered about Presto, that is more than enough for your cert examination. Again, something that I'm covering here is going to be additional. So good if you can grasp it. Otherwise, you can obviously ignore it. So I am telling you what is the actual Presto architecture, which is pretty simple actually. So Presto, it works something like this. You have a client. Too terrible. Anyway, so this client is nothing but a Presto CLI. You are running your Presto queries using some sort of CLI. So that is your client. This client connects to a coordinator. Just understand this is coordinator. I'm not able to type it. Then at the back end, what it does, it creates this multiple workers for you, as it is a distributed open source. So these are the different workers. This coordinator sends all this information that we got this particular query. Let's say select all from this table. Obviously that's pretty simple, so it will go to just one worker. But if you have a query which 100 people are running, as basis that this coordinator will send that query to different workers, and that's all actually your Presto architecture is, as simple as this. Obviously it's built on top of your HDFS or S3. Storage could be anything, S3 or SDFS. One additional thing that EMR gives you, this is EMR component, not Presto component. So what it does you, this coordinator, again, all this are going from your coordinator. So you can have different connectors. So a connector could be Cassandra, a connector could be PostgreSQL, a connector could be Hive Metastore, all of this. So Presto gives you this advantage on top of on EMR that you can have this different connectors. So uh, I know there is nothing much to understand from this diagram, but if somebody it is helpful for somebody, you can take a screenshot. Okay, if that is done, let me clear this. So we already have a cluster, and this cluster has Hive. Let's try to do one basic thing, which is come out of this Hive. Uh, where is my pointer? Yeah, exit. So I'm out of Hive. Let's see if I'm able to go to Presto. For Presto, anybody aware what is the Presto command? Oh yeah, it is Presto CLI. So as you can see, I am in Presto now. Currently, I don't have anything in my Presto. It was in my another account. So basically, if you'll do, so for an example, the same query that we ran here, it ran in 1.65 some seconds. If you'll try to run the same query in Presto, it will probably take just 0.02 or 0.23, something of that sort. So it will just be much more obviously efficient than Hive. That's all I wanted to show, but I don't have data to show that. Sorry, my mom called. Yeah, so just to conclude, so for your examination, what you need to know is you want to know high level understanding of Presto. Then you should know where Presto should be used and should not be. That's all. And that's it for Presto. Let's go back to our slides and see what do we have here. So we have seen HBase with EMR. Next is we will be seeing Spark with EMR. So SSH blah blah blah, start Spark shell, create an RTD out of text. Perform design. Okay, that's all they want me to show you. Cool. So let's open. Oh, sorry. First, I have to come out of Presto. So I'm out of Presto. You just have to type Spark -shell, and you should have Spark for you. Spark session available as Spark. So as you can see, we are very easily have created and we are able to use Spark. If you try to do this, it's like too much work actually. So before this, I need something in my S3 bucket. I don't have anything here. My AWS Bash demo. Why do I have all this? I obviously don't have data for it, but let me see if I have something. Okay, I don't have a text file, which would have been convenient for us, but I do have a CSV file. Why it is free? Access denied. Sorry, I forgot the command, so I'm Googling. Too much work. Let me just try this. If it fails, I'll try something else. Hmm, Actually, it worked. Uh, Currently, I'm not able to figure out what the error is, but yeah, for some reason, it is giving me this error for a data frame, but using this basic command is working, and I guess we can conclude it here itself for today. I'll see it in my spare time how I can show you the Spark data frame as well. But yeah, for now, this one, as you can see, is working. Where is it? Where is it? So yeah, this particular line. So as you can see, it has created an RDD from S3 at particular this using this text file at this particular console. So yeah, that's it for this Spark demo. Create an RDD out of text file in S3, perform desired Spark operations. I don't have the exhaustive list of the commands, but let me check. I'll keep it prepared next time. Spark. Anyway, I don't have the data ready for it to show you the complete example, but yeah, I hope you got the gist how we can use S3 to create RDD, or you can create this kind of example where they're using a Python-based Spark shell to count a simple file number of occurrences of a particular word or something like that. Sorry. What do we have next? So yeah, with this, we are actually done with EMR as a topic. And the next topic is your AWS Lambda. And I'm sure people are here who have already cleared few other certification. So yeah, please let me know, what do you know about Lambda? So yeah, so in this particular section, we are going to look at Lambda for the people who don't know what exactly Lambda is, or they have used it before. So before that, we are just going to learn a little theory of Lambda, and then we are going to do a basic demo as well. So uh, examples of Lambda. After that, we'll start with the definition, but where exactly you can think you have used Lambda. Everybody has used Lambda actually, even though they have association with AWS or not. You can give your example as well. Where do you think Lambda might be used? So let's start by reading the definition. So your AWS Lambda is a serverless compute service. A serverless being the key term here. So there are no asset servers. Obviously, there are servers somewhere, but you that is abstract from you. So in this case, so for an example, if the same thing what he mentioned, that can be done using, let's say, EC2 as well. But for that, what is EC2 for you? That is a server that is up and running all the time. So for an example, let's say there are no COVID cases for 7 days, but you will still end up paying for those 7 days for keeping your EC2 server running. So that's where Lambda pitch in. So this is a kind of very big abstraction, and I'll talk about it a little more in detail. Currently, let's focus on the definition. So AWS Lambda, it's a serverless compute service where your code is triggered in response to an event occurrence. So as he mentioned clearly that he wants a job done or a form to be filled. So that is nothing but an event for us. So we want certain tasks to be done in response to an event. So that event being somebody tested positive, and the trigger in terms of response would be a form will be filled, for an example. So that's what Lambda will do for us. And there are many places where people are using Lambda. So, and they are saving like literally too much. I'll give you one example. It's one of my favorite example I keep on giving. So while I was working with one of the AWS partner. So my job was to help them transition from a legacy application or a monolithic micro application to a microservices architecture. So that's where we gave them suggestion of Lambda. They did all the transition to Lambda. They wrote all their code and they asked us for whatever help they needed at that for that. And so that was a very big startup in India, and their cost. Let me give you a comparison. So they were spending around monthly uh, 3 to 4 thousand in their current architecture, whatever they had, where they had all these servers running all the time 24/7 for entire year and things like that. Then we moved them to Lambda, and for last 2 year their cost is not more than $500. So they were paying like $4,000 a month, and that has been transitioned or transformed to $500 in 2 years. So that much it has saved for them. So obviously they paid us certain money to do this, but again that was a one-time thing. But they are for the longer run, they are saving a lot there. So that's one use case. It is very cheap, very cheap. When I say cheap, so I'll tell you why. Probably it might be covered in the slides as well. Otherwise I'll tell you my example or whatever I know about it. So it's first thing would be it's pretty cheap because your code is only running in response to a certain trigger. Otherwise you're not paying for anything at all. So that's Lambda. Again, I'm not a big fan of reading all the points, so please somebody do it for me. Absolutely. This is one drawback of Lambda actually, but this list they are expanding every day. So for an example, currently I'll show you in the console as well. So currently they are restricted to few languages like Python, Java, Go, C, C++. All the major languages are covered, but that is one drawback that they have a list of 8 languages currently. And if your application is not in one of those languages, it's going to be a challenge for you. You cannot use Lambda, and that's where EC2 will be a solution for you because it has no environment restrictions over there. Third point.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
So here, this is one layer of complexity gone from your end. You just choose, let's say I want to use Python. You just write your python.py script, give it to Lambda, and it will take care of everything. In EC2, you don't have that flexibility. You first have to choose, okay, I want to go for Ubuntu operating system. Then you'll require all the software that are required to run that particular piece of whatever application you have built. So for an example, FFmpeg, Pandas, this, that, all those softwares you will install. Finally you will write your code and then only it will run. And last point I'll read. So no flexibility to log into a compute instances. We need to choose a customized operating system or language runtime. This one has the flexibility to use a variety of instances. So obviously this is much more flexible in terms of all the custom things that you want to do. Though that flexibility is not there with Lambda, but again it works pretty well for most cases that I have actually been involved in. There was no as such problems in using Lambda. So my favorite example I'll give you of Lambda, and if you probably are aware, if you're not, it will be a nice introduction to this. So most people don't realize this, but every time you talk to Alexa, you're not talking to anything but Lambda. So it's entirely built on top of Lambda. All the skills that it has, all the functionality it has, you're just talking to the cloud. And when Alexa responds back to you, that is the cloud talking back to you. So yeah, Alexa is one of my favorite example or application of Lambda. So before we go on to talk what exactly
So
Lambda is, so yep, it is event driven, but even if you want application, I'll give you example of my own startup. So we are currently working on something, and that entire website is built on Lambda, and you can reach out to that website and keep on using that website for 24/7, and it will respond back. So again, this is how you architect things. So it pretty much can be used for that 27 scenario. That's why I cut you off directly there. That this is not a
Harsha,
limitation at databases anyway. So for an example, my website or any other application which is using Lambda and they are using database as well. In that case, we have DynamoDB, which is a serverless offering as well. So my entire database is DynamoDB. DynamoDB is serverless, Lambda is serverless. So yeah, that's what I just wanted to clarify. So yeah, that can be done, but it's like how you architect. If you have something which is running for last 20 years in EC2, for an example, as a database, that you cannot. So obviously use cases are there for both. Okay. So let's talk a little brief history of cloud. So we we used to always have data centers, at least in 60s and 70s, and essentially basically all organizations initially they would have their own data centers. Some would use providers like, if you're aware, in 60s, or not 60s, in 80s we had this company called Rackspace, and what they used to do, they used to provide you all this physical hardware for your uh, company. So for an example, all the big companies at that time, they obviously not no public cloud was there. There was no cloud at all. So initially we started from that place that every company they used to own their data centers. So problem there. So whenever you order a server, so for example a web server, it actually used to take like for a physical server to be dedicated to you in like from what I've heard and from the colleagues which used to work in that company, Rackspace, that they used to give an order, then they used to wait for like 10 to 15 days for a physical server to arrive. And for some companies and for some geographic locations, it used to take like 6 months as well. So we started from that place. So that was the case. And then in 2006, we moved from that. AWS launched EC2 in 2006, and suddenly we had this option of provisioning all these virtual machines just using a simple API call. So you could have a machine with you ready in minutes, and it completely changed the entire architecture. And that's why EC2 is a game changer, and that's why everybody is aware about EC2 as well, because it's firstly going on since 2016 till now, so at least 15 years. And after EC2, actually, public cloud started becoming bigger and bigger. So, and this happened as well. It was very interesting read, so I read about it. So Rackspace and Amazon, they actually, it was kind of a war between each other, but Amazon could basically completely outspend Rackspace in terms of investment that time. So Rackspace obviously is gone now. There is no, they are not running their operations at all. So it was that big. EC2 was that big that they entirely vanished one organization from existence. So yeah, that was your transition from having your own virtual data centers, data centers to virtual data centers using EC2. We then moved on to some platform as a service, like Microsoft is actually very big in this space. So we, but yeah, Amazon also launched things like Elastic Beanstalk. So if you're aware about Elastic Beanstalk, that's where you don't even need EC2. You don't need your EC2 running all the time. You just provide your code, and as per that code, for an example, your code requires 2 servers. It will create those servers for you. So after this infrastructure as a service, we move to platform as a service using this Elastic Beanstalk. And finally, somewhere around 2014 to 15, Docker came. And again, it was a game changer as well. And again, completely off topic. You don't need to know this for this certification, but for your developer associate, sysops, or solutions architect, you should know what is Docker and all those images. And I think you already know. So that was a transition. So we started from physical data centers, then big change was EC2, then came your platform as a service, which was Elastic Beanstalk. Then we moved to Docker, and Docker is still pretty much in use, but right now the hot new thing is your Lambda. Everybody company or people are investing a lot in terms of transitioning to serverless architecture, and that's where Lambda kicks in. So that's your really the full evolution of cloud. So we have gone from physical servers inside your data centers, and right now we are at a stage to almost ultimate abstraction layer now, which is just focusing on your code, having nothing to worry about anything else underneath it. So with containers, you have that, but still you have to worry about managing your containers, like Kubernetes and doing things at scale. But yeah, serverless, you don't actually have to worry about managing anything. All you need to worry about is your code. So that's what Lambda is, and that's what brings us onto Lambda. So Lambda, in simpler terms, what is Lambda? Again, I'll go back to my documents to write my own. So Lambda, in my definition, I like to call it ultimate abstraction layer. So it's much better than, as at least for me, and that's completely my opinion, it's much better than obviously having your physical data centers, EC2, having Docker images, having that Kubernetes to handle and all these things. So that is the complete abstraction layer for me, and that's what I used like to call it. So what if let's say we are not using Lambda, what all we have to take care of? Let's first see that, so it will give you an idea what all Lambda has made easy for us. So if you're not using Lambda, we have to take care about our data center. Inside our data centers, we will have different hardwares. Inside our hardwares, we will then have our assembly level of code. Then we have different protocols. Then you will have your high level languages. Then you will have your operating systems that you're running. Then you will have a application layer 7, and then you will have finally a lot of APIs to deal with whatever application databases you have sitting on top of that. With Lambda, all of these things are abstracted. You are just focusing on code, and this entire layer is gone. So yeah, that's why I'm a big fan of Lambda. So AWS handles all of these things for you. All you need to worry about is your code when you're dealing with Lambda. So AWS Lambda, it's a compute service where you can upload your code and you can create Lambda functions. And we'll see that in the console itself, what exactly is Lambda functions if you're not aware. Then Lambda, it takes care of provisioning and managing servers on your behalf that you will be using to run your code. So you don't have to worry about operating systems. You don't have to worry about patching. You don't have to worry about scaling. And this is the favorite ultimate game changer for me, that in everything else. So for an example, let's say the COVID application that you gave an example for, currently you're building it for your organization. Let's say you got a contract for building the same thing for entire US, all the organizations there. So in that case, you have to deal with a lot of things when you're dealing with that kind of scale. But when you're dealing with Lambda, whatever code you are running right now, you just have to provide that code to Lambda, and the entire scaling portion will be handled. You don't have to worry about whether you're using one server versus 1 lakh servers or whatever. So yeah, scaling is a big game changer as per me when it comes to Lambda, that it entirely handles that for you, which is a big thing, because every time your code requires a lot of input and work from your end is when you're trying to scale it to a bigger extent. So how you can use Lambda? It can be used in following ways: that you firstly have this event driven approach. So every task will be taken care as per a certain trigger. In that case, it was a positive case. Whenever there is a positive case, then some response will come in response to that. Uh, and this could be a lot of things. So this could be, for an example, change in your database, and that's what my application deals with. So for an example, let's say something happened in your DynamoDB table, that a new record came in. So for an example, a new purchase was made for a certain product. Obviously, quantity of that product changed from 10 units to 9 units. And let's say you have certain trigger or code or some logic created by you, that whenever the quantity of that particular product goes from below 10, you should be ordering that product automatically, something of that sort. So this kind of triggers you can create. this trigger need not be something is returned or something is coming as a response from an API. It could be some change in your database as well. So yeah, lot of things, lot of triggers can be done, and again, that will be much more clearer to you when I'll show you in the console itself what are the different triggers that are possible. So one trigger is your database, another trigger would be your API, another trigger would be some form data coming in from your user itself, and etc. etc. A lot of things. So I'll give you an example of my website that I built, just a POC kind of thing. So in that particular, it's an edtech startup. So therein, whatever sessions I'm taking, for an example, let's take an example of this session itself. Currently, I'm not recording it, but let's say currently I'm teaching you live, and I want to provide the same thing in my website that, okay, this is my entire big data certification class. So what I'll do, I'll be recording all of the sessions. Then I'll be saving all of these sessions in, let's say, S3 bucket. Okay, so that much is done. I recorded this particular session in S3 bucket. But right now, you're probably somebody's my website, whatever I'm building, some people will be using that website in their laptop, some will be using in their iPad, some will be using in Android phones, some will be using in Microsoft phones, or a lot of things. So in all of these platforms, one thing which is so let me try it with the diagram itself. So we have this application where I'm recording these sessions. All of these sessions will be recorded and saved in S3 bucket. And for an example, my recording is done in MP4. I don't know what is the format, but for this example, let's consider MP4. And for, let's say, to use this in different platforms, I want the same recording in different format. Again, I'm just completely writing the made up names. I'm not sure about the format. So let's say for iPhone, I need HEIC, then I need MKV, and whatever other things you can think of. I just want the audio, so MP3. So let's say for this example, I need this 3 different kinds of format. So obviously I don't want to record my session and save it again and again manually in different formats. What I'm doing, I'm storing them in S3, then it's stored in an MP4 format. And after that, I'm using some sort of custom logic, or even if I'm not doing that, I'm using something that AWS has already created, which is called Elastic Transcoder. So this Elastic Transcoder, if you're not aware, what it does, you provide a file, for example, MP4 file, and you tell it to Elastic Encoder that I want to convert this file to MKV, HEIC, MP3 and all, and it does that for you. So that's what I've done. I am triggering that every time I upload a file to S3 bucket, a recording to S3 bucket, I want it to go to Elastic Transcoder. Then I want Elastic Transcoder to convert and then save the files in different formats in different S3 bucket directories that I've created. So I've created directory for iPhone, I have created for Android, laptop, iPad, whatever. We have created those directories, and it will be converted and saved in those respective directories after that. So this is my trigger, that something, every time something is uploaded to S3, I wanted to trigger this Elastic Transcoder job, and this Elastic Transcoder job will finally save the results in my S3 bucket in the respective folders that we have here. And what else? Let me just try to extend this. Anyway, let's just, I'm not able to think further, but yeah, it could be a lot of things. This, once it is done in this S3 bucket, it probably could hit another API, and it will generate some sort of HTTP request, HTTP response, and things like that. A lot of things can be done after this, but yeah, this is one example. Creativity has no limits over there. So whatever example you can think of on the similar lines, you can do it. For just like learning purposes, we built this meme creation website. So what I did there, whatever, I keep on scrapping the Reddit subreddit thing. There is a page called funny meme, something like that. So I keep on checking that, and whatever meme has gotten like 10K and above votes, I take that particular meme, it automatically gets stored in my S3 bucket. As per that, whatever new content or text I provide, it uses the same image, it generates a new meme for me. So this kind of thing we did as well, just for learning. But yeah, a lot of things which are something like on the similar lines can be done. So yeah, that's what Lambda is. Let me go back to slide to see if we have something over there. So yeah, it's serverless architecture. You are away from the servers. You don't have to deal with servers. You just write your own code, upload it there. You don't need to create virtual machines. Obviously, there is pay as you go pricing, and this is one of my favorite thing. It's not mentioned here, so I'll tell you. So for your Lambda, if you're using Lambda, first per million requests every month, it is free. So the startup that we are building, we are running it for like last 8 months, and we have not spent any money there, not even like $1 over there. Everything is running for free because obviously it's not that famous, so we are not getting million requests over there per month. So it's that cheap for anybody whoever is using Lambda. Your initial 1 million requests are free. Then you can monitor performance. There is a extension to it which is called X-ray. You can see, so for example, you have your monitoring things with your monolithic applications. Same thing they have built for Lambda as well, that you can see which particular portion of Lambda is failing, so that you can just go and fix that particular portion instead of just checking your entire code and everything. But there are few drawbacks as well, and you probably should know going forward in your examination that the maximum disk space that it provides you is 512 megabytes for your runtime. It's for runtime. Okay, so what basically this means is the data that is coming into you, the data you are generating in between, it cannot exceed this limit of 512 MB. Obviously, there are few workarounds, but natively it does not. Then your memory volume varies between 128 and 3 gigabytes to the function while execution. Nothing much to focus on. Then this is a big thing. Anything, any operation, any particular piece of code that is not able to generate outcome within 15 minutes, you cannot use Lambda with it, because the maximum time it allows you to run a Lambda function is 15 minutes and the default is 3 seconds. So if your code executes within 15 minutes, definitely use Lambda. If it takes more than 15 minutes, please go for EC2 or something like that. Then last thing that we have already covered as well, only the available languages in your Lambda editors can be used. If your application is beyond those languages, you cannot use Lambda. So how it works, you upload your code to Lambda in one or more Lambda function. Actually, let's not read this, it will confuse you. I'll just show you directly. Yeah, that's all actually is there about Lambda. So let me quickly show you a demo. Do I have something? Let me check if I have a Lambda code already in place. Lambda. Anyway, even if I'm not able to, I'll show you. I have very good examples about Lambda. Anyway, coming back to the Lambda. So yeah, we can use, so that's all you do. You go to Lambda, obviously, then click on create function. And there are few options. Usually what I use is author from scratch. So we write our own examples over here, but there are a few other things as well. So you can use a blueprint, and that is a very nice place to start learning about Lambda. So they have a lot of examples here. So this is one of my favorite example to start with. So if you are interested in building your own chatbot, so I built one own chatbot for my Facebook Messenger. So that was done using this particular blueprint that they have. This blueprint, what it does, using NLP technique, it allows you to book basically a hotel booking or flight booking, something of that sort. And they have the logic for that. But yeah, that's just one example, but there are a lot of things, lot of blueprints that you can choose from, play around with. uh, Let me give you one example. So all of these things are created by AWS Solutions Architect. You can create your own blueprints and save them for reuse again and again. Then you can use container images as well. So whatever Docker image you have, you can just provide that Docker image, and you can, instead of writing code, you can provide the Docker image. And finally, this is another interesting section. So this I actually started learning recently. So serverless app repository, this is one section where you can save your Alexa skills. So whatever Alexa skill you want to build for your own Alexa. So for example, I have built one Alexa skill that whatever I keep on saying here, it keeps on transcribing everything. and basis that whatever words I am emphasizing more, it makes note of it and finally save it to an S3 bucket so that I can go and refer to that. Basically a note building kind of skill. So every time I say Alexa, open my big data class, developer class, it just start reciting the entire thing which I have already recorded over there. Something of this sort. Yeah, but this particular section is all about Alexa skills. We'll obviously start from basic, which is author from scratch. Function name, demo function, runtime. So you are limited to using all of these things. You can use .NET, Go, Java, JS, Python, Ruby, and that's all. Apart from this, you cannot use anything else. So that's one limitation over here, but it serves my purpose. I know Python, I know Java, and I know .js. So all three are supported. I don't face any problem over here. Then permission, whatever permission your Lambda requires. For example, you want to save something to S3 or you want to read from DynamoDB. All those permissions you have to provide by creating your own Lambda, IAM roles. For me, this particular example, whatever role it is creating, it is sufficient. So I'm not doing anything over there. Let's create function. Okay, so a demo function is created. So this particular thing or this particular console that you're seeing in front of you, this is called as your Lambda function. And this is the section where exactly you will write your code, whatever logic you have. So in this case, it's pretty simple that this is your function. What it does, it returns a JSON body. It tells you that it successfully ran with a status code 200, and it just writes hello from Lambda. That's all it does, but obviously you can replace it whatever you have here. uh, for this example, this is fine, and in this case you can, this is how you debug things. You come to this test section, whatever input it requires you provide here, and you just test that particular function. So for me, as you can see, it gave this result which my code is doing, that it should give me a JSON with response code 200 and body with hello from Lambda. So it successfully ran. If it is not running, it will give you an error. Then you can debug that. For monitoring, it gives you a nice integration with CloudWatch metrics. So you can see how many times it was invoked, what was the duration for which this particular Lambda function ran, and other metrics related to it. Configuration, again, very big thing to go through, so I'm not going through everything, but let me give you one example. So triggers, we saw that Lambda is event driven approach, so you can add triggers over here. And as you can see, there are different places that you can use triggers, even third party things. So all of these things are third party. So you can integrate with Freshworks, you can integrate with Atlassian, and a lot of other third party companies that you have over here. But this covers a lot of AWS related services. So let me give you one example. So this is the Alexa section. Every time somebody is asking Alexa something about a particular skill, it will respond as per that. That's how your Alexa is built. So for an example, let me give you example by very simple something S3. So you provide S3 as a trigger, you provide a bucket that something happens to that particular bucket, and you have obviously granular control over it. If something gets deleted from that bucket, if something is updated in that bucket, if something is put in that bucket for the first time, and so on. For me, I'm just going with the all objects. And here in prefix, you can write, okay, something happens to this images folder, then I want to do something. You can do that as well. This prefix is nothing but your directory. And you can have this kind of operations as well. You can write suffix. So for an example, I want something only for my text files. So if a text file is uploaded, then only an operation will be triggered. Otherwise, for other files, it will not be. So this kind of things you can do. But for me, I'm just keeping it to the entire bucket, and my trigger has been added. So every time now something will happen to this bucket, somebody will come and put something into this bucket. This particular Lambda function will run, and this is obviously doing nothing. It's just showing hello from Lambda, but it could do a lot of things like send it to that Elastic transcoder, send it to the REST API, and a number of things as per your custom logic. So yeah, if In this particular section, we'll learn about AWS Glue. So yeah, let's go ahead and get started. So firstly, again, just like every other topic, I'm going to start by asking, what do you think is AWS Glue? I know few are already aware. So yeah, go ahead, somebody. Absolutely correct. So Glue, what it is a fully managed abstraction, transformation, and load service or ETL service that allows you to categorize, clean, and enrich your data. So that's what Glue is. It's already written, but I like to try it. So enrich your data. Then you can also move the data between various data stores, as we'll see later, and you can also use it as a data catalog as well to quickly discover and search across multiple AWS data sets without moving the actual data. So can somebody want to elaborate what your understanding about data catalog is? Okay. No. So let's quickly read the formal definition given here. So AWS Glue, it's a fully managed ETL service that allows customers to prepare and load their data for analytics. So in overall data analytics pipeline or a big data pipeline or any machine learning pipeline, this particular tool becomes kind of very crucial that it allows you to have a catalog from where you can have the metadata of your data, and your data might be stored in some other place. For an example, it could be in EMR inside a Hive cluster, or it could be in S3 and various other places. So it acts as that particular data catalog. So apart from S3, your data could be in Hive Metastore, and this is crucial for your examination. I remember seeing one question related to this in my examination, where they were asking usage of something related on the lines of Glue along with Hive Metastore. So yes, Glue supports that. Your data, it might reside in Hive Metastore, and still you can use Glue to see that data. So instead of MySQL for an EMR cluster, you can use Hive Metastore using Glue. Apart from that, Glue is a serverless service, so you don't have to really provision any instances or worry about managing anything. And next, let's take a look at few use cases for Glue. So you can make data that you have in S3 available for querying, and let's quickly look at how this actually would work. So let me see if I have few use cases here. Yep, I do have. So as you can see here, in this particular use case, we have data which is available in S3, and we want to use the data to query that. We basically want to query that data. So you can have structured or unstructured data present in S3, and after that you can have AWS crawlers like this, which will access your data in S3, extract the metadata from that data, and it will create table definitions in your Glue data catalog. So that's what is happening till here. You have some data present in S3. It could be unstructured or structured data. Then you'll run Glue crawlers, and we'll see what Glue crawlers are as well. And this will access your data which is present in S3. And finally, it will extract the metadata from that, and it will create your table definitions in AWS Glue data catalog. So for now, don't worry about what the crawler is. I'll talk about that a little bit later in this particular section. And then
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
okay. And then using Athena, Redshift, EMR, you would know what type of data you have by looking at your catalog. And then you would be able to query this data which is present in S3. And finally, as you can see here in this last section, and finally, you can use some sort of BI service, for an example, Amazon QuickSight or Tableau or whatever you choose for BI as a BI service. You can connect that particular service to your Glue data catalog, and then you can use Glue in order to clean, normalize, or even enrich your data into a final warehouse, for an example, Redshift, something of this sort. So this is how Glue workflow looks like. And apart from that, so those of you who have already worked with products like Informatica and others, you could use Glue there as well to serve the same function. So in that case, you can have clickstream data in S3, and you may have some customer data in RDS. So let's say Let me see if they have that example as well. Okay. So in this particular example of workflow, so somebody has worked with Informatica here. Oh, cool. I have not used that. So yeah, I worked with Informatica, and in this particular example, so again, if you're using something other than S3, and in this case, for an example, Informatica or something else, you could use Glue there as well to serve the same function. So in this case, what is happening? You have some clickstream data which is present in your S3 bucket here. Then you may have some customer data which is present in your RDS cluster. Okay, and let's say that you want to try to make some sense of customer behavior based on this clickstream data which is present in S3. So in that case, you can use Glue in order to clean that data, to normalize that data into a single table for your data warehouse that is being used for, let's say, customer insights, and probably to visualize everything using QuickSight. So you can use Glue as a data catalog there as well. And if you're not familiar with what a data catalog is still, it is a metadata management tool that helps you manage metadata for various heterogeneous data sources that we have and we'll be seeing later as well. So this Glue crawler, it can crawl through tables and Redshift files which are present in S3, tables in RDS, tables in different databases running on EC2 or DynamoDB tables. So this crawler can work or crawl over this many places. It's obviously not shown on this diagram, but DynamoDB was added later as well. It's a outdated diagram, but yeah, it supports DynamoDB as well. And after that, you can extract this metadata for this tables and file, and you can add them to the Glue data catalog. And finally, you can then access the data sources for analytics or ETL. And if you need to, finally, you can plug in QuickSight or any other BI tool as well. And apart from that, you can use Glue for event-driven pipelines as well. And that's one of my favorite example or use case for this. Let me see if they have that as well. So in this particular workflow, so you can, what we are doing is we are starting some sort of ETL job based on an event which occurs. So in this example, let's say a file is dropped in S3 bucket. I gave you that example last time as well, that I have whatever recording I'm doing right now. I'll be dropping this file, let's say in your S3 bucket from some external source. It could be my local, or it could be any code which is running. It's basically creating a file in S3 bucket. Okay. Then this Glue crawler, it will ensure that the metadata for this file is captured in your data catalog. However, because the file has just landed in your S3 bucket, what Lambda can do, this Lambda, it can trigger your Glue ETL job. Okay, this Lambda will know some file came here. This Lambda will run. This Lambda will trigger your Glue crawler to go and run it. And once the once the ETL job is run, your data is transformed. Let's say you change it from CSV to JSON. You did something with your data, whatever ETL processes you have, and finally you're loading that data into Redshift or probably in S3. So this kind of use cases are possible using Glue as well. And so yeah, that's all about the different kinds of use cases. You don't need to understand Glue's architecture for this examination, but let me see if I have some sort of diagram to explain that. So this diagram will help us understand how your ETL jobs are created and run, so that currently I think few people are having confusion in terms of visualizing what exactly Glue is doing or what it is. But yeah, this diagram, I'm sure it will clarify a lot of things for you. So the first thing you would do here is you create a crawler, and let me take my highlighter. So you have some sort of data store. It could be anything, but for this example, let's say it's S3 bucket. Okay. Then the first thing that we do is we create a crawler, and this crawler, it points to our data store that, okay, this is my source where I have to go and crawl. Then this crawler, it populates your data catalog with the metadata table definitions or file definitions. This data store, as I said, it could be S3, it could be DynamoDB, it could be some sort of data store which you can, any data store basically that you can connect using JDBC connection. So it could be some on-premise connection as well, not related to AWS at all. Then what we do next is we create a job, and essentially this job is really nothing but a script. Okay, and this Glue can generate a script to transform
data for us as well. And that's one of my favorite part about Glue as well, that it automatically gives us this script. So that script is written in PySpark, and one more language I have used just PySpark, so I remember that. Oh yeah, it's Scala code. So either what you can do, whatever transformation that you want to do, either you can give your own code if that works for you, or you can provide or you can use the drag and drop flow that Glue has given, and it will write a Python or a Scala code for you. So that happens here in this particular script. Then, okay, after that, I said that you can provide Glue with a script, and this script can contain either your Python or a Scala code, and whatever jobs you are and this is one piece that you can provide your custom Java, or sorry, Scala or Python code. Or there is one feature that Glue provides, like for an example, you want to drop duplicates, so it will ask you choose this option, drop duplicate, and it will write the corresponding Scala or Python code for you, that okay, this is the code to drop the duplicates from my code. Or it could be conversion, or it could be treatment of some sort of missing values. So all of this functionalities they have given, you just have to kind of choose that functionality, that in this particular data, I want to drop this duplicate, and it will write this code for you. Again, that is completely optional. You are more than welcome to give your own code. So is this clear? What are we doing here in the script portion? And then what I was saying is we can have this, either we can run it on demand, that I want to run this ETL job right now. So that's what we'll do in our demo as well. Or we can schedule it to run sometime at midnight or whatever you prefer. So those jobs can be scheduled. And whenever the jobs are running, your script will extract the data from your source data store. Okay. Not from data catalog. It will extract your data from directly from your data store. Then, as per the script, it will transform that data, and finally, it will load that data back to your target, whatever it is. So, for an example, this data source, it's too much clutter here. Let me erase. So, yeah. So, in this example, I said that our data source is S3. We gave this script. What this script will do, it will take all the metadata from our data catalog, but it will extract the data from the actual data source itself, not from data catalog or anywhere else, directly from S3 in our example. It will take that data as per the script, it will transform that data, and finally the L portion of ETL, it will load that data into data target. And for an example, we are creating a data warehouse. So in this case, let's say this is Redshift. Is that clear? So all of this, whatever jobs you are running, whatever script you are running, it runs in your Apache Spark environment. So everything that is happening in the backend in terms of Glue, it is happening in Apache Spark environment. So that's what gives it quite good speed as well. So after this, for your examination perspective, all we need to see after this is how Glue works against different services. So uh, they might be trying to confuse you by giving you scenario, and they'll be asking you whether we should use data pipeline over here, EMR here, or Glue. So you have to understand those tools and their comparison with Glue as well. But before that, actually, let's see the Glue demo. I think that will help. So let me go to my AWS console. Where is it? Not sure. AWS console. So yeah, this isn't a particularly complex lab, but here you'll get to learn how to use Glue to convert various file format. So in this lab, we will take a look at how to convert a CSV file into a JSON file. But you're not obviously limited to that. You can also convert files to Parquet, Avro, ORC. So the first thing that we want to do here is get a sample data. So I think I have one sample file. But yeah, anyway, I have to upload that file to S3. So let's open S3 as well. So yep, I already have one bucket created. So I'll just upload the file here. Actually, I was searching it with the wrong name. So yeah, this is a sample file that I downloaded from Google Trends, and it just shows the worldwide trend between 3 different kinds of noodle soups. And yeah, In case you're wondering, I love all three. So we aren't looking at data particularly in this particular lab, but we are just learning how you can convert this data from CSV to a JSON file. So we can learn how to convert files in various formats. So till then, it is done. We just want to go to Glue then. And the first thing that we are going to do in your Glue console is we'll be adding a crawler. So there is a section here, as you can see, crawler, and we have this option called add a crawler. And this crawler, what it will do, it will help you identify the schema of that particular CSV file, and you'll quickly see how. So here, let's quickly give it some name, demo crawler. Then it will ask you for the source data type. So in this case, either you could give it the existing catalog table, but currently my Glue metadata catalog does not have many things. So I'll be just giving it the data store as well. And here you have few options. So whether you want to crawl entire folder, you want to create new folder, or you want to create some sort of event mechanism that something happens or comes in this particular S3 bucket, then only I should be creating this or running this Glue crawler. All of those options are here, but I'll be crawling through the entire folder. Then as you can see, these are the data stores that are supported. So you can obviously go with S3, then you have DynamoDB, then DocumentDB, MongoDB, and anything that supports a JDBC connection. For our example, I'll stick to S3. Then I have to provide the specified path of my account, or I can provide a path of another. Just give me a second, I want to adjust my headphone. So I'll go to S3. Why did I close S3? I just want to copy the path. So currently I directly uploaded this file here itself, but if you want, you can create a folder and then upload this file, and then you can give the path along with that particular folder directory. But yeah, both ways work. We just have one file, so we don't have to worry. Sample size, I don't want to give. Then you can provide some exclusions here as well, that I don't want to go through JSON file or JPEG or anything. You can provide a wildcard here for that, but we don't need that again. Then it's going to ask you whether you want to add another data store. But obviously for this example, I don't want to add another data store. So I'll just click on next. Then it requires an IAM role to do this. So for an example, in this case, it needs to access S3 and your bucket. So it needs that role. So I'll keep it simple. I have a role already created, but we can just create a new role as well. So I'll again call it Big Data Crawler. Then it is going to ask you about the frequency. It's fairly simple. The whether you want to run it on demand, hourly basis, daily, or you want to choose particular days, weekly, monthly, and those options are there. But I'll choose the run on demand option. Then now we'll be adding a database for our data catalog, and I'll call this Google Trends. Okay, resource other options are not required. And if you want, we can put a prefix here as well. But again, I don't want that, just to keep it fairly simple. So I'm going to skip that, and I'll just click on next, and then I'll click on finish. So as you can see, it's already ready. And as it was created to run on demand, should we run it now? So I'm going to run the scroller. So it's running. As it is using Spark, it kind of takes a little more time for the smaller jobs instead of having more data. It kind of prefers more data. Okay, so it's stopping now. It ran, and we should ideally be seeing some tables over here. So as you can see, I have the table here. Uh, so, and remember, this table, it only contains the metadata of your CSV schema. The actual data is still in the CSV file. It's not in this table. All we are doing is creating a data catalog. So next thing that I'm going to do, is that clear? So this table, it does not contain any data of related to whatever was there in your CSV file. It just contains the metadata. So as you can see, it ran through my CSV file and it was able to find all these columns called month, PHO, ramen, soba, all of these files, their data types as well. If there are any partitions key, but currently obviously it's a CSV file, it does not have any partition key, and all of the metadata here. So what is the average record size, compression, if there is any compression over there, and are the columns ordered and things like that. So basic metadata about that, whatever file you're going through. And it's a fairly small file. As you can see, it just has 190 records. So the next thing, I'm going to create a job to finally do that the file conversion that I talked about from CSV to JSON. So for that, we go to this section called ETL under that jobs, and just click on add job, and we'll give this job a name. I'll call it demo, no, file conversion. And we'll select the IAM role that we created earlier. So that was called Big Data Crawler, if I'm not wrong. And we'll run a Spark job. Apart from that, you have few other options as well, like Spark Streaming, Python Shell, but I prefer Spark, so I'll keep that selected. And it gives you a lot of versions to choose from, but I'll stick to the basic, whatever it was given by default. So after this, what will happen, we'll run a Spark job and Glue will create the script for us. And I want to change the S3 path where the script is stored, just to make it easy. And I'll pick my, I'll just pick this bucket itself. Or I can just leave it be as well. No issues over there. Anything else that I should tell? All of these things, they are kind of important for your solutions architect certification, but not for this. They are a little more advanced feature for Glue. But right now for this certification, we don't need to discuss what is job bookmark, but it is a really nice thing. Kind of helps you save money. And this again, you don't need to understand, but choosing correct worker type again helps you speed up your jobs. It helps you save money as well. Choosing number of workers, it is crucial if you are doing this ETL as for your, let's say, job itself. But for this certification, all of these things are not required. But yeah, you can definitely see their documentation, or you can just run few jobs on your own by changing various permutation and combination of this worker type and number of worker, just to see what is the change in terms of duration for which your job ran, what was the change in terms of how much you incurred for that particular job. It's really interesting to know it on your own, but for that you have to play around with this. There's no just way of just feeding you this information that this particular one is correct or number of workers should be 20 every time. It depends on what kind of use case you're dealing with, size of your data, and a lot of other parameters. But again, as I mentioned, for this certification, this thing you don't need to worry about. Similarly with your job bookmark as well. But yeah, if you're interested, you can just see the documentation. Fairly easy thing. You just need to do it few times and you'll understand this. So I'll just click on next. Is something missing? Why it's not going ahead? For some reason, it took a lot of time. So we want to create tables in our data target, which is S3 in this case, and we are converting to JSON format. So I'll choose my target path, which is going to be just my S3 bucket. So in this case, it's asking choose a transformation type. So we are just changing little schema. So I'll keep that one itself. Then there is something called find matching records. So what it does, it uses machine learning in order to find if there are matching records in your source data. But again, right now it's not required. So I'll be choosing create tables in your data target, Amazon S3 format. As you can see, I want to convert it to JSON. So I'll choose JSON. Then compression type. This is again nice if you want to save some money, save some space over there in your S3 bucket. You can keep it compressed. Your Glue supports the converted formats as well, but I'll not choose it because it's a very small file anyway. Then I just have to provide the target path, and it's a very nice thing that they provide this nice little icon over here, which gives me all the S3 buckets I have. Instead of copying and pasting the path, I can just choose it from here. For some reason, there is some lag. I click on next, but it takes time. Oh, today I'm in Mumbai data center. That what is happening? Why it's not going ahead? Okay, let's try again. Okay, let me retry. Add a job, file conversion. Okay, actually, I'll just copy. For some reason, it was not able to take it from that icon thing, and I just gave the path and it worked. Strange. Probably some bug which can be reported. So as you can see, it is asking you whatever output schema you want. So you can add columns, you can change the data type if you want, and change the name of the column, month, something like that. So basic transformation like this as well, you can do it on the fly itself. So all I'm doing here is I'll just click on save job and edit the script. So ideally it should give me the script that it is going to run. So this is the script currently what they have given me. Uh, and other things, you can use this transform option. And these are the things that they allow currently. So you can apply some sort of mapping, you can drop fields, you can drop null fields. You have this filter option. Then you have this find matches option, the option that I mentioned earlier, that using machine learning, they see if you have duplicate data or exactly similar data. So probably to figure that out and delete it or anything that you want to do. Then it supports joins, maps to collection, relationalize, and renaming of fields as well. So let's add this. So currently it will give you this kind of thing that whatever you want to name it, then rename field dot apply, change, give the old name, new name, and something like this. So basic transformation option they provide here. But yeah, anything, whatever is important for your use case, you have to write it by yourself. By running the jobs option that I was showing so far, I'll show again. Just give me a second. So we went to this section jobs, we created a job. Once you are done till this section, you click next and finish, and you come to this page. So you can check those transformation by yourself. You have this documentation field available, or the documentation page available, or it's fairly descriptive by the name itself. So you can keep on playing around with all the transformations that they have provided. uh, for sure it covers all possible basic stuff, but yeah, customization, obviously there is scope for that. So in this case, we are not going to make any changes over here. We'll just save this job and we'll click on edit script. So save, and then we'll run this job. And again, few advanced functionalities, but we don't need it right now. Okay, it's gonna take a while, so there's nothing to do. Let's just wait. Okay, let's quickly check if it actually did run. So we can go to S3. Oh, no, this is my another bucket. Yep, it did run. Script path was this. I know temporary. What was my target? Connection path S3. My what incorrect name I have given here? My okay, my SA batch demo. Oh, this is my solution architect batch. The job run failed, blah blah blah. What is the problem here? Syntax error.
what I did wrong. Let me try again. Choose an IAM role with data crawler. What was that error? The bucket is in this region, US East 1. Please use this region to reach. Okay. Got it, got it, got it. Sorry, bear with me. I was in different region and my bucket is in another region. Why it's not coming here then? There is the table. No tables found. Ah, now it is coming. Create tables in your target, JSON. This time I'll choose a different bucket. Something is seriously wrong. It should not take this long for sure. My internet has some issues or what? Can you guys hear me and see the screen properly? File convert, blah, 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 blah. Action. Okay, run status. Okay, it ran, it was successful, so there should be a file. Let's check. It ran for then why it was still loading? It just ran for 1 minute. No, 38 seconds.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Anyway, I'll check this. Let's not waste class time here. It's creating it in parts. Something is wrong. Anyway, I'll check this and I'll probably show you again tomorrow. But yeah, you got the idea like how the flow goes. So we start by running a crawler. Crawler goes through whatever data store you have. In this case, S3. It creates a metadata, and then your metadata looks in this kind of way. Here in this databases section, you have all the tables. So it will have this metadata of that, whatever tables you crawl through. So this is how it looks. After that, whatever ETL job you want to run, you go to jobs, create a job, add the job, and
then finally run that job. And if there is need of some sort of customization, you can do that. And ideally, unlike what happened just now, it should show you the output file as well. But I'll check on it. I have done the same thing in the last path itself. It was running perfectly fine. I don't know, something is missing today. But yeah, I'll check on it and I'll get back to you. So yeah, any other questions on Glue? Okay, cool, no issues. So yeah, whatever data sources you have. So for example, again, a flat file like a CSV file that we had in S3, that's your data sources. And then you have the staging area, wherever whatever script you have or whatever transformation it is doing in this area. And this warehouse is nothing but the Glue data catalog that we saw here. So this is termed as warehouse over there. Okay. Then whatever is done here, it will finally at then have your this data marts. So this data marts are again nothing but either it could be the final file that you saved in S3, or you have the option of keeping everything in this table itself. So actual data would be over there, but whatever metadata is here, you have the option of creating this different databases here. You can again a number of databases you can create, and then finally using those databases you can finally connect to some sort of BI tools. So yeah, again, kind of explanatory, but here we don't have any servers running all the time. So we are not paying for like 24/7 usage. We are just paying for whatever duration our jobs are running. So in my example, it ran for 38 seconds. So I was incurred cost only for those 38 seconds. So just like any other or lot of AWS services, it is kind of cost efficient that way because it is serverless. So you don't have an infrastructure up uh, uh, kept running for you and you're paying for that particular infrastructure. It's just making usage of whatever jobs you're running in that particular duration. Automates everything or it does everything for us, but yeah, it gives us a start. It gives us a basic script to start working with. It has a lot of transformations available. So again, at least 15 transformations are available, and they keep on adding to that list as well. But yeah, just to start off, I think it's a good enough thing to have at least all of these basic transformations in place, which is fairly easy. And then obviously, as per your need, you can customize it. So that's what it provides you. What else? Glue workflows. We have already discussed all these workflows. So one thing to remember is that you can have this AWS Lambda for event-driven applications as well. So instead of running it just like how I did it manually, that I went ahead and clicked on run job, you can have it a event-driven application as well. Something coming in your S3 bucket, and immediately you want to take some sort of action or a ETL process on that. So you have those event-driven approaches as well. And finally, hands-on, we have already done that. So let me check if they were mentioning something else here. Download the data set, upload the file to an S3 bucket, open the Glue services, add tables using a crawler, enter name, select data store, specify the path of CSV file, mention IAM role, run the crawler. We did the same thing. Wait for it to finish, upload the file to S3, check the output. This didn't happen for us, but I'll check that. Go to jobs and click and add a job. Oh yeah, this happened, not this. Go to jobs and click on add job. Use the following settings. IAM role that was created earlier. Select the data source, blah, 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 blah. Select change schema. That's what we did as well. Save the job, edit the script, and run the job. So what we are doing next is we are creating a data set for our Redshift cluster so that I can show you all the demo that I want to show you here. So yeah, obviously it will incur some charges in your personal account. So please, if you are worried about that, don't do that. But yeah, I'll do it in front of you itself. Probably I could have skipped this as well because I just want to show you the demo. Generating a data set is not part of it, but as we have 9 minutes, I think I can show that as well. So for that, I need a little bigger instance. So I think a little memory intensive instance would be good. So I'll choose m4.xlarge. So we'll be connecting to a website that provides this dummy data set, and we'll download that data set as per our need. So yeah, what are we doing here? We are downloading a data set from a website called TPCH. I was confused with the name. So you can Google it as well. So as you can see what they do, TPCH, it's a benchmark. It's a decision support benchmark, and it consists of a suite of business-oriented ad hoc queries and concurrent data modifications. The queries and the data populating the database, they have been chosen to have a broad industry-wide relevance. So this TPCH benchmark is popular for comparing database vendors. And in this course, we'll just use it to get hands-on with our Redshift cluster. After we are done generating the data, we'll just terminate the instance, obviously to save some cost, because to generate around 40 gigabytes of data, it's going to cost me some amount. But yeah, so let's jump to the console. And where is my console? I'll probably choose not m4.large, I'll choose m5.large. It is giving me how much? Up to 10 gigabytes. I need more than that. Everything else is fine. Adding storage. So as you can see, it's just giving me 8 gigabytes. I need 100 gigabytes at least. Not it. I just need 50, but for safe side, I'm choosing 100. I'll give it a name. I like to keep a lot of tags. Data generator. Configure security group. So I probably should have a security group already, but okay, I'll just stick to the default one itself. What do I have here? Huh, this one works for me. Everything is open over here. Key pair, choose an existing key pair. Let me check if I have this key pair or not. SA. Nope, I think I deleted it after my solutions architect batch. So I'll create a new one. Big data. Data generator. Okay, so it's already in running state very quickly. That's nice. I'm too lazy to type, so I'm waiting for it to give me this option. Come on, man. It's taking a while. Huh. Unnecessarily, I was waiting over there. Okay, so I just wanted to copy this, but first I need to copy this as well. So I'll open my terminal. I'll make it a little big for you guys. Should be fine. Okay, this is done. Then I want this. Okay, so I am in my EC2 instance. So let's quickly go ahead and do the very basic thing that everybody does. Sudo yum install make kit. And the installation is complete. And I'll just clear my screen. Next, what we have to do is we have to type git clone, then https github.com/gretpch.kit. So if you are interested in following me along now or later after seeing this recording, so I'll just pause here for a few seconds so you can catch up and type this in your screen as well. After that, I'll hit enter. Okay, and the GitHub repository has been cloned. Next, you have to type cd that particular directory, dbgen, Okay, and then I'll install one additional tool, which is sudo yum install gcc library. Okay, that is done too. Let me clear the screen. Then I'll type make os equals to Linux and hit enter. Okay, and now our tool set has been compiled. And next, let's navigate back to the home directory. And I'll be creating a directory called EMR data. I'm creating EMR data as well along with Redshift data. So this is where the data for my EMR lab will go if we are having any. And let's also set an environment variable so that we can run the TPCH tool set, and the data will be automatically end up in this EMR directory and I don't have to manually do it. So let's type export DSS path equals to, again, if you don't understand anything, it's not required at all. We are just generating data, a simulated data to work with. And now let's go back to the dbgen directory, tpch dbgen. Okay, we are there. All I have to do is type full stop slash forward slash dbgen v hyphen t, the letter o hyphen s, and then 10. And so basically, again, if you're interested to know what we are doing here, so we are saying here run dbgen in verbose mode. T specifies a table, and we are using the letter O for the two tables that we will create, the orders table and the line table. Again, you'll understand later when you'll see that. And then this hyphen S, it's for a data size. So for my EMR data cluster, I just need 10 gigabytes of data. So I'm just mentioning this as 10 over here. So yeah, as you can see, TPCH population generator, it has started the process, but it's going to take a while. It takes some amount of time to generate this. So we can
So
hyphen was missing with the verbose. So as you can see, it has started generating the data, and yep, it is going to take time. And yeah, somebody was saying something. This particular they have created a Git page for them. So all these steps and everything I've copied from over there itself.
oh,
So they have mentioned the process as well. It's just that their process is little complicated. So few commands here are my own. So I find it little easier this way. But yeah, you can definitely check this. I'll show you. TPCH. So as you can see, they have a lot of benchmarking results for transformation processing to TPCC, TPCE. What we are doing is we are just downloading one of their version, which is called TPCH. So that has some industry related data in terms of order table and line table, and basically information about users and whatever orders they have done. But yeah, I have not explored all of them. So what is, like, for an example, TPCC, TPCE, I'm just aware about TPCH and TPCG, that's all. But yeah, you can check it on your own. Okay, so yeah, do the rest of the process. So I want this data to reside in my S3 bucket. So what I'll do is I'll create an S3 bucket. I actually have done it, but I didn't do it properly, so I'll do it again. And I want to show you as well. So this is the bucket that I created earlier. I'll delete all this. Okay, that was successful. Okay, this as well. So as you can see, I've created one bucket called Big Data Specialty Lab Solhurst. And then I'm going to create two folder. One will be called EMR data. And similarly, another one would be called Redshift data. And what we are going to do, we have data in our, it's almost about to be finished. The one which we ran, it is already finished. As you can see, it gave me this done thing here. And so currently that one is running. And for this to happen, for me to send data from my EC2 instance to S3, I need permission. And for that, I already have created a IAM role. You can create one for yourself as well. So currently what I'm going to do is I'll just attach that role to this instance. So I have to go in security, modify IAM role, and I just have to choose the role called S3 admin. Or I can choose this one as well, Big Data Specialty Admin. What it does, it just allows my EC2 instance to talk to S3 buckets. So I have given S3 full access policy to EC2 role. So using this role, I can securely now download, upload things to my S3 bucket. Come on, be finished now. Okay, it's gonna take whatever it's gonna take. So till then, we can actually start discussing Redshift, and we'll come back to this section again, because I think it's gonna take again 5 minutes at least. So till then, we can just start discussing about Redshift. So yeah, we'll start with my favorite question. What do you know about Redshift? So yeah, it is
And
Amazon's fast and fully managed petabyte scale
yeah,
data warehouse service in the cloud. So that petabyte scale is a keyword over here. So in this section or in this particular module, what we are going to cover is we are going to learn about what Redshift is, common use cases of Redshift, and why someone may want to learn Redshift in the first place. So while it is fast and fully managed and known for very good performance, you will have to play a part in making it perform. And that's what we are going to learn. And I find this particular section of this course little helpful because just knowing Redshift, I've seen people transition in and managing Redshift cluster and kind of using it for a career switch as well. So if people are interested in this stuff, I've seen a lot of people just after classes and just after knowing or researching a little bit more about Redshift and management of data warehouses on their own, they have transitioned or switched to a new career altogether. And it's a fairly, I currently, honestly, I don't like it that much, but yeah, it's kind of interesting actually how to, I used to get a lot of queries from our AWS partners that this is the table that we have created. When we created it was like 40 gigabytes of data, and now we have scaled to a very large extent, petabytes and all. So in that case, we are incurring this much. We want your help in managing Redshift. And then you check the history, how the table was created, what are the components that they are using. And by correctly tuning those parameters, whatever Redshift allows, even though it's a fully managed service, there are a lot of tunable parameters over here which increases the performance of the queries. It increases, I mean, it decreases the cost. A lot of things can be done. And some people find it very fascinating that just by knowing that much in depth, they are able to save like too much dollars for their company. So it's a very nice skill to learn, I feel. But yeah, it comes with like playing around with it. So okay, thank you for that. There's nothing much to explain over there, so I'll just skip to the next slide. So anyway, for this particular section, my goal would be to provide you with the knowledge you will need to make sure your implementation of Redshift performs well, not just it gets created and you are able to run basic queries. My focus would be on how you can make it perform little well by learning all the things like how distribution keys work, how you can use those compression to make it perform a little better, save some storage, save some cost, and things like that. So I'll start from the basics again. So please bear with me if you are already aware about all this information. So Redshift was announced in November 2012, about 10 years from ago from now, and it is one of the AWS's fastest growing services. And I have the good fortune of working very closely with the team. So Redshift is designed for OLAP and business intelligence applications. Please do not use Redshift for OLTP applications. There are different alternatives for you, but use Redshift only for OLAP, not for OLTP. I'll repeat that warning again. Please do not use Redshift for OLTP applications. It's not meant for that. And there'll be a few sections in this particular section where I'll be explaining why it is not a good idea as well. And it is ANSI SQL compatible. So if you have SQL experience, you'll be able to use that experience when you use Redshift. It is also column oriented. Let me go to my doodling. Redshift. So first point was it is petabyte scale warehouse. Then it is column oriented. It's meant for OLAP and not OLTP applications. And obviously it supports ANSI SQL. And I have a whole section planned for this particular section or the module regarding columnar databases. And you'll learn the advantages and the disadvantages of columnar databases if you're not already aware over there. So why learn Redshift? We'll start from the basic question itself. So we can provision a multi-terabyte cluster within just few minutes at a lower cost than how usually would end up paying for a data warehouse. So that's one big reason why somebody might want to learn Redshift. Then once those clusters are up and running, storing and managing large amounts of data is far easier in Redshift. We are generating a significant amount of data from applications, devices, and various other forms. And that data will always need to be stored and managed. And we can create powerful solutions by using Redshift along with other AWS services as well. And again, I'll be talking about design patterns in relation to other AWS web services a little later. So let's start with Redshift's architecture. And before that, let me check if my data is finished. Nope. So I'll again do my doodling. So Redshift architecture looks like this. You have your uh, leader node in center. Actually, I'll first draw and then I'll explain. I'm just writing for one, but all three are your compute nodes. And once I'm done, please take a screenshot if you want. It is your inside some AZ availability zone. And then you connect to your leader node with some sort of SQL client or a business intelligence tool. Anyway, so this is how Redshift cluster looks like. Obviously not this bad, but yeah. So we are going to discuss the Redshift architecture, and we are going to look at the components that make up a Redshift cluster, the various node types that are available, and we'll also look at pricing as well, just to give you some sort of idea. And yeah, so I hope you like this awesome diagram created with so much difficulty. So Redshift data warehouse consists of EC2 compute nodes, which are tightly coupled together in order to create a Redshift cluster. So again, at the backend, they are using EC2 to give you this managed service. Redshift cluster is a single availability zone concept. There are quite a few reasons for this, but before telling you all those reasons, I want you to guess why this is single AZ concept and not multi AZ. So yeah, so for performance reasons, obviously the leader node and the compute nodes, they need to be in close proximity and they require a high speed network connection. So while latency between your AZ, as you know, is generally not an issue. However, a Redshift cluster, just like your EMR cluster, it requires all the nodes to be present in very close space, and that's why it requires because it requires high speed network communication. And again, I'll cover more on this in the table design section of this course. But yeah, majorly for performance optimization, this is the case of single AZ architecture. Uh, Apart from that, a Redshift cluster has high availability and durability anyway built into it, even though it's a single easy concept. And we'll again cover that in another section of this particular Redshift course, overall Redshift course. Apart from that, let me think if I'm missing out on something. So yeah, what are the use cases of Redshift? Obviously, as a data store, then any analytics data store or business intelligence applications. Most of the time, they are used by business users during their business hours. So this use cases don't usually anyway require the type of architecture that you might want to need in case of an e-commerce website which needs to be up and available all the time. So Redshift is not used that way. That's why, again, apart from the technical reason of performance optimization, because of all those use cases that it offers, it's not it's not required to be a multi-easy concept in the first place itself. So yeah, that's another reason, which is non-technical reason, I would say. So let's start stepping through the architecture. So every cluster is obviously going to have a leader node. The leader node facilitates the communication between the SQL clients and the BI tools to the compute nodes that are in this cluster. So kind of like your EMR as well. In EMR as well, we have this master node, secondary node. So kind of similar architecture, little similar. I wouldn't say exactly similar. Then each leader is going to have a SQL endpoint. And once we are creating a Redshift cluster, then I'll show you how this endpoint looks like. But some of you may already be familiar with RDS. And if you are, RDS has an endpoint. The Redshift endpoint is similar to the RDS endpoint. Uh, so yeah, let's step out of some of the slide thing over here, and we'll actually check the console. But actually not, because I have to unnecessarily create Redshift cluster 2 times, so I don't want to pay it 2 times. I'll show you everything when I'm done with the theory and I'm showing you the entire Redshift lab for which we are downloading that data. That works, right? Or you want to see it now? So yeah, we'll see how to launch the cluster and we'll have a visual inspection of our endpoint a little later. But yeah, if you are aware about RDS, it's exactly like that in terms of how it looks. Apart from that, so your leader node, apart from connecting to your business intelligence tools or the SQL client, what it does, it coordinates parallel query execution, and which is one of the important thing about Redshift, that it allows you to run this parallel query. But again, I'll cover about this parallel query execution in later section, which is related to this, because I have to give you some stats regarding it as well, how many connection it allows, how many concurrent connection it allows, and things like that. So I'm not covering all those things here. I'm just focusing on architecture now, but I'll be covering that little later. So yeah, when a SQL client sends a query to this leader node, I'll open my highlighter. So this SQL client, it is sending some sort of query to your leader node. Your SQL query is passed. The leader node develops an execution plan. I'll write it EP. So as per the query it is receiving, it develops this execution plan. And based on that plan, the leader node compiles C++ code. Again, that is an optional information. You don't need to remember this. What it does, it creates a C++ code, or it compiles a C++ code, and then it distributes that code to this particular different compute nodes. Is the flow clear? SQL client, leader node, execution plan, C++ code, distribution of that code to different compute nodes.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.
Okay. So yeah, I was saying that based on this plan, your leader node, it compiles your C++ code. It then distributes that code to your other compute nodes, and the compute nodes will then execute the query, whatever query was passed on from the SQL client, and then the data will be returned to the leader node again. So it will come from here, here, finally, and it will aggregate that data, and whatever final output or the result will be displayed in your SQL client itself. So that's how your Redshift architecture looks like. Apart from that, your leader node, it also stores metadata. Where is my doodling thing? So yeah, if you want, oh, I was already there. So I don't know if you can understand anything from this diagram, but if you think it's going to be helpful for your revision, please take a screenshot. So yeah, I was mentioning that your leader node, it also stores metadata. So this metadata comes from your compute nodes. Each compute node has some sort of files on them that are sent back to the leader node. That information is then stored in the system tables. And if you have done DBA work before, uh, or you are currently a DB or something like that, then you're probably familiar with system tables as well. So that's one example of metadata stored on your leader node. Where is that example? Let me check. So this is a simple use case on Redshift can be used. Input all data is stored in S3, Redshift, elastic resize, concurrent scaling. Output, pretty simple. They had a better diagram. So obviously you don't need my screenshot. So SQL client, database connection, leader node. It is having this compute nodes, then compute nodes having different slices. We'll talk about slices as well, but little later. So let's quickly read it. So client applications, Amazon Redshift integrates with various data loading and ETL tools and business intelligence reporting, data mining, and analytics tool. That's what we saw in the last slide, that all these client applications, it could be a SQL client or it could be a business intelligence tool. Then Redshift is based on PostgreSQL, and this makes it easy to connect Redshift to most SQL clients. So either using JDBC or ODBC drivers, you can connect to Redshift just like how you can do it with PostgreSQL. Then the entire core infrastructure component of Redshift is your cluster. So cluster is composed of either one or more than one compute nodes. Then if a cluster is provisioned with two or more compute nodes, an additional leader node coordinates the compute nodes and handles external communication. So what it means is your leader node, it keeps on increasing if your entire cluster is getting bigger and bigger. So for an example, you have 3 compute nodes. For that, you will have 1 leader node. If you have 6, then you will have 2 leader nodes, and so on and so forth. Then what leader node does, I told you that leader node manages communications with your client programs, SQL clients, and it also manages communication with your compute nodes. It sends this execution plan and things like that. So it passes and develops this execution plan to carry out database operations. In particular, the series of steps necessary to obtain result for complex queries. Basically, a simpler plan for your compute nodes to execute, in simpler words. And then compute nodes, what are they doing? As per the slide, the leader nodes compiles code for individual elements of the execution plan and assign the code to individual compute nodes. The compute nodes executes the compiled code and send intermediate results back to the leader node for final aggregation. Each compute node has its own dedicated CPU memory attached. Obviously, it's easy to instance in itself, a compute node. So that's what they are saying as well, that it got the C++ code, the compiled C++ code. As per that, it executed the query. Whatever result it got, it sent it back to the leader node. Leader node finally then aggregates the results coming in from different compute nodes. Then finally, node slices. And yeah, this obviously, as you can see, each compute node's having its own dedicated CPU, memory, and local storage. It allows you to scale your compute nodes up, down, out, in, whatever. It allows you to basically scale. That will really depend on how much data you are having. And I'll talk about resizing cluster as well. It's pretty easy to resize Redshift clusters. Depending on the type of data we have, we can obviously resize the cluster as per a need. Then apart from that, backup of your compute nodes to S3 is done in parallel as well. And yep, coming to slices. Now your each compute nodes, as you saw in this diagram, as you can see, each compute node has its own slices. Now slices, they are a portion of your memory and disk. Your data is actually loaded to the slices in parallel. So when we get to the loading data section, I'll highlight why exactly slices are important and how it is important to load data in parallel for performance reasons. So now slices, they process a portion of your query assigned to the node. So when I talked about each compute node processing the queries, that work is really happening within the slices. So the slices work in parallel to complete the operation. So it's not like one entire bad job is coming and your entire compute node is doing that job. Whatever job it is doing, again, it is slicing it up, giving it to this node slices, and those node slices, they work in parallel to again expedite the query results. And that's how it works. The number of slices, it depends on the type of node that you have chosen. So there are different types as well, and when we are creating cluster, I'll show you those types. So it's just like your EC2 instance, like M4 versus T4 versus C class and things like that. Here also we have option of choosing different compute nodes. So we choose those nodes, and as per those nodes we get the slices. And obviously, as you can see, more slices means more parallel operation. More parallel operation means less amount of time to run a particular query. And so designing your tables properly in order to use these slices, it allows you to achieve optimal performance. And we'll talk a little more about it later, but for now I think it should be clear. If not, please let me know. So yeah, after this, your Redshift cluster, it runs on a 10 gigabyte Ethernet mesh network in order to maximum throughput between the nodes. So let's quickly take a look at the kind of nodes we have available. So where is Safari? Redshift nodes, node types. So no, this is a blog. I want their documentation. Overview of RE3 nodes, cluster, blah, 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 blah. Yep, this is the page. But before that, let me check if my data is ready. So yeah, my data is ready. So uh, are there any questions related to Redshift architecture in terms of whatever we have covered so far? If yes, please ask now, because I am going to resume this work related to my data, this data set creation, because I am again paying by the hour, so I want to complete it as soon as possible. Questions, questions, questions. Okay, I think no questions. So in this case, as we can see, this done represents that our data has been generated. And let's quickly go ahead and check our data as well. So for that, let's go to home directory, and then my data should be in EMR data. I'll do LSL. Why? It's not showing any data. Why? This one has data. EMR data. For some reason, EMR data was not copied. Probably some problem in one of my Unix command. But that's fine. We got the bigger data, which is like Redshift data, 40 gigabytes. So that works for me. I am anyway. We are done with EMR anyway. So cool, no issues. So yeah, as you can see, our data files, they are generated, and we'll execute this AWS CLI. So for that, we'll be creating a bucket, and after creating the bucket, we'll copy the data through that particular bucket. And for that, if you're aware, this is the command to create a bucket: AWS S3 API, quite literally create bucket, then bucket, and then you provide a bucket name. So I'll call it my big data specialty batch 2022. Damn. Sorry, my bad. I forgot to provide region. So region, I want it in US East 1. I am using it incorrectly or what? I forgot. Any idea what mistake I'm making? AWS the label must be blah, 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 blah. AWS S3 API, create bucket. Oh, sorry.
I think bucket should be double hyphen
Yep,
bucket.
yep. Silly mistake. Huh. Now everything looks fine. Region would be US East 1. So yeah, this particular message means my bucket has been created with this name. So let's copy this files that we have created to this bucket. And for that, I just need to type S3, sorry, AWS S3 CP. It's in my home directory in Redshift data. Actually, instead of doing this, what I'll do is I'll go ahead and split this files, and splitting the file, it allows you to load the data faster, and it is kind of a Redshift best practice that they recommend as well. And it will be a good for you to know this as well, that instead of just copying or uploading data directly from S3 from one file, how we can do it using a split file, because anyway that's a general recommended practice. So it will be a good thing for you to see as well. So before we split this files, let's find out how many lines are there in this particular file. So as you can see, I have two files, orders.tbl, lineitem.tbl. So I'll type wc for word count l orders.table. Oh, sorry. It's obviously a big file, so it is taking time. It's 40 gigabytes. I was just too lazy to go there and do all those clicks, so I just did it from here. But you can definitely do it from there. Okay, this is taking too long, but I know how many lines it has. So I'll just tell you I'm stopping this command. Oh, it showed. So as you can see, it took a little while to show this result, but this particular file orders.tbl, it has 60 million lines. So let's go ahead and split this file into 4. You could do it as per your choice, 4, 5, 7, but whatever. As it is 60 million, I just want to do it in 4 so that I have equal 15 million parts. So for that, I'll type split -d -l, then I'll type 1, 5, 1, 1, 2, 3, 4, 5, 6. Correct zeros, right? Huh. So yeah, now the file is being split into 4 different parts. Again, that's gonna take some few seconds at least, around 30 to 40 seconds. So let's wait for it to happen. That's why. This kind of things I don't like it in live sessions. It kind of interrupts the flow. Come on, man. 15 million, 15 million. I just wanted to show you a little bigger data set. That's why I created this 40 gigabytes. Otherwise, a demo would have been a little faster, smaller data set. Because otherwise, what happens, even for Redshift per se, this 40 gigabytes is too small as well, because I want to show you few queries and what happens after I make changes to some sort of your table design. So what happens is sometimes a a table created with like parameters A, it takes around like 10 seconds to show you the results. Another one with parameters B, it shows you 19 seconds. So I wanted to show you that difference. That's why we are doing this much. But again, 40 gigabytes is again not a very good, um not enough data for you to show this comparison, because sometimes what happens is in 40 gigabytes of data, you probably will I've made some changes. I've made changes to the table design, and instead of 10 seconds, now it is taking 12 seconds. And I expected it to be lesser than that. It happens because um, it was not meant for, that is not efficient on a 40 gigabytes of table. Probably with the same settings, if you are increasing the size of your data is getting increased, and let's say it is like 1 petabyte now. In that case, that particular query is going to take little lesser time with the parameters B. So yeah, I want to show that comparison, but we'll come to that section and we'll see if that is happening or not. Ideally, it won't, as per what I feel. 40 gigabytes is also not enough, but I don't want to spend more than that because 40 gigabytes as well is too much. Come on, it's taking too long again. Okay, let's do multitask then. Anyway, I'll go back to the slides. So what do we have here? I told you slices, they work in parallel. It works on a 10 gigabytes of Ethernet mesh network, which gives it the speed and the how the query execution plans happen, how the data is being sent to the leader node and things like that. So that's what is being shown here in this diagram. Uh, yeah, what I was showing next is the kind of nodes we have here. So this is their pricing page. Pricing. Where is the pricing? Anyway, I'm not able to find, but I'll just show you the kind of nodes we have. So as you can see, we have dense compute node types. So this nodes, as the name suggests, they are ideal for high performance databases. So if you need fast CPUs, if you need a lot of RAM and you want SSD drives, in that case, you have to go for dense compute nodes. Uh, Apart from this, you have dense storage nodes, and these are ideal for large data warehouses because they come at a lower price point than your dense compute node types. Because again, this are using SSD drives, this are using HDD drives. HDD drives, as you are aware, are cheaper than your SDD drives. So, but yeah, obviously there is trade-off that you need to think about. So for an example, uh, you could technically run large data warehouses on the dense compute node as well, for sure. But in that case, you will need many nodes, especially because the storage on the dense compute node is lesser than the storage which is available on your dense storage nodes, of course. So that will come at a much higher price point for you and something that you need to think about as well. There are previous generation compute nodes as well, which are fine to use, but from a price to compute resources ratio, it may not be worth it. So this previous node types, I don't think anybody uses this because it's slightly lesser than what this compute nodes and storage nodes are, and they have huge difference in terms of performance. So mostly people don't use it, or at least I have not seen people using it nowadays, at least for last 4 to 5 years. But yeah, before that, obviously they were the only alternative. Uh, if there was pricing page, I was able to pricing shows you a great difference, why you need to think about that trade-off. Anyway, you can find that pricing page on your own. And lastly, you have this RA3 nodes. And RA3 nodes, they are the uh, proprietary Redshift created nodes. So what they have done is they have taken advantages of both the node type, the storage node types and compute node types, and they have given you a good balance of both. But obviously, this comes costlier uh, at a costlier price than even your compute nodes. So they are probably the best in terms of performance. They have best of both worlds, if you want to say. So they can store a lot of data. They are good for compute. They provide you a lot of RAM and everything as well. But the only thing is that you have to think about the prices because they are the most costliest one. Uh, So apart from that, obviously this course assumes that you have some sort of AWS experience or you have cleared some other certification like solutions architect or something. So I'm assuming that you're already familiar with reserved instance pricing. So I'm not going to go over in detail in what reserved instances are, but you should know that you can have reserved instances pricing for Redshift as well. So obviously reserved instance pricing that helps you reduce your cost if you're planning to have this data warehouse up and running for 3 years, 5 years, and things like that. So in that case, it helps you lower down your prices. And there should be some table in terms of in pricing page that will show you the effective differences between these nodes. And as per that, you can make your decision, which will be good for you. Okay, let's see what do we have next. And this split is still not done. So Redshift related concepts. First thing is massively parallel processing. They call it MPP. So MPP, what it does, it enables fast execution of even complex queries running on this petabyte scale of data as well. So basically the execution plan, how that C++ code is compiled and sent and things like that, and usage of slices. So that's what allows you this massively parallel processing database. So your data, it is being stored on multiple nodes. All of them have their own dedicated CPU, memory, and local storage. and they kind of obviously work in parallel in conjunction kind of way. So that's what that allows you to call it a massively parallel processing database. Apart from that, columnar storage. So columnar storage, if you are aware, it helps you optimize your query performance, because obviously instead of saving data in terms of rows, it saves that data in this columnar format. And sometimes whenever you want to query or have complex queries, it helps in terms of speed. We have is workload management. So actually I'll talk about it later, workload management, but we can see at least the high level description of what workload management is. So this workload management, or WLM, what it does, it enables users to flexibly manage priorities within workloads. So what it means is that, let's say you have 10 people running in queries. One person ran query which is little complex and it's going to take few hours to complete, let's say, again, made up figures. So let's say one query is very big, it's going to take hours, and there are 10 other queries which are going to be finished in 5 minutes or even 2 minutes, something like that. So we don't want this long running query to take up space and not allow this short duration queries to run. So this WLM, or workload I keep on forgetting the name, workload management. So what it does, it allows you to decide, okay, if I have this many queries, short running queries, what do I want to do with them? Do I give them preference, or do I allow them to wait for your longer duration query to finish? What kind of percentage of traffic I want to allow for shorter queries, for longer queries, and things like that. So again, I'll show you this in the demo itself, but I hope it is clear what it is doing. If not, please ask your question. Questions, guys? It is, and I'll show you a demo of that as well, but I'll just give you a brief how it works. So you create groups for that. So you call one group long running queries, you call another group short running queries. And if you are aware about RDS or even Redshift, so there is a thing called parameter group. In that parameter group, it allows you to configure things like this. So in that, using that parameter group, what you can do is you can uh, give, let's say, 70% of preference. Whatever queries are coming in, 70% preference should go to the queries which are shorter running queries, and only 30% preference should go to longer running queries. There is a way of doing that, and I'll show you. So this can be achieved using this WLM. Currently you just need to understand what this workload management is doing, because definitely I've seen one or two questions at least for this particular topic itself. Does that answer your question for now? uh okay, so I think we are good for today in terms of theory. I don't want to bombard with you a lot of advanced topic related to Redshift. I just want to finish this data set thing today. uh it's not split yet. I should have taken little smaller data. 60 million is too much. Let's quickly walk through the slides, whatever we have, so it will give me an idea as well. I usually don't go by the slides. Next thing is designing tables, a database, blah, 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 blah. Yep, we'll see all this. But yeah, it's 17 minutes is not enough to cover this. I'm gonna cover this in little detail. Cool, I'll talk about this tomorrow itself. And then we'll be creating a Redshift cluster. That's fine. Then we'll be loading data. Okay, then we'll be using Redshift Query Editor. Cool. Querying the cluster, tuning query performance. I'll probably have little more information than this, but yeah. So this, firstly, they recommend, and then I was interested in checking how much difference is there. So in this kind of lab in one of my other batches, I tried that. Okay, I uploaded one file directly. You can try that as experiment as well. It will be interesting to know the difference. So upload one file directly, then split that file, and then load that file in Redshift. You'll definitely see that the files which were split, they took little lesser than what usual the single upload took. But again, if you don't want to go through this entire hassle of splitting the file, you can do the single upload as well. Okay, we can actually start with this section itself, which is showing in the slides. So, designing tables. So, table design is obviously very important in Redshift. How you design your tables will have an impact on the performance. So it is going to be a very crucial area to master for the big data specialty exam. And that's why I think 2 slides are not enough for this. So I'm going to cover the uh, relationship Redshift architecture and its relationship to the table design. So I'm also going to talk about how you should think differently. For an example, if you're used to designing tables in a typical row-based database engine, how you should think differently when you're designing tables for Redshift. And finally, I'll be talking about the data model that will be used in a lot of examples in this particular section that we are going to have on Redshift. And finally, I'm going to use this data set that we are generating here to show you a few examples. But then after that, we are going to cover how distribution style, sort keys, compression constant, column sizing, data types, how they impact the performance of your tables. So yeah, so it's not just enough to know how to implement a Redshift cluster. You should know how to implement it correctly, and you want to make sure it performs well as well. So before we begin this designing table section, uh, so as you would with any other data store or database engine, you need to know your data first and what your data relationships are. So if you're responsible for doing all the technical work only on a Redshift cluster, but you really don't have an understanding of your data, like in some cases, data engineering team is different and the software engineering team is different, and probably you just know that they'll give you data and you just have to use it. But yeah, just imagine in a case if you don't know what the data is, it's very tricky to design a good Redshift table design, because you should have an understanding of data to have a good Redshift table design. And if you're new to column oriented databases, then you should think differently when you're designing your tables. It will be different than when you're designing tables in your usual row oriented databases. And I'll try to cover that in this section as well. Uh, so I have so far talked about how your queries in Redshift, they are executed in parallel, and how data loading is done in parallel as well. I have not shown that to you, but yeah, your data loading, when you're loading data from S3 to Redshift, that is also done parallelly. So for an example, and that's why this split thing is happening here, because uh, whatever amount of time one file is going to take in order to get uploaded. So it's as simple as that. A file with 60 million records is going to take a lot of time, but a file with 15 million records is not going to consume that much time. And what you're doing, you're splitting that 60 million into 4 files of this 15 millions. As it is parallel, I will have, let's say, 4 slices, and again, made up scenario. So let's say you have 4 slices, they are capable of loading data parallelly, and that's why we are splitting this file into this 4 chunks. And all of these chunks, they'll be uploaded quickly parallelly together, and that's why this split operation helps. So yeah, I hope that is clear even more now, why we are splitting instead of uploading it directly. And so yeah, we also saw what your node slices are. And in this particular section, what we'll learn is how your table design and your Redshift architecture work together. So in a typical row-based engine, database engine, you're used to linking your tables and maintaining referential integrity with the use of primary keys, foreign keys, and things like that. In Redshift, while primary keys and foreign keys are available, they are only there for query planner and to drive performance. This is very crucial, so I'm going to write it down as well. I don't think it's written in your slides, so please make your own notes for things like this as well. So what I mentioned was, uh, unlike your traditional row-based database engines, in order to have this, what do you say, linking of tables and maintaining your referential integrity, there it is done using primary key and foreign keys. In Redshift, we do have primary keys and foreign keys. However, they are only there for your query planner and to drive performance. It's only for those purposes these are present. However, you need to know, while you can create this primary keys and foreign keys even in Redshift, your referential integrity, unlike your row-based databases engine, it is not maintained here. So I'll write that down as well. So in a typical row-based database engine, we are also used to creating indexes, right? in Redshift, what do we have is we have a concept of sort keys. They are a little bit different than your indexes, but but a similar concept basically. The whole idea behind table design in your Redshift is that try not to lift and shift your current data warehouse to Redshift. So for an example, if you're using currently Oracle for your data warehousing solution, try not to fit the same concepts that you're already used to into Redshift. You definitely have to run Redshift while following the best practices suggested by them. Follow this basic table design guidelines, other performance guidelines, and that will give you. I'll obviously give you all of that in this particular series, and after that, you will have highly performant data warehouse. Uh, I am going to be using the star schema data model in order to illustrate a lot of points. And why? Because obviously star schema is the simplest style of your data mart schema. And this is also most widely used as well in order to create your data warehouses and dimensional data marts. As it is widely used, as it is simple, I'm going to stick to that itself. So your star schema, it consists of one or more fact tables, and they are referencing any number of dimension tables. Obviously in the shape of a star it looks like that, so that's what star schema is if you're not aware. And if you would like to learn more about the star schema data model, just go through their Wikipedia page. I think that Wikipedia page is the most simplest and most thorough one in terms of that. Anyway, coming back to this, regarding data set, we are already working on it. So obviously I cannot provide the data set to you, otherwise I would have. But yeah, I have already shown you where you can get the data set, so you can test with small amounts of data, large amounts of data, whatever you want to work with. You can do that as well. I gave you the entire steps, whatever is there for that. Anyway, coming to the distribution style, I think that is the next thing here. Yep. So when you create a table in Redshift, you will choose from one of the three distribution styles that are available. First one, as you can see, is even, uh, key, or all. These are the three distribution styles that are possible. This is called key, even, and this one is called all. And understanding this distribution styles, it is very important for your examination. Why? Because, and not just for your examination, even for your Redshift cluster. So while Redshift is a managed service, you still need good table design in order to drive performance. Again, I am being redundant here. Why? Because it is very important thing to know that this is a managed service, but again, lot of heavy lifting is there for you to do as well as compared to other services which are managed. So for example, you don't do this much in other managed services that you have to do in Redshift. So yeah, that's why I'm being redundant again and again. So yeah, let's look at the even distribution style. Uh, Let me see if I have an example of even which is better than this. Actually, we'll start with this one itself. So in this case, how it goes is it goes in a round robin fashion, as you can see here. So regardless of whatever the values in the column, they are distributed across all these nodes. Where is my highlighter? Oh yeah. So this is your compute node 1. This is your compute node 2. I'll call them C and 1. I'll just call this 2. This will be your node slice 1, node slice 2, node slice 3, and node slice 4. And just think that I have a data which is like this. I'm just writing, think this is 1000, this is 1002, this is 1007, this is 1001. And here I have 1003, 6, 5, and 4. Again, I hope the idea is clear. Diagram obviously is not. So let's take a look. Let's take a closer look using this illustration that I've drawn for you. So for an example, I have this order ID here as a part of the table, and I've just left other columns for this example. So just to obviously make it a little simpler for this illustration. So as you can see, I have this order ID and I have two compute nodes, 1 and 2. I have 4 slices across my nodes. slice 1, 2, 3, and 4. And if you look at the data on the compute node 1, in this case, you can see that supplier ID 1000, 1002, they ended up on your node 1. And then your 1007 and 1001, they ended up on your node or slice number 2 on your first compute node. And in the second one, supplier ID 3 or the order ID 3 and 6, they are in slice 3. And similarly 5 and 4, they are on slice 4. And this is just an illustration of how it will go about if you'll choose the even distribution. So your data, it is going to be distributed across your slices regardless of the value in a particular column, and it's going to be done in a round robin fashion. So there is no order. As you can see, it's not going by 1000, 1001, 1002, 1003. It's not like that. It just goes in this round robin fashion. So that's how your even distribution style work.
Just a quick info, guys. Intellipaat has a cloud computing and DevOps job guarantee program. This program will give you an in-depth knowledge on how to build applications on the cloud and help you learn the best practices for deploying software as a service, platform as a service, and infrastructure as a service applications on AWS. Reach out to us to know more.